If you've been learning web scraping on your own, you probably know that the three main web scraping libraries in Python are BeautifulSoup, Selenium, and Scrapy. But which one is the best? Let's find out in this video. The first library we'll see is BeautifulSoup. BeautifulSoup can pull data out of HTML and XML files, and this library is the best choice for beginners. This is because BeautifulSoup is the easiest web scraping library in Python. You only need a few lines of code to scrape a website with BeautifulSoup, and it's also easy to set up because you only need to install the requests library and the BeautifulSoup library. And with this, you can start scraping a website. Unfortunately, BeautifulSoup doesn't have support for JavaScript-driven websites. This is a big disadvantage because nowadays many websites run JavaScript. Also, BeautifulSoup is inefficient and it has some dependencies that make it complicated to transfer code between projects. Next, we have Selenium. Selenium wasn't actually designed for web scraping. In fact, Selenium is a WebDriver designed to render web pages for test automation of web applications. This makes Selenium great for web scraping because many websites rely on JavaScript to create dynamic content on the page. So we can say that Selenium is one of the best libraries for scraping JavaScript-driven websites. Another advantage of Selenium is that it's easier to learn than Scrapy. Unfortunately, Selenium is slow. Web scraping with Selenium is slower than HTTP requests to the web browser because all the scripts present on the web page will be executed. However, if speed isn't a top priority, Selenium will be a good option. Finally, we have Scrapy. Scrapy is a web scraping framework built especially for web scraping and written entirely in Python. This is without a doubt the most complete web scraping tool in Python. Unfortunately, Scrapy is harder to learn than Selenium or BeautifulSoup. That said, one of the biggest advantages of Scrapy is speed. Since it's asynchronous, Scrapy spiders don't have to wait to make requests one at a time, but it can make requests in parallel. This increases efficiency, which makes Scrapy memory and CPU efficient compared to the previous web scraping tools. Also, Scrapy is the most complete framework in Python. You can easily store data in databases, create crawlers, and do more with Scrapy. So which one is the best? I would say every web scraping tool satisfies a specific need. For example, BeautifulSoup will be great for beginners. Selenium will be good for small projects that need to scrape JavaScript-driven websites, while Scrapy will be great for large projects where speed is priority. And that's it. In this video, you learned the differences between BeautifulSoup, Selenium, and Scrapy. Choose the web scraping tool that fits better the website you wish to scrape. In this course, we're going to use Python to scrape websites. To download Python, go to python.org, and when you're in this website, go to Downloads and then go to the option View the full list of downloads. Then the last version of Python for your operating system will show up. In my case, I have Mac OS, then I have the Python version for Mac. Now I click on Download and click on OK, and then wait till the file is downloaded. Once the file is downloaded, just double click on it and then click on Continue to complete the installation process. In case you're on Windows, make sure you check the box that says Add Python to Path. After this, Python should install successfully. To verify you have installed Python on your computer, open a terminal or CMD. To open the command on Windows, you have to press the Windows button with the letter R and then write CMD. And to open a terminal on a Mac, just press the CMD key and comma and then write terminal. Once you're on the terminal, write Python --version or Python 3 --version to verify the Python version you have installed. In case you see the version, it means that you successfully installed Python. Okay, now besides Python, we also need an editor. So we're going to use PyCharm in this course. So to download PyCharm, go to Google and write PyCharm and then go to the first option. Then you should see this website and here just click on download. Then you'll see the download PyCharm page. Here there are two versions, the professional and the community version. We're going to download the community version since it's free. Then you should choose the Python version that corresponds to your operating system. So I'm going to download the community version of Mac OS and then I'm going to click on download. So I click on download and then I wait till the file is downloaded. By the way, you can install any editor you want, like VS Code, Sublime Text, or any other. But keep in mind that I will work with PyCharm in this course. Anyway, the editor is not gonna make any difference for web scraping. So now that the file was downloaded, I double click on it and then I'm going to install it. Since I'm on a Mac, I have to drag the PyCharm icon to the applications folders to install. After this, you should see a new window and then just click on continue to install PyCharm. Keep in mind that if you're on Windows, you should check the boxes you see on the screen to install PyCharm successfully. Okay, now that I installed PyCharm, I'm going to open it. So I press Command Space to write PyCharm and then I open PyCharm. So now PyCharm is loading and then I'm going to create a new project. So I press on Create New Project to create a new project and then I can give the project any name I want. After you write the name of the project, just click on Continue and then PyCharm should load all the necessary steps to start a new project. So just wait a little bit and then you can see your projects folder on the left side. So I'm going to maximize this window and then I'm going to show you how to install new libraries. So first I'm going to create a new Python file and I'm going to set it to a random name and then I'm going to import a library. So I write import OS. This is the operating system library and it comes by default with Python. However, libraries like the pandas library need to be installed. One way to install it is going to settings or preferences. To open it on Windows, press Ctrl-Alt-S and on Mac, press CMD and comma. Once the window is open, go to Project Interpreter and then press on the plus button. After this, you should see a new window and here you can search any library you want. For example, I can search for the pandas or NumPy library and then click on Install Package to install any library. In PyCharm, you can also customize the theme. Just go to Editor and then choose Color Scheme and then you will see a list available. Choose the one you like the most. And that's it. Now you can start writing Python code. In this video, I'm going to teach you the basic stuff you need to learn in Python to learn web scraping. This is what you will frequently use when scraping a website, regardless of the framework you use in Python. So BeautifulSoup, Selenium, or Scrapy. So I assume that you at least know how to print a basic hello world in Python, so I'm not gonna show you how to do that, but we're going to start with lists in Python. So in Python, lists are used to store multiple items in a single variable. To create a list, we have to place the elements inside square brackets, separated by commas. So let's create a list of some states in the US. So I'm gonna write states and I'm going to set this equal to, I open square brackets, and now I'm going to write 4 states. So first I write California, then the second is going to be Texas, the third is going to be Florida, and the last one is New York. So these are 4 states and these are inside square brackets, so this represents the list and the name of the list is states. Also, all the elements are the same type, so they are string because we're using here double quotes to set this to strings. Now each item or element in the list has an index, which is the position in the list. Python uses zero-based indexing. That means the first element, so California, has an index 0, while the second, Texas, has index 1, and so on. To access an element by its index, we need to use square brackets. So this is how you do it. Let's say we want to get the first element. So we write state, which is the name of the list, and then square brackets, and write the position of the element. So in this case, the first position, so 0. Now if we print this, so I write print. To run this in PyCharm, we right click and then click on run, this one. So run, and then we get the first element or the first item, which is California. So now if we want the fourth element, we write number 3 because this is the element 0, 1, 2, and 3. So now we run and we're supposed to get New York, and yeah, we got New York. Another way to get an element by its position is using negative indexes, but in this case we're gonna get elements starting on the last position of the list. Also, instead of using indexes from 0 and above as we did before, we're gonna use indexes from -1 and below. So let me show you here. So let's imagine we want to get the last element. So far we got it with states square brackets 3, but if we want to index from the last position, we have to use -1. So let's test this code and run, and we still get New York. So this is -1, this is -2, -3, and -4. So let's try now with states -4. So it should be California. So let's see. And yeah, we got California. So why do we need lists for web scraping? Well, lists are necessary to store all the data scraped, so we can export it in a CSV file or JSON file later. Also, indexing is really important when we locate multiple elements with the same name and we want to select one in particular. For example, sometimes we locate multiple elements and we want to get the first or the last one. So we can use index 0 or index -1 to get to one of those. So now that you're familiar with lists, now I'm going to show you how for loops and if statement works. A typical step after storing elements in a list is looping through it so you can work with the elements. To do so, we have to use the for and in keywords. Let's print each element of the states list we created before. So first, I'm going to write for, then state in states. And here I'm going to write just state. So print state. So this is the syntax of the for loop. So we have for an element inside the list, and then in the body of the for loop we write print state. So this is the action, what we actually want to do with the element. Remember that for this for loop to work, you need to write the colon at the end of the for statement. So now I'm going to run this code, but first I'm going to comment this out. So we only get this result. So now right click and then run, and we got here the 4 states. So here we looped through the elements inside the states list, and then we printed each of them. Okay, that's it for the for loop. Now let's see the if statement. So the if statement works with a condition. If the condition is true, the body of the if block is gonna be executed. But if it's not true, it's not gonna be executed. Let me show you an example of this. So here I write if, and then I write a condition. So for example, if the state is equal to Florida, then, so I write colon, print the state. So now let me put this if block inside the for loop, so this makes more sense. So here I have this for loop. We were looping through the elements inside the states list, and then if state is equal to Florida, So when the state is equal to Florida, you print this. But if it's not, if it's California or if it's New York, don't print it. So as a result, we will get only one element printed. So now let me show you. I'm gonna run this script and let's see what happens. So yeah, in the results, we only got Florida. But this doesn't mean we didn't loop through each element. Actually, we're still looping through each element. But here, we only print the element that is equal to Florida. Okay, now let me tell you why this is important for web scraping. So, usually when you get elements inside a list. But you can't do anything with those elements unless you loop through it. Because when you loop through it, you get the element alone. So you can get the text, for example, or you can do anything else with that element. But if it's inside a list, you cannot do anything. You cannot get the text or any other attribute. So if we loop through it, we can get, for example, the text. It's usually what we want to get from the website, the data. So a typical step when web scraping is getting multiple elements inside the list, then looping through that list and getting the text inside the for loop. So it's something like this. Instead of printing this, we write a state that text, and this is how we get the text of the element. Anyway, I'm going to explain you this much better when we check Selenium or BeautifulSoup or Scrapy. So far we've seen how to work with the data we scraped. We imagine that this was our list that we scraped, and then that here we were working with each element scraped. But now it's time to show you how we're going to export the data we scrape. So first I'm going to delete this, and then I'm going to comment this out. I'm going to leave this here because we might use it. And here I'm going to show you how we can export data in Python. So there are different ways to export data in Python. And in this video, I'm going to show you two ways to do it. Okay, the first way is one of the simplest ways to export data in Python, and is using the with open as pattern. So before explaining you what this means or what this is, I'm gonna write so you can understand a bit better. So I write with open, then parentheses, then as, and here I'm gonna write a random name. So I write file, for example, and then column. So first, let's start with open. Open is a function that takes in a file name and a mode. So here you need here two elements. The first is a file name. So I'm going to write just a file name. And here it's the mode. And there are three modes: the write mode, the read mode, and the append mode. So let's start just with the write mode because it's the one we're going to use the most. And to use the write mode, we have to write W. So this is the letter for the write mode. Okay, what the write mode does is deletes the existing file content, creating the file if it doesn't already exist, and then allows you to write to the file. Here we're going to create a file name and we have to write the extension. So usually we create txt files, so I'm write just txt. So here in this write mode, I'm going to create a txt file name, and here I'm going to write test because I want to do a test. So this is going to be a test and this is going to be a txt file. So this is going to be the name of the file we're going to create, and also this file is going to be created in our current directory. So basically in the directory where this Python script is located. Now the with is a useful keyword that helps us manage two related operations that need to be executed as a pair. So for example here I'm gonna open this, and then here in the body I'm gonna do another operation. So for example I'm gonna take this file, and what I want to do is write a message. So I do file.write, and inside, let's say I want to write data successfully scraped. So with this with, we can handle 2 or more operations. And also, we don't even need to close this file that we opened, because after you open a file, you need to close it, but we don't need to do it because we're using this with keyword, and this will help us close it as soon as we leave this with block. Okay, and then the as keyword is just a way to rename this expression. So instead of writing this again, we just replace it for file. So this is represented by the file. In here, we can reuse the file to do some operation here as we did. So now I'm gonna right click and run this script so we can see what we get. So here we didn't get anything because we didn't print anything, but we only executed this code here. So this is gonna create a new file named test, and it's a text file because it's txt. So this file should be located in our current directory. So I'm gonna open this here on the left, and here, as you can see, I have a new file named test, and I'm gonna double click on it, and here I got this message that I wrote before, and it's data successfully scraped. So our code worked. And now I'm going back to the script here, and I'm gonna show you the second way to export the data. So in the first way, we didn't need to install any third-party library. We just used the built-in with keyword and the as keyword and open function, but we didn't install any third-party library. But for the second way, we have to install the pandas library. So I'm gonna comment this out. And now to install a library, you have to go to the terminal or command prompt, and then you have to write pip install pandas. So I'm gonna show you here how you can do it in PyCharm, because in PyCharm we have a terminal too. So it's in the lower left corner. So here it's the terminal button, and now I'm gonna click on it. So here we have the terminal, and here you can install any library. So I'm gonna write pip install and then the name of the library, which is pandas. So I write pandas. Then you press enter and run that command. So I immediately got a message, and it says that I already had this installed. So it says requirement already satisfied. In your case, you have to wait a couple of minutes or maybe some seconds for this to install correctly. Okay, now I'm gonna close this terminal, and to use this library, first we have to import it. So we write here at the beginning of the script, we write import pandas. And here, usually you rename these pandas as PD. So we use the as keyword and write PD. So instead of writing pandas, the next time we only have to write PD. Okay, now to easily create a data frame, we will need to put the lists we created before into a dictionary. So first, apart from this states list, I'm gonna create a second list named population. So I'm gonna write population, and now I'm gonna paste the data of the population of each state. So here I pasted the data of the population of each state. So this is the one of California, and this is the one of New York. So now I'm gonna put the states and population lists inside a dictionary. So I'm gonna create this dictionary, and I'm gonna name it dict_states. So now to create a dictionary, we have to use curly braces. So we open curly braces, and now the syntax of a dictionary is a key, then colon, and then the value. So let me show you here. First, the key, which should be inside quotes. So first, my first key is going to be the states. So I write states, then colon, and then the name of the list. So we write states. This is my list. So this is the key that I want to create, and this is the value, which is the list that it's here. It might look redundant because both have the name state, but they are different. One is the value and one is the key. So now I'm going to create the second key. So I write population, and then I'm going to write the name of the list or the value. So population. Here I wrote the key in capital letter, so we can differentiate the key with the list, but actually you can even write the same name. So here population and here states. But just to differentiate them, I just capital letter. So these keys are unique, so you can create another pair of key value with the same key. And these dictionaries also help us better manage the lists in Python. So now it's time to create the data frame. So to create a data frame, we write PD, which is pandas, as I told you before. Then we write that, then data frame, and then we use the from dict method. So basically we're saying PD, we're getting the data frame, and we want to create a data frame from a dictionary. So here we only have to copy dict states and then paste it inside parentheses. And then we have to name this data frame. So I'm going to write equal to, and here df, so stands for data frame, underscore states. So this is my data frame, and now I'm gonna print it. So print df underscore states, and now let's see the output. So I run this script, and now we have a data frame, and here we have the states list in the first column, and in the second column we have the population list. So this has the format of an Excel spreadsheet, and we can even export this data frame to a CSV file. So to export it, we only have to write the name of the data frame, in this case df underscore states, and then use that to CSV method. So we write that to, and then underscore CSV. Then we open parentheses, and inside parentheses we write the name of the CSV file we want to create. So we have to give it a name. In my case, I'm going to name it states.csv. You have to include the format of this file. So in this case, .csv. So now I'm going to comment this out, and we're going just to execute this code. So right click, then run this. Now in our current working directory, we should find a file named states.csv. So I'm going to close this one and open here, and here I have the states.csv file. So I'm going to double click on it, and we have the CSV file inside of PyCharm. So it's here, it's the states column and the population column. These numbers 0, 1, 2, and 3, they are just the index. Data frames work with index, and in case you don't want to export the index, you have to set it to false. So here you go and add the argument, and you write index and then set it to false, and just the same process, run this. I'm gonna close this so it's updated hopefully. So I'm gonna open states.csv, and as you can see here, we don't have the index anymore, but only the data with the states and the population. So now I'm gonna close this one, and we're back to the script. Okay, so far we've seen how to work with data and then how to export that data. That should be enough to get you started with web scraping. But now we're gonna see how we can handle an exception error. Exception errors are typical in web scraping. When scraping a website, you will come across different exceptions. For example, sometimes the element might not be in the DOM, or the element might not be visible yet, and so on. So to handle these exceptions, we're going to use the try and except statement. So here I created a new script, and here I created a list named new underscore list, and this has 4 elements. So the first 3 elements are numbers or integers, and the last one is a text or a string. So this is the first time we see a list with different type of elements. Before, we've seen a list only with integers or only with strings, but now we have a mix. So I created this list in purpose so I can show you an error that Python can throw when you work with different type of elements. So I'm gonna do a for loop. So I'm gonna loop through this list. So I write for element in new list. So we're going to loop through each element in this new list. And then I'm gonna print element divided by 2. So this is gonna break when we get to California because 2 is a number, so we can divide it by 2. The result will be 1. Then 4, it'll be the same, 6 the same, but with California, you cannot actually divide a string with a number. So Python should throw us an error if we do this. So let me show you here. I'm gonna run this and let's see what happens. And here we got an error. So it was fine in the first iteration, in the second, the third, but in the fourth iteration we got an error that it says unsupported operand type for slash. So it's string and integer. So we can mix this in a division. So here it's not a big deal if we made this mistake because we can easily fix it. However, when scraping a website, if we leave the code as it is, we will be able to store and then export the data because the code will break completely. This is why we have to use the except statement to let Python know how to handle an exception and then skip to the next iteration. So now let me show you how this works. So we have the try and the except keywords. So let's start with try. We write try, then colon, and here we have to indent this. So in the try block, we execute the same operation we want to make. So far it's fine. It's just what we did before. We just added the try statement, but we will still get the error. So to handle this error, we have to use the except statement. So in the except statement, I'm going to write a message. So I said print and then write the message, the element is not a number. So Python will execute the code following the try statement as a normal part of the script. However, Python will only execute the code following the except statement when the code runs into an error. So just when the code runs into an error, this except block will be executed. So I'm going to run this to show you this in action. So I right click and then run, and now we didn't get an error. So let's see what happened. So first, 2 is a number, so 2 divided by 2, 1. Then 4 divided by 2, 2. And then 6 divided by 2, 3. So far we just needed that try block because it's working fine. We don't get errors because we're making an operation between numbers. But here in the last element, we are supposed to get an error here. So what Python is going to do is to go to the except block. So it goes here, and instead of throwing us an error, we're going to get this message. So it's going to print this message that says the element is not a number. So this is what we got instead of the error message. So although the fourth element isn't a number, the code didn't break. And this is good because when we scrape a website, we don't want the code to break just for one single element that maybe wasn't correctly scraped, or maybe the data was corrupted, or something weird happened with a specific element. So we don't want this to break just for one element, but we want it to pass to the next iteration, so at least most of the data will be correctly scraped. We're going to use this try and except statement a lot in this course, so try to remember this. Okay, the last thing we're going to see is the while break statement. This is basically part of a workaround we use when there are some limitations in the scraping tool we're using. So when a web scraping tool lacks some functionality, you have two options. Either you learn from scratch how to use another scraping tool, or you can find a workaround. A good example of this is pagination. Scraping through multiple pages can be easily done on Scrapy. However, on Selenium and BeautifulSoup, you might need to use the while loop. Here is the format of the while loop. So here I wrote while, which is the keyword, and then we have an expression, and this represents the block to be repeatedly executed. This is evaluated in Boolean context, so it can be true or false. If it's true, the body is executed, so we're going to execute this statement, and then we're going to check the expression again. But if the expression becomes false, the execution proceeds to the immediate code below the while loop. So for example, if we have here print, and here we have like a message, I want to write message. So if this is false, this is not gonna be executed, but the immediate code below the while loop, so this is gonna be executed. So now let's see an example. So I'm gonna create a variable n, and this is gonna be equal to a number. So just a random number 4, and then I'm gonna write an expression here. So this has to be a Boolean. So I write and greater than 0. And then on the statement, I print this n, and then I do the following. I'm gonna decrease the value of this n in 1. So I write n equal to n minus 1. So on each iteration, this 4 is gonna be reduced by 1. So first it's gonna be 3, then 2, then 1, and then 0. And when it's 0, this is gonna break and we're gonna get this message. So let's test this out. I'm gonna right click here and then run this script. So as you can see here, we got the value 4, 3, 2, and 1. And then we didn't get the value 0, because when n got the value 0, here 0 is not greater than 0, but it's equal. So here this expression was true and it became false. So when it became false, the while loop was broken, and then the immediate code below the loop was executed. So we printed the message. So here we have the message instead of 0. Now another way to break this while loop is using the break statement. So I'm going to add here a if condition, and it's going to be if n is equal to 2, then break. So now this is going to be similar as we did before, but now this is going to stop when n gets the value of 2. So in this case, I'm going to change the message. I'm going to write loop ended. And now I'm going to run this code. So we test this out. And here we only got the value 4 and 3. So let's check what happened. When the value was 4, here it was printed n, so 4, and then 4 minus 1, 3. And then it went to the next iteration because 3 is different from 2. So now it's 3, 3 is greater than 0, and here printed 3. So we got here 3, and then 3 minus 1 is 2, and 2 is equal to 2. So we executed this break statement, and with this, all this loop was ended, and we got this message here. And we didn't get a value of 2 because before that iteration, this while loop broke. And that's it. Now you know the basic stuff in Python to learn web scraping. So now you can learn either Selenium or BeautifulSoup or Scrapy. But make sure you also watch the HTML basics video in this course so you don't have problems when learning web scraping. In this video, we'll learn some HTML basics that will help us when scraping a website. HTML stands for Hypertext Markup Language and is one of the most basic tools used to build websites. It defines the meaning and structure of web content. Although we're not going to build a website in this course, it's important for us to get familiar with the basics of HTML. This will help us understand the code behind a website. As a result, we will be able to find the best approach to scrape a website and get the data we want. Now let's review the HTML markup syntax. The first element in purple we see on screen is the tag. They are hidden keywords within a web page that define how a web browser must format and display the content. Most tags must have two parts, an opening and a closing part. For example, the H1 tag is the opening tag, and H1 with the slash is the closing tag. Note that the closing tag has the same text as the opening tag, but has an additional / character. A few tags like the img tag, that stands for image, are an exception to this rule because they don't need a closing tag. There are plenty of tag names, and we'll review the essential tags for web scraping a bit later. The second element we see is the tag attribute. Attributes allow us to customize a tag and are defined within the opening tag. For example, the H1 tag contains an attribute named class. Attributes are often assigned a value using the equal sign. The attribute value in this example is title. Finally, we have the affected content, which is what we usually see in a website. It can be a text, for example, like a title of an article. It's called like that because it's affected by the tag and attributes defined. So all of this is known as an HTML element or node. Great. So far, we've learned some of the basics of HTML. Now it's time to see some of the most important tag names for web scraping. So let's start with some of the most common tag names. The first is the head tag. This represents the head section, and it's used mostly for metadata. Then we have the body tag. This establishes the body of an HTML document. And the third HTML tag you see on the screen is the header tag, not to be confused with the head tag. The header tag typically contains introductory content and layout that goes above the body. Let's see these three tags in action in a website that we're going to scrape later in this course. First, let's inspect this website. So right-click and select the Inspect button. After this, you should get the HTML code of the website. So scroll up and go to the head tag, as you can see on the screen. So this is the head, which doesn't represent anything at all, but if you go to the body, you'll see that all the website will be highlighted in blue. And then if you select the header, you'll see a section of the website highlighted in blue, which is where the logo goes. Next, we have the article tag. This tag is new in HTML5, and this tag can be used to contain blog entries, posts, etc. Then we have the p tag, which encloses paragraph in an article. And then we have the H1, H2, or H3 tag, which are level headings. So H1 is level 1 heading, which is the headline or title of a page. And H2 is the level 2 heading, so the subtitle of a page, and so on. In this website, we can see the article tag, the H1 tag, and the P tag. So the first contains the whole article, and H1 contains the title of the movie. And finally, the P tag contains the plot of the movie. The following tags you're going to see really often when scraping websites, and you should at least recognize them to find the best way to scrape a website. First, there is a div tag, which is a divider or a kind of generic container. Then there is the nav tag, which is used for specifying a navigational region within a document, like the pagination bar. Then we have the li tag, which represents a list item with an order list or an order list. And then we have the A tag, A for anchor, also known as hyperlink or simply a link. To make an actual link using the A tag, we use the href attribute. For example, in this website, we see many movies listed in a table. We see that this is inside a UL tag, which contains a tag, which is the anchor, and inside it is the li tag, which is the list item tag. As we can see, the A tag has the href attribute that contains the link that redirects to another page. So now you can see how they relate to each other in this HTML document. Let's see the last 6 tags I listed here. So first we have the button tag. So this one specifies a button that can be clicked. It's commonly used with forms. Then we have the table tag that is used for making tables in an HTML page. Then is the TD tag, which stands for table data. This represents a data cell within a table. Then we have the TR tag, which stands for table row element. This tag defines a row of cells in a table. And then we have the UL tag, which is an order list. This one is used with the li tag to make an order list. To see these last tags in action, let's check this website that contains data inside rows in a table. So as you can see, here we have the TR tag, which represents a row, and then we have the TD tag, which represents each element of data. Then I scroll up and I got the table tag, which is the whole table that contains a group of data. The last tag I want to show you is the iframe tag. This one makes it possible to embed another page within a page. In HTML5, this is known as nested browsing. This iframe thing makes sometimes web scraping a little tricky. So sometimes you have to switch between one frame to another frame. But that's not in all the websites. So you have to recognize whether the website you're scraping has multiple iframes or everything is contained in just one iframe. Before we start writing some code, let's review some HTML basics first. Here's the website we're going to analyze. I chose this website for its simplicity, so you can successfully scrape your first website. The website has 3 main sections: the title, the plot description, and transcript. Now let's have a look at its HTML code. Here I wrote a short HTML code version of the website that contains transcripts of thousands of movies. Now, if you've never seen HTML code before, you could still recognize some text elements like the title, description, and transcript. In this case, we're looking at the transcript of the movie Titanic, so that's why the title is there. Besides that element, something you will always see in HTML code are tags. Tags are those words surrounded by brackets. There are opening and closing tags. For example, in this HTML code, we have 4 tags: article, h1, p, and div. Each of them represent a node, and we'll see them in detail in the following tree structure. The tree structure will help us come up with effective ways to scrape a website, and also will be the foundation for XPath that we'll use later in this course. Now let's start building this tree. The first element of the tree is the root. In this case, the root is the article element. As we've seen in the HTML code before, this article tag has an attribute called main article. This root element also contains the h1 tag that contains at the same time the text Titanic, which is the title of the movie. Another element inside the root is the p element. In this case, this has an attribute and a text. The attribute is named plot, and the text is the plot description. Finally, we have the div element. This element has also an attribute called full script and text with the transcript of the movie. All the rectangles you see on this tree are called nodes. Every node has exactly one parent, except the root. The h1 node's parent is the article node. Siblings are nodes with the same parent. An element node can have 0, 1, or several children, but attribute and text nodes have no children. For example, P and div have two child nodes, but no child elements. Now, something very important in this tree is the attribute element, because they will determine the approach to take to scrape a website. In this example, you see only classes like main article, plot, and full script. However, you can also find IDs and others. As a rule of thumb, we'll follow these priorities to find an element. First, we're going to look for the ID because they are unique, which means that we'll always find an element by the ID. Then we'll go for the class name, then the tag name, and finally the XPath. But we're not going to use XPath for BeautifulSoup, for example, because they don't work on BeautifulSoup. Now it's time to start scraping our first website with BeautifulSoup. So the first thing we're going to do is to import some important libraries. So the first library we're going to import is request, or requests in plural. So this is the first library, and the second library we're going to use, it's called BeautifulSoup. It's from BS4 import BeautifulSoup. So in case you don't have any of those libraries installed on your computer, you have to open a terminal. In this case, I'm in PyCharm, so I have the terminal inside PyCharm. So I'm going to write pip install and then the name of the library you want to install. So you can open your command or your terminal or just inside your text editor or IDE and install this library as I'm gonna do it. So first BS4, so pip install BS4, then I press enter, and here it says that it's already satisfied because I have it installed already, but in your case it's going to install all the dependencies. So now I'm going to install requests. So I'm going to clean this first, and now I'm going to write pip install requests. So it's the same process. It's going to download the dependencies and install this library. So now we have to install one more thing, which is the parser. BeautifulSoup relies on a parser to get this HTML code. So the parser we're going to install, it's called LXML. So I'm going to write pip install, and I'm going to paste this, and this is basically the parser we're going to use. If you want to install other parser, you can do it, but we're going to do just a basic scrape, so it's going to be enough with LXML. So I'm going to press enter, and it's gonna tell me that it's already installed, and that's it for the libraries. So just a recap, BeautifulSoup is the name of the library we're going to use to scrape. In this case, it's the first tool, the scraping tool we're going to use to scrape a website. Now, request, this is basically how you send requests to a website, to Google, for example. So you send a request and Google is supposed to send a response. And that's where the HTML code comes from. But we need to use a parser because this BeautifulSoup doesn't have like its own parser, so we have to add it. And that's it. In the next video, we'll start scraping our first website with BeautifulSoup. In this video, we'll learn the basics of BeautifulSoup. BeautifulSoup is the easiest Python library used for web scraping. It can pull data out of HTML and XML files. However, BeautifulSoup has some dependencies, such as the need of the request library to make requests to the website and the use of external parsers to extract data. For example, XML and HTML parser. These dependencies make it complicated to transfer code between projects. So this is why BeautifulSoup is not the first choice for large web scraping projects. To scrape websites with BeautifulSoup, we have to import two libraries. First, import BeautifulSoup from BS4 and also import requests. Now, some of the typical steps to follow to scrape a website with BeautifulSoup are fetching the page, obtaining the page content, and then creating a soup. To fetch a page, we have to write requests.get and in parentheses write the website, for example, google.com. When you send requests to websites, you get a response. In this case, I name it as a result variable. Then to get the content of this website, just write result.text. With this, you will get the HTML code behind the website. Finally, we have to create a soup object to locate elements with BeautifulSoup. To do so, we have to parse the content. So in this case, I'm using the LXML parser to parse the content. After this, you should get the soup object that will help us locate any element we want. For example, if we want to locate an element by the ID, we write soup.find and inside parentheses, we specify the argument ID. And inside quotes, we write the ID value. Now, if we want to locate an element by the class name, we write soup.find and inside parentheses, the first argument should be the tag name. So we write the tag name inside quotes and the second argument should be the class name. So we write class underscore equal and then inside quotes we write the class name value. Now to see some examples, let's check this basic HTML code we've seen before. So it has an article as root and h1, p, and div as child elements. Let's say we want to locate the article element by its class name. So we should write soup.find and the first argument should be article because that's the tag name. And the second argument should be class underscore equal to main article because that's the class name. Now, what if we want to locate the h1 element? It doesn't have an ID or a class name. Anyway, we can still locate it writing soup.find and inside parentheses only specifying the h1 tag. So in case you don't have the ID or the class name, you can still locate an element by its tag name. Now, if we want to locate multiple elements by its tag name, we have to use find all instead of find. So let's imagine we have multiple h2 elements. So we can locate all of them writing soup.find underscore all and inside parentheses h2. Keep in mind that find underscore all returns a list, while find only returns an element. This happens because find all obtains multiple elements, so all the elements will be stored in a list. To work with those elements, probably you'll have to use a for loop. And that's it. Now you're ready to start scraping websites with BeautifulSoup. In this video, I'll show you how to get the HTML from a website using BeautifulSoup. So as we've seen before in the theory of the basics of HTML, this website has like many transcripts of movies, and the structure of each transcript, it's what you see now on screen. It starts with the title. In this case, this is the movie example, Titanic. Now, then it has the description or the plot description. This is what the movie is about. And finally, and the most important thing, is this transcript, which is really long because it's what the actors said on the movie. It's the 2 hours or maybe 3 hours of the movie in text. So this is really important information if you want to do some other projects like sentiment analysis, or you want to do some NLP, or you want to train your machine learning model. Anything you can do with this text information. But first, of course, you need to scrape it. So we're going to scrape, in this case, just the title and the transcript because I think both are the most important information. But anyway, it's the same way to scrape the description. So now let's go back to the editor and let's write some code. So I'm going to start writing the name of the website. So I defined a variable which is website, and now I'm going to copy and paste the link of this website. So I use copy and paste it, and we have the website. Now we're going to send a request to this website. So we're going to write requests, and then we're going to write that get. So we're going to put the variable website inside this get. So this request is going to give us a result. So I'm going to write this result variable, and basically this is what we're going to get after we send this request to the website. So once we have this, we can get the text of this result by using the method text. So basically this is how you get text in BeautifulSoup. Just text, but I'm going to show you another way later how to get text too. So now we have the content because we have the result of the request and we have the text. So we can say that we have the content of the website. So I'm going to write the word content here. Now I'm going to define the soup. The soup is what we're going to get after we use the parser. So I'm going to write now here, or I'm going to copy BeautifulSoup, and now I'm going to write content. And now I'm going to indicate which parser I'm going to use. So as you remember, we installed LXML. So I'm going to write this LXML. Now what we've done so far is basically get the HTML code. So here we had the content of the website, and here we had to use the parser to get the code using BeautifulSoup. So now we can print this result. We can print this soup. So I'm going to write print and now soup and that prettify. Prettify is just a way to make your HTML code look nicer, good looking. So it's just for that. So I'm going to run this code and we're going to see the results. Now Python just printed the HTML code and we can see it below here on the bottom of the screen. So here I'm scrolling up to get to the top of this HTML code because it's really long, because as you've seen before, that transcript, it's really long of this movie Titanic. So I got here to the top and we can see the HTML code. And that's it. You just learn how to get the HTML from a website using BeautifulSoup. So now we can get not only the code, but we can get the data that we want. Before we get into it, I'm going to show you just what we've seen before in the three element that we've seen in just some minutes ago. So I'm going to write article and hopefully I'm going to find the HTML code that we've seen before, and it's here. So as you remember, we had before this code that I wrote you on screen, a bit bigger, but now it's in HTML code, and it's here. It's the complete code. So before I wrote just this part. So I wrote this article h1 and the p, I think, and also div that it's below. It's here with full script. So that's what you usually will find in real websites. What I did before, it's like an introduction. So you have to get familiar with this HTML code, but don't be afraid because we're not going to use all this HTML code, but we're going to go just to the part we're interested in. So I'm going to show you how to go to those nodes we want to get data from. So now I'm going to close this HTML code we printed and we're going to go to the website. So now we're here on the website, and to get to those nodes we'll have to right click and then click on the word that says inspect. So we have to click on it, and now we get the HTML code of that part. So for example, we inspected the title, the Titanic title. So we get this part. So as you can see, if I go down, it highlights other sections in blue. And basically it's how it works. It's really simple. So now if we want to locate an element, we're going to use that list that I told you before with those priorities. So if you remember, it started with ID, then with class names, then tags, and finally XPath. So now we have that class name. So we're going to start with this root that it was the root of our tree before, and we're going to locate it first. So I'm going to copy this main article, and I'm going back here to the code, and I'm going to write soup. Once we write soup, we can find elements. There are two options to find elements. We can use find or we can use find all. In this case, since I want to get just one element, I'm going to write find. So once we have this, we have to indicate the name of the tag of that node. So here the name of the tag is article. So I'm going to write just article. And now we have to indicate the attribute. So I'm going to write class and now equal to and now main article. So this is basically how we locate this section. Yeah, because this is the root, as I told you before. It's a way just to have a reference, because this is not giving us the title or the plot or the transcript. It's just locating like a reference for this data we're going to scrape later. So now I'm going to name this as a box. I'm going to say that this is a box, and it's gonna be my reference. So one thing that I almost forgot to tell you is this underscore. In Python, we have to indicate every time we write class here, we have to add this underscore, because in Python we also have classes. So in order to differentiate both, we have to add an underscore. It's just that, nothing more. So now we have this box as a reference, and we can now locate the title and the transcript. So first I'm going to locate the title. So to locate the title, you can easily go straight here, or let's imagine that it's not so obvious. So we can use one little trick here in the left, and it's this button. So I press here, and we can also get automatically the code hovering on the section we want. So here I'm hovering on the title, and immediately the name it highlights in blue here below. So I get here the H1 Titanic, and this is what we want. So here we have only the tag. We don't have a class name, we don't have an ID. So we're going for the tag, and it's the only data that we have. So I'm going to copy this H1, and I'm going to write here soup.find, open parenthesis, and then H1. And now to get the text, we write get underscore and text. And now we write the parentheses, and that's it. That's how we get that text in that H1 node. One more thing here that we can do is, instead of using soup, we can use the box reference just to exclude anything that it's outside of that box. So now I'm going to give it a name. I'm going to name it title and then equal, and I'm going to print this so you guys can see how it looks like. So I'm going to write print, and I'm going to write title. So now I'm going to print this, and it should say Titanic. So let's see. Oh, here it's the prettify here. I'm going to run it again. So we're going to see, and yeah, it's Titanic 1997 full transcript as it's here. So everything it's okay so far. So we're going to continue to get the transcript. Now to get the transcript, we're going back to the page here, and now we follow the same method. We're going to click here on this button, and then we're going to locate this little box here, and now we get the code. So I'm going to repeat just one more time if you didn't get it. It's just clicking here, then locating the element, and boom, you have the code. So now we have this div with class name full script, and this is what we want. So now again, the priorities are IDs, then class names or tag names, and XPath. So now we have class names and there isn't any ID, so we're going just with classes. So I'm going to copy this full script and then going back here, and I'm going to duplicate this code, and then here I'm going to write transcript. So now we don't want h1, but we want, let me see here, it's a div. So now we write div and the class, it's gonna be, yeah, full script. So this is the same structure that we followed before for title. I'm going to print this out. I'm going to write transcript and let's see what happens. So I'm going to write this code now, and now wait. So here's the title, and now here's the transcript. But there is one more little detail that I just omitted. Here in get text, everything is okay. Everything prints fine here on my editor, but I just tried this in Excel, and when you pass this information into other thing that is not the editor, this gets really messy, this data. So the problem is that if you want to put this information in Excel or inside a data frame, there is no space between these lines. So we're going to avoid this problem with two parameters in the getText method. So we're going to use strip and separator. So I'm going to write first strip true and then separator equal to space. So basically what strip does, it deletes trailing and leading spaces. So this means that if I have a word Python here with a space here and another space here, it means that this strip is going to delete this and this only in the beginning and in the end of the text. So only here in the start of the transcript here, and only in the end of the transcript here. So just in these two parts. But the separator adds a blank space, so it will replace a new line with a blank space. For example, right now, between the second and the third line, you can see a new line between the sentence, you should see it, and the word okay. If we include a blank space as a separator, you should see both of them in the same line. So let's run this script to see how the transcript will look with these changes we made. It's running now, so I'm gonna get to the top. And as you can see, the new lines were replaced with blank spaces. And that's it. In the next video, I'll show you how to export this data into a TXT file. In this video, we'll export all the data extracted into a TXT file. First, I'm going to delete that print, also close this thing. So to create a file in Python, we use the with, and we write with open, and now we write the name of the file. In this case, let's name it titanic.txt, and now we have to write the mode. So there is write mode or there is read mode, but since we want to create a file, we have to use the write mode. So we open this and write W. So now we have to write as, and then I'm going to write file. So far we have with open this txt file in write mode as a file. This is like the name of this expression we wrote. I'm going to add here the C, so it's Titanic. Now we write file that write, and inside this parenthesis we write the transcript. So I write transcript. We created a Titanic txt file, and then we name it file, and then in this file variable we just write the transcript. So as a result, we're going to get a txt file with the name of the movie and then with the transcript inside it. Here we can add one more thing to use this title variable. We can just add here an f string. I don't know if you're familiar with f string, but it's just like regular strings, but we can also add a variable. So here, instead of writing Titanic, we write title, and what we do is basically add a variable to this string expression. So before it was Titanic.txt, but now with this f string is title.txt, and the title name is Titanic. So basically this is like doing something like this. Let me show you in case you're not familiar. Title plus txt. Yeah, it's something like that. If you're more familiar with the plus sign, then maybe you can use the plus sign. But I'm using just here f string. But yeah, you can use the plus sign if you want to. So now I'm going to run this code and see the results. So now I'm going to run and see what happens. So everything run correctly. So this file should be created in the same directory where your script is now. So I'm going to here to my directory, and it's here. It's Titanic 1997.txt. So I'm going to double click on it, and inside it's all the text that we scraped. Congratulations! You just scraped your first website with BeautifulSoup. In the next video, I'll show you how to scrape multiple pages using BeautifulSoup. So far, we used the find method to get data from one article. But what if we want to get data from multiple articles? For example, here I have the same website but in another page because I want to show you a list of movies. So here it's a list of maybe 30 movies here. And what if we want to get the transcript of those movies? So here we can use find all to get data from all these movies, and we can also use a for loop. So I'm going to show you how to do this in this section. So we go back to the code because all the code that we wrote before is going to be the foundation for this new code we're going to write. So first I'm going to modify the code. Here we are in the movies page, so I'm going to copy here. This is subs like script page, but we're in the movies section, and now I'm going to copy. We're not in Titanic anymore, but we're in movies. Now we have the website. Now this is the same result, and we have the same content after we get the text. And then it's the same process. We get we use the parser to get the soup, and now we have this. So now I'm going back to the website to inspect this list. So I'm going right click on it and inspect. So let's see how this is structured. So the first thing I see, it's highlighted in blue, is this LI. For example, this is the first movie. Here, The Life of the Irish, and this is the first. So this is LI is inside a tag. So here we can see that there are many A tags, and each of them have LI. So what we can do here is to locate this LI to get a title, and then go to the website getting the href. So as you can see here, the href gives you the link of that website. So this is basically what we saw before in the Titanic website, but this is for each movie listed. Now back to PyCharm. So we press enter, and then we write this soup.find. So first I'm going to pick this this section that you see here. it's the main article, so we exclude everything that is outside this section. So first I'm going to copy this tag and soup find article and then the class, which I didn't copy. So I'm going back here and then main article, and yeah, I think it's the same here. It has the same structure. I didn't notice this. So as you can see here, we already have the box here. So I'm going just to delete this because it's already considered here. I'm going to delete this. So basically this is this, what I wanted to do. So this is my first box and it's article, main article. So box soup find article with class main article. So everything is fine so far. So now I'm going to get the href. So to get that, I'm going to get the a tag. So I'm going to write here box because this is my new reference. Here not equal but that. This is my reference as I said before. And now I write find. In this case it's find all because we have multiple A's. As you can see here, there is one A per transcript, movie transcript, and we go back here and write A. So if we wish to extract this href that is inside the brackets, we have to turn on href. So we write href equal true to activate the href. So now we have all the hrefs in this thing. So when you do find all, you get a list. When you do find, you get just an element. This is the difference between find and find all. Basically here, for example, or before, we did find just to get one element and we got just the text or something like that, just an element, a single element. But here we do something completely different. Even though it's just underscore all, this changes the output. So we get now a list. So this list, you can give it a name if you want, but in this case, I'm going to loop through it. So I'm going to do for link in this expression, and I'm gonna do something. So since this is a list, I can do a for loop and work with the content of the list. So now inside that for loop, I can work with the elements of this list. So I just have to write link. And for example, if I want the text, I write text, or as I showed you before, get text. But in this case, I'm not going after the text. I want to get the href. That's why I just said true here before. So I'm going to get the href, writing the square brackets, and then writing href. So now if we want to store these values, we just have to create a list. So I'm going to create a list that I'm going to name links. And now I'm going to store all of this by writing links that append and parentheses. So this is how you create a list and how you append elements to this list. So just recap here, we just find all the hrefs, or sorry, find all the a tags, and then we activated href so we can get that element from it. So then we looped through it because this is a list, so we can loop through a list. And once we are inside that loop, we get the href. So we just have to write link followed by square brackets and inside it href. And then we just create our links list and append each element or each href to this links list. So now I'm going to print the list links just to show you how it looks like. So let me see, it's not link but links. So now everything is set, and let's see how it goes. So I just run and we got all the links. So here we had a list as we said before, and inside this list is the link, but as you can see here, we don't have the whole link, but we have just a part of it. So I'm gonna show you here. As you can see here, again, this is not the whole link, but it's just one part of it. So as you can see here on the top, the name of the link is soupslikescript.com and then /movies. So the root of the link is soupslikescripts.com and the rest is the views. So this is like one view and this is another that corresponds to another transcript. So this is just giving us part of that link. So we have to complement this with the root of the website because we only have this and we have to complement it with this. So we can easily do this with Python. So let me show you how to do it. I'm gonna write here, instead of website, I'm gonna write root and I'm gonna write here this. So I'm gonna put this in a string, and now instead of writing here, I'm going to delete this and I'm going to create again an f string, and I'm gonna put inside it a variable which I name root. So I'm gonna copy here, so root, and I'm gonna add this slash. So what I did here is just use this root because this is the original website, the homepage, you can call it. And now for the website, I just added this /movies. So I can reuse this root variable for other things, like concatenating this root with the href. So as you can see, if we copy this, or much better if we only copy this here, and now we paste it here, let me delete this and now paste it here, we get the website. So that's what we're gonna do a bit later, but basically that's the whole idea. We have the root, we add this is the root that I'm highlighting now, I'm selecting now, and we only add the href with the slash, and we have the transcript. So that's what we're gonna build later. So I'm going back to the home page, and now I'm going back here to the code, and I'm going to close this terminal, and now I'm going to continue writing the code. So the first thing I'm going to do here is to loop through the links. So here we got a list of links that we printed before, and now I'm going to loop through it so I can get the transcript of each of them. So I'm going to write here for link in links. And now what we're going to do is to reuse the code that we wrote before. We wrote this code some minutes ago, and it's how we scrape the title in the transcript and all of this. So I'm going to reuse this. I'm going to press tab, and this is again the title, the transcript, and here we created the text file. This we did it before. I'm just reusing this code, and now I'm going to write here again this website and the result and the content and the soup, because remember that we are going to a new website or to a new page inside this subs like script website. So let me copy this here, and now I'm going to paste it, and now I'm going to edit this a little bit so it does what we want. And I'm going to start with the website because it's not root with the movies /movies, but it's root with the href that we got here before. So it's gonna be this, and instead of movies, I'm going to open these curly braces and I'm going to copy link, and paste it. So I open the curly braces and then I pasted this link here. So now we have this F string with the root here first, the slash that separates both, and link. So now we have the whole structure that we were talking about before, the root plus the href. So that's it. And then the same workflow, we request the website. Here request get website, what just we did before, and then just get a result, and then the text, and this is the content as you might know now. And now we have to use the LXML parser to get the soup, and then we get the title, the transcript, and we open the txt file. But one little thing here is missing, which is the box here. I just used it before for this code, but I'm going to use it again because in this new page there is the box too. If you don't remember, the box is this thing. I'm going to highlight it again. This thing here, we use it for the list of movies, but also it's in the title with the transcript, just as a reference, just to have it as a reference. So this is the box, and it has an article in the class main article. It's just a coincidence, I think, that they have the same box here, here, and here. So that's it. Everything is set. So now we're going to print this out so we see what it happens. Now I just print it, and we have this. And probably now Python is creating all these files with the respective title. I didn't print this, I forgot to print, but the result is gonna be on my directory. I'm going there right now. So I'm here, and as you can see, every second it's creating one new txt file with the name of the title of the movie. And now we just have to wait till everything is finished. If I'm not wrong, there are like 30 transcripts in one page. So we have so far 32. So that's it. 32, and here it's finished the process. Everything was correct. All of the txt files were created. So I'm gonna have a look to each of them, and we have just the title and the transcript here. So I'm going to open one of them randomly to check if everything was okay. So here the movie is called This Day 2021. It starts with yeah man, everything. And now I'm going here. So I said this stays here 2021. I'm going to open it so the title is correct. And here it starts, yeah, with the same. Yeah, man, everything is measured and all of that transcript. So this is the whole transcript, and that's it. Just learn how to scrape multiple pages with BeautifulSoup. In this video, you'll learn how to handle pagination with BeautifulSoup. Remember, this is a workaround. Pagination is easier to handle on Selenium and Scrapy. So in case this lesson feels a bit complicated for you, feel free to skip this lesson and learn pagination on Selenium or Scrapy. So far we learned how to scrape the title of the transcript itself, and then also we learned how to scrape multiple transcripts that are in a single page, like this list of movies that are here. But now what happens if we want to scrape a list of movies that are in different pages like this? Here we have like 92 pages, and what happens if we want to scrape all those transcripts contained in those multiple pages? So here we can use something called pagination, and this will help us work with different pages with BeautifulSoup. So let's go back to the code, and we're going to use again the same code that we used for the second part of this BeautifulSoup course. And now we're going to add pagination a new variable. So I'm going to write this here in the middle of the code, and now I'm going to inspect these pages. So just right click here, inspect, it's the same process, and now we get this one here, and we get a class that says pagination, UL class pagination. So I'm going to copy this UL, and then I'm going to write soup find, and then just UL, and then the class as well, and I'm going to copy pagination. So with this we have like the whole bar here, and now we can have also the content that is here. So as you can see, each number it's in a LI tag that I'm just highlighting right now, and we can get the total number of pages. So that's what we're gonna do here. So what I'm gonna do is copy again this LI, and I'm going to write pagination because this is my new reference, and now find all and open string and then LI, then again the class. As you can see, it's the same process, and then I'm going to copy page item. So copy and paste, and I'm gonna call these pages. This is my pages variable. So go back here to the page, and now let's inspect this 92 because this is the total number of pages. This is the number I want to get. So let's see what happens with this 92. So now I clicked on it, and now I had this. So this is 92, and we see that this arrow here, this right arrow, it says page item. As you can see here, I'm highlighting it now, so it's in blue. It's here, page item, and it has the same name, 92. So as we can see here, if we go to the last element, we get this little arrow here, but we don't want this. We want the number. So we have to get one element before the last one. So how we can do this in Python is this way. We write pages, and then we open square brackets and write -2. So basically what this means is don't get the last, but get one before the last. So this is -2. When you write minus, you start from the last position. So -1 is the last, and -2 is one before the last element. So now I'm going to write text to print this or to get the text. So now I'm getting this LI, and if I get the text, I will get 92, which is what I want. So this is going to be just equal to last page. So now I'm going to comment here pagination so you guys don't get lost. So this is basically the new section that we are writing, this one, pagination, and this is what we wrote before. So now this is only the new thing we wrote, and what we're gonna do is make a loop again like we did before, but we're going to see first the structure. So let me show you here very fast. So as you can see here, we have again the root, which is sapslikescript.com, and now we have a different view, which is movies letter -a. So this is the first page, but if we go to the second page, something will show up, which is a new structure. So this is the syntax of this website. Every time you go to a new page, this will show up, even in page 1. So I'm going to show you page 1, and it goes to the first page, which is this, the one we were before, and that's basically the syntax. So now we have to add this to our code. So first I'm going to change the website to this because we were doing something a little bit different before. We were in the movies view or the movies page, but now we are in the letter A because we want to get transcripts from letters. We are in letter A and then go from 1 to 92. So I'm going to copy this and I'm going to keep the root. So now everything is ready to make the loop because we have the root here and this movies letter A. So check here again, root movies letter A. So now we have just to complement this with this question mark page equal to 1. And this 1 is going to be part of the loop we're going to create. So let me show you here what I'm talking about with some code. So I'm going to write for page in range I to last page plus 1 and then colon. So here I just made a typo, it's 1 not I, and now here I have to add to make sure this is an integer, and now I'm going to explain you what I did here. So basically a range, it's a set of numbers that starts with one number and ends with another number. So let's imagine this is 1 and this is 10. So if we say range from 1 to 10, it's going to give us 1, 2, 3, 4, 5, 6, 7, 8, and 9. So basically what I'm saying is get from 1 to 92 plus 1. So this, if I just do 92, it's going to give me from 1 to 91 because that's how range works. So if I want 92, I do 92 plus 1. That's basically what I'm doing here with range. I'm going to write range so you can understand this much better, what I'm doing here. So it's just give me array from 1 to 92 in this case because there are 92 pages here. So that's it. So now I'm gonna repeat the process that we did before when we created the for loop before in those multiple pages. Yeah, you remember when we scrape all of this? We're gonna repeat that process. So the first thing we're gonna do is copy this from website to soup, and we're gonna paste this here. And why we do this is because every time we go to a new page here in the loop, we are looping through the 92 pages. Every time we go to a new page, BeautifulSoup has to read that content that it's there, so it can give you the result, and then you can get the soup, the correct soup for that page, right? So that's why we're doing that. So we have the website here, the result, the content, everything okay, but we have to modify the website. All of this is okay except the website because as I told you before, we have a new syntax. This is a new structure. So I'm going to write here the new syntax, and I'm going to use the root again, but now I'm going to change something here. I'm going to add the page. So I'm going to write page, and also I'm going to copy this. I'm going to copy actually everything so I have a good guide here. So just copy this, comment this out, and now I have the root, which is this root, and now movies letter A, and it's here, and now the question mark and page. So I'm going to write question mark, the page variable it's set, and now we have to add equal to 1. Oh, I'm sorry, I made a mistake. It's not this way, but it's page equal to page. It's just a little mistake. So basically this is question mark. I just was confused because of page, but this is question mark, and now page equal to, and then the number of the page. So page equal to the number of the page, which is a variable. Yeah. So this is just one of the disadvantages when you write the variable and you have here repeat it again. Just you can get confused, but I think everything is clear now. This is the number and this is the variable that has the number that we want. So I'm going to leave here just in case you want to check this out and compare it with this that has the same structure. Now we have everything set. This is the result, the content, the soup. And now we have to indent this code we wrote in the previous videos. So I press tab and I think this should do it. Now everything is ready for us to run this code, but I just realized something, that we have this website, that variable, that we can reuse it. So as you can see here, we have the root movies underscore letter dash a, and this is basically this. So we can reuse this, not use the root, but use the website, because we have all this structure already here. So I'm going to delete this here. So I'm gonna just erase this and write website here. So this is the same thing, just we made the code shorter by using the right variable. Something else I want to add here is that in this chunk of code that we wrote before in the last section that is working fine, we can add something just to handle some errors that could come up. So we can write the try except block, doing try and then tab and write here except. So let's imagine there is no transcript or no title here. In this chunk of code, we are in this view. Let me show you here. So basically in this code, we are in this page. This code represents this page. So what happens if the transcript that we're looking at, or the transcript that we're scraping, doesn't have neither the title nor the transcript? So that's gonna throw an error and that's gonna break our code. So we don't want that. So one way to handle that is with the try and except block, and we only write try this code, and then if something goes wrong, just pass. That's something we can do. So what this is gonna do is, if this goes wrong, just pass to the next iteration. So if one link is not working or doesn't have information, go to the next link. That's basically what it does. But something I want to add is I want to maybe print the links here just to keep track of them. And I'm gonna comment this out, and I'm gonna add here a message in case there is one link that is not working. So I'm gonna print the link, but I'm gonna also show a message that it's gonna say link not working. So we know that this is not working and needs to be checked, or just to let us know that something happened. Now before we run this code, I'm going to cut this and I'm going to put it inside, because this is supposed to create a file when this works. When it doesn't work, it's not supposed to create a new file. So I'm just going to include this creation of the txt file inside this try block. So now everything is ready for us to run our code. But for purposes of this video, I'm not going to run the 92 pages because that's too long. So I'm just going to take 2 pages. So for video purposes, I don't want to make this video so long with the 92 pages. So I'm going to write square brackets and then colon 2. This means that I want the first 2 pages. So it's going to give me the first and the second. Finally, before we run this script, we have to do a couple of changes. So the first thing we're going to do is to place this links list outside the for loop, because if it's inside the loop, we're going to create empty lists in every iteration. So we don't want that. So we're going to place it outside the for loop. So all the data is stored. The second thing we're going to do is to omit this website variable. Instead, we're going to include this f-string expression inside the request.get, so we don't repeat this website variable twice. And we're going to do this inside the other for loop, the nested for loop. So we're going to cut and paste it inside this request.get, so we don't have any problems when running the code. Now I'm going to run the script to create the text files. So I run the script, and now I'm waiting for the first text file to be created. So as you can see, now many files are being created, and in my directory I have the text file. So it's creating text files one by one, and I'm going to cut until the moment I have that 30 transcripts per page. So we're supposed to get 60 transcripts or 60 text files. So now all the text files were scraped. I got the message that the process finished, and I'm going to my directory, and as you can see, there are 60 items. So all the transcripts were scraped correctly. So I'm gonna check this out. I'm going to open up a text file, and I'm going to check if the transcript is the same as the one that appears in the website. So I'm going to the website, and now I open the same movie, and I'm gonna check, and yeah, it's the same transcript. So everything was perfect. And that's it. We just learned all the tools that BeautifulSoup offers you to scrape a website. In the next section, we're going to learn how to scrape JavaScript-driven web pages with Selenium. In this video, we'll learn how XPath works. XPath is key to easily learn web scraping with Selenium and Scrapy. So let's start. XPath stands for XML Path Language. XPath is a query language for selecting nodes from an XML document, but we can also use it to select elements from HTML pages. Another way to select elements from websites is using CSS selectors. CSS stands for Cascadian Style Sheet. So it's a language that was mainly created to style HTML web pages. CSS and XPath have some similarities in their syntax. However, in this course, we'll mainly see how to select elements with XPath because of its simplicity. Now, let's review the XPath syntax. With XPath, we can select an element by using the double slash, and then we write the element name. This is the most basic way to locate an element or node. For example, if you want to select all the h1 elements in an HTML page, we do double slash h1. This double slash is a special character in XPath that means pick a matching node that is located at any level within the XML document. We're going to see the meaning of this and other special characters in detail in the next video. Now we can select an element based on its position by using the square brackets. Let's imagine that there are two h1 tags in the page. You will pick the first, writing the XPath expression double slash h1 plus 1 inside square brackets, and you will pick the second h1 tag with double slash h1 and the number 2 inside square brackets. Now we can also specify the attributes, adding square brackets and writing inside the attribute name. This is the standard version of an XPath. It starts with double slash, followed by the tag name, square brackets, the @ sign, and the attribute name like class, ID, and so on. Then we write the equal sign, then quotation marks, and inside the quotation marks, the attribute value. This is how we build an average XPath expression. We can also use some functions to find specific values. For example, the starts with function will search for text at the beginning, while the contain function will search for text included inside an element. In this example, I included the contains function inside the XPath expression. So, as you can see, we have to include parentheses to wrap the attribute name and attribute value. We also have to use the comma to separate the attribute name and attribute value instead of the equal sign. You can also use the and or logical operators with XPath expressions. They should be placed inside the square brackets, and every time you use operators, include a parenthesis for each XPath expression. We'll see how functions and operators work in action using a small HTML code in the next video. Now it's time to test some XPath expressions with this small HTML code we've been using so far. I'm going to leave the HTML code I'm using with the link of this website in the description so you can play with it and understand how XPath works. So as you can see, this is a small HTML code of the Titanic transcript we've seen before. So this HTML code is going to help us understand what we've learned of XPath so far. So as you can see, there is the title, the plot description, and the small transcript I wrote. So you can test the XPath expression in that bar. For example, I'm going to write double slash and then write the tag name h1. So as you can see here, the result, it includes the h1 that is the title, Titanic 1997. And if I want the text, I can just write a slash and then text with parentheses. This is one way to get the text, but there are many ways to get text with Selenium or with Scrapy. I'm going to show you how to do it later. So now let's test some other XPath expression. So let's try the P, which is the paragraph tag. So now I write P and I get two results because I included two plot elements. Now let's try double slash div and now let's get the text inside it. So we get the transcript of this movie, which is just a small phrase of the movie. And now let's try some other expression. So I write double slash and P. So I get two results because I have two plots. So if I want to specify one element in particular, I have to open square brackets and inside I have to write the number. So for example, if I write 1, it means the first element or the first P element, which is the first plot that contains 84 years later. And if I write 2, it's the second plot that contains the text in the end, and that's it. So now let's write div to test the average XPath expression. So now I write the @ sign and then class and then open quotes and write full script. So this is going to be the XPath expression of the transcript element. So this represents the full script element and we just use the XPath expression with the div tag, the class attribute name, and the full script attribute value as we've seen before. So now if I want the text, I just write slash and text with parentheses and we just get the text. Now let's delete all the text values and just leave the sign elements of the XPath expression like the double slash, the quotes, square brackets, and the @ sign. So this is the bones of the XPath expression, and now I'm going to write the P tag, class, and now the value plot. So as you can see, I get one element because I just have one XPath with these conditions. And now let's test some logical operators. So to do so, I'm going to include parentheses and then copy this, write or, and then paste this expression. So I'm saying locate an element that contains the class plot or the class plot 2. So either one or the other. So as you can see in the result, I get two results that tell us that both elements satisfy these conditions. Now, if I write AND instead of OR, I will get no result because there is no element that satisfies both conditions. So let's now try the contains function. So I delete one XPath expression and now just one remains. So I'm going to write inside the square brackets the word contains. And instead of writing the equal sign, I'm going to replace it with the comma. As you can see, it says that at least it should have two arguments. So I'm going to replace the equal sign with the comma. So as you can see, I get two results because both elements contain the word plot inside the attribute name. So that's why I get two results. This contains function will still work if I change the XPath expression. So let's change the p tag for div, and also let's change the plot attribute value for script. So now I get the transcript element, which is the full script, and that's how you use the contains function with XPath expressions. And that's it. Now it's your turn to test any XPath you want with this HTML code. Now it's time to see some special characters that will come in handy when writing XPath. This lesson will be extremely useful to build robust XPath expressions that will efficiently locate any element we want. First, we have the single slash character. This one selects the children from the node set on the left side of this character. In contrast, the double slash specifies that the matching node set should be located at any level within the document. For example, if we write /article, we'll get any descendant node in the HTML tree. In this case, the root is the only that matches. Now, if I add /h1, I get the immediate h1 element, in this case, the movie title. If I add /p, I get the 2p elements, and if I add /div, I get the transcript. On the other hand, if we want to get the text, we should write text in parentheses. However, if we add only a single slash, we won't get the text we want because it's not the child node of article. So what we have to do is to write first the element that contains the text. For example, if we write /h1 before /text parentheses, we should get the title. Also, you can get the text using /text and parentheses because / locates an element located at any level within the document. Then we have the dot character. This specifies that the current context should be considered as a reference, so it refers to the present node. Then we have the double dots, which refers to a parent node. Sometimes it's difficult to find an element in a website, but if you find its children, you can use this special character to find the parent. Now I have a /h1 that matches the title. Let's see what happens if I add single slash and period. As you can see, I still get the same element because period returns the current node. However, if I write now period twice, the parent node will be returned. In this case, the parent node of h1 is article. Unfortunately, in this XPath playground page, you can't see it clearly. But if we go to the actual page and inspect it, then press Ctrl F to text XPath and write the same XPath. So first /h1 and then add that twice, you will see that only the article element, that is the parent node, will be highlighted in green. Now we have the asterisk character, which is a wildcard character that selects all elements or attributes regardless of names. As an exercise, try to guess what these characters mean together. You can pause the video to figure it out if you want. So these characters together select all the children nodes considering the current context. This means that all the children elements will be matched. So this is the opposite of that double dot character that gives you the parent node. Now let's test the asterisk character. If I write /article and then /asterisk, I'll get all the nodes inside article. So as you can see, there is the h1 node, the p node, and the div node that contains the transcript. Now as you can see, we obtain all the elements inside. Now if I add /text parentheses, I get all the text inside these elements. Finally, we have some characters we've already seen. So first, there is the @ sign, which selects an attribute. Then we have the parentheses that it's used for grouping an XPath expression. And the last one is the square brackets with a number inside, which indicates that the node with an index n should be selected. And that's it. You just learned many special characters. Use them wisely to build better XPath expressions. One of the reasons why we have to learn Selenium is because it allows us to scrape JavaScript-driven websites. With this, we'll be able to scrape websites with dynamic content. But how can we identify if a website was built with JavaScript? You could have a look at the website and check if the data is loaded dynamically. But a better way to find if a website runs JavaScript is inspecting the website. So let me show you. Here I'm on the Twitter website and I want to know if this website runs JavaScript. So I'm gonna right click and then click on Inspect. After this, you'll have the developer tools. And to know if this website runs JavaScript, go to the settings option that it's on the right. So here it's the button, so I'm gonna click on it. And then you're gonna see this preference tab. Then scroll all the way down and look for the debugger section. And inside debugger, you'll see a box that says disable JavaScript. So if we check on it and the website stops working or doesn't load all the data, it means that it runs JavaScript. So let's find out. So I'm going to check this box and then I'm going to reload this website. So I press enter and here we have a message that says JavaScript is not available. So apparently Twitter needs JavaScript to load all the data, but usually you won't see a message like that. So let me show you another website to test this out. So this is a second website and here you can see football scores. So to find out if this website runs JavaScript, the same steps, right click and then click on Inspect. Then we click on Settings, scroll all the way down and then we look for Debugger and then check on Disable JavaScript and let's find out if this second website runs JavaScript. So as you can see, the data doesn't load. It keeps loading but it won't find the data because this website runs JavaScript. It keeps loading but it won't display the data because this website needs JavaScript to load all this data. So as you can see, the website doesn't show you a message that needs JavaScript, but if you disable JavaScript, you won't be able to load the data. Let's check a third website to see what happens if I disable JavaScript. So this is a third website and let's see what happens if I disable JavaScript. So inspect and then we click on settings, scroll down and then we look for the debugger section. I disable JavaScript again and then we reload this website. So as we can see, the website doesn't display anything at all. So this is another behavior that websites that run JavaScript might have when you disable JavaScript. And that's it. These are 3 examples of how websites that run JavaScript will behave if you disable JavaScript. So whenever you want to know if you need Selenium to scrape a website, first disable JavaScript and then see if the website needs JavaScript to load the data you want. To scrape websites with Selenium, first you have to download Chrome driver and install Selenium. To download Chrome driver, just go to chromedriver.chromium.org and in the download section, you will find this page. Here you will find the current releases of Chrome driver and you have to choose the one that corresponds to the version of the Google Chrome you're using. To know which version is the right for you, just go to this three dots button on the upper right corner and click on it. And inside Help, click on About Google Chrome. Here you will see the version of Google Chrome that you have installed. So in my case, I have installed version 92. So I'm going back to the other tab and now I'm going to choose Chrome driver 92. But in your case, you have to choose the one that corresponds to your Chrome driver. So I click on Chrome driver 92. Then you'll see options for different operating systems. So you'll see Linux, Mac, and Windows. In my case, I have a Mac, so I'm going to download Mac 64. So I click on it and then it's going to start downloading the file. Once the file is downloaded, unzip the file and remember the path where you're leaving this file because we're gonna use this path later. Now it's time to install Selenium. So you can install inside PyCharm. So just open PyCharm and then go to the terminal located on the bottom. So click on it. And after that, just write pip install Selenium. And after this, just press enter. And after this, you'll have Selenium installed. Another way to install Selenium is just opening the terminal or the command prompt. In my case, I'm gonna open the terminal. And once you have the terminal, just activate your virtual environment and then write pip install Selenium. And press enter and then Selenium will be installed on your machine. And that's it. In the next video, we'll start scraping websites using Selenium. Okay, now that you installed Selenium, it's time to import the library. So we write from Selenium import WebDriver. So we just imported WebDriver from Selenium. This is what we're going to use to create a driver that will help us scrape websites. This is all you need to start with Selenium. So now let's create a driver. So first we're going to define the website we're going to scrape, and I'm gonna go to the website here, and this is the website. So here you can find data about football matches, and this is the link. So I'm just going to copy the link. We're going to analyze the best approach to scrape this website later, but now we just need the link. So I copy the link and I'm going to paste it here. Next, we have to define the path where we downloaded the Chrome driver. So I'm going to create a new variable called path, and here I'm going to open single quotes and I'm going to write my path. Actually, I copied the path before making the video, so I'm going to just paste it here, and I pasted it, and here as you can see, it's inside my downloads folder. So you have to locate your Chrome driver file and just copy and paste the path. Then we're going to define a driver variable, and we're going to set this equal to WebDriver.Chrome, and inside parentheses we're going to paste the path here. Now I'm using here .Chrome because I downloaded that Chrome driver, but if you downloaded, for example, Firefox, you should write here Firefox or Safari, but I recommend you to use Chrome since it works well with Selenium. So now I'm going to open a browser or driver doing driver.get, and now inside parentheses I'm gonna write the website variable, so website. So let's do a little recap here. We first imported the WebDriver from Selenium, then we defined the website, then the path where the Chrome driver is, and we created a driver which is going to help us scrape the website. So this is WebDriver from Chrome because we downloaded the Chrome driver, and now we're going to open a Chrome driver window with this driver.get. So now to show you this, I'm gonna run this script. So I'm gonna right click and then run to show you how this looks like. So this is running, and now it should open a window with this website. And now it's loading, and as you can see here, there is a message that says Chrome is being controlled by automated test software. This means that Selenium is behind this, so the code was successfully executed. Now, one more thing here. To close the browser or window we just opened with Selenium, we have to write driver.quit. And don't forget to do it every time you do driver.get, because you're gonna open a window, and if you don't close it, you're gonna have a lot of Chrome windows open on your computer. Finally, remember that you have to write this code every time you want to create a bot with Selenium. And that's it. On the next video, I'll show you how to click on a button using Selenium. In this video, you'll learn how to find elements with Selenium. In Selenium, we use the driver to find elements. This is similar to the soup object we create with BeautifulSoup, but with the driver, we can scrape websites that run JavaScript. With Selenium, we have different options to locate elements. We can find elements by ID, name, XPath, link text, tag name, class name, and CSS selector. Let's see an example of how to locate an element by its ID. To locate an element by its ID, we have to write driver.find_element_by and _ID. And inside parentheses, we have to write the ID name. The same happens for class names and other elements. We only have to write driver find element by class name, and within parentheses write the value. Now let's see some examples with this HTML code we've seen before. Let's say we want to locate the article, the title, the plot, and the transcript. So for the article element, we can use class names. So we write driver.findElement by class name, and within parentheses we write main article. We do the same for the plot and the transcript. We just have to change the value. For the plot, we write plots inside quotes, and for the transcript, we write full-script. Now, you can also locate elements by tag names. This is frequently used when you want to locate multiple elements with the same tag name. For example, rows inside a table. Now let's locate the same elements, but now by tag name. We're gonna locate the title, which is inside an h1 tag, the plot inside a p tag, and the transcript inside a div tag. So to locate them, we write driver.find_element by tag name, and inside parentheses we specify the tag name, so h1, p, or div. Now let's see how to find elements by XPath. XPath are sometimes the best way to find an element. If you use XPath to find an element, you can be certain that you will find it. To locate an element by XPath, we have to write driver find element by XPath. And inside parentheses, write the XPath syntax we've seen in previous videos. So as you might remember, you have to write /tag, open square brackets, at attribute name equal to the attribute value. As I mentioned before, there are other ways to find elements on Selenium, for example CSS selector, name, or link text. But XPath tag name and class name are used more frequently. In case you want to locate multiple elements on Selenium, you have to write driver.findElements in plural, so with the S. This is extremely useful when you want to locate multiple elements with the same class name or tag name, for example. Just keep in mind that when you use find elements, you'll get a list. The list will contain all the elements that you extracted. This is different from find element because find element returns a single element and not a list. Other things that you can locate with Selenium are dropdowns. You can even choose any element listed in a dropdown. And some other things we'll see in this course are how to log into websites and how to scrape dynamic websites using weights. And that's it. Now you're ready to scrape websites with Selenium. Okay, before scraping with Selenium, let's have a look at the website. So here we can see that this website has data about football matches, and we see that the data is stored in tables. So we see tables, and inside tables there are rows. And here we can see also buttons, so you can split the matches between home and away, or you can put them together in all matches. So if I click here in all matches, we don't have two tables, but we have only one table, and that's this button. In here we can change the country or the lake here and the year. So first what we're going to do is to put these two tables together. So we have one table per team. So for example, instead of having these two tables per team, we're going to have just clicking here, one table per team. So we're going to scrape all the tables that correspond to each team. So first, let's click here and then let's track the data inside the table. So let's start with the All Matches button. So to click on this button, we have first to inspect this element to see if it has an ID or a class name, or we have to build an XPath to locate it. So we have to locate this, and to do so, we right click and then click on Inspect. So I have here the developer tools with the HTML behind this All Matches button. And here we can see that there is no ID. And this class has a weird class name. And I think the best approach will be to locate this with XPath. So for example, we can use this analytics event attribute in this all matches value. Since the button is called all matches, I think this is gonna be a solid XPath. So let's build it. So first I press Ctrl F to build the XPath here in this find box. And now we have to remember how to build XPath. So as you might remember, to build an XPath, you have to write / and then the tag name, then square brackets, the @, the attribute equal to, and then quotes, and inside quotes, the attribute value. So let's write this. But first, I'm gonna copy these all matches. So remember these three elements: the label, which is the tag, the analytics event, which is the attribute, and the all matches, which is the attribute value. So let's write / then label, which is the tag, now square brackets, add, here I'm gonna write analytics dash event equal to, in here I'm gonna open single or double quotes, and inside I'm gonna paste the value I just copied before. And we finished building the XPath. And here on the right, we can see that the XPath matched one element. And this element is highlighted in green, so it's this one. And if we select it, we can see that this represents this all matches button. So we successfully built this XPath because it locates the element we wanted. So I'm gonna copy this XPath and then go to PyCharm. Now, to locate this element with Selenium, we have to use this driver, as I told you before. So we write driver, then find element. And as you can see here, there are many ways to find elements with Selenium. There are tag names, XPath, class names, CSS, IDs, but here we're going to use XPath. So I double click on it, and then I'm gonna open quotes and paste it. Now, remember that if you use here single quotes, you have to use double quotes here for the XPath. And vice versa. If you use here in the XPath single quotes, you have to use double quotes because Python is not gonna let you have the same quotes. So let me show you. If I write here double quotes and double quotes, it's not gonna work. So I'm gonna just change this and write single quotes here as it was before. And now I'm gonna create a new variable called all matches button. So this code is gonna be equal to all matches button. And this is how you locate an element with Selenium. So far so good. Now we're going to click on this button. So I'm going to write here all matches button. And now to click on a button using Selenium, we have to use the click method. So we write that and then click. Then click with the parentheses. And this is how you click on the button. Now let's test out this code. So I'm gonna run and let's see what happens. So I click on run and Selenium is gonna open the browser, and now it's going to press on this all matches button. So let's wait. Oh, okay, we couldn't see because I left this code here. I'm gonna comment this out so we can see the result. So let's do this again. I'm going to run this. So Selenium is gonna open the browser again, but in this time it's not gonna close the browser. So yeah, so here Selenium pressed on this button, and now we have just one table per team. So as you can see here, all the teams have just one table, and it's not split in home await anymore. So great. Now I'm gonna quit this manually, and now back to PyCharm. Okay, in this video you learn how to click on a button with Selenium. We just needed these 2 lines of code. On the next video, I'll show you how to extract data from a table using Selenium. So far, we learned how to extract data from a website, but now it's time to show you how to export that data into a CSV file or JSON file. To export data in different formats with Selenium, we have to use the Pandas library. Pandas will let us manage all that data inside data frames. You can think of a data frame like a spreadsheet on Excel. Pandas is a whole new library, but here we're going to learn just how to store data into a data frame. So first we have to install Pandas. So in case you don't have it, just open a terminal here inside PyCharm and then run pip install pandas. Then press enter. In my case, I already have it installed. And once it's installed, just write here import pandas as PD. PD is just a short name for pandas, so we can use it without writing a long word. So now to create a data frame, we're going to write PD data frame, and now we open parentheses. Now we can create a data frame from different ways, but since we already have lists, we can do it with dictionaries. So dictionaries are made of lists, and we can create a dictionary with curly braces. So here we have the parentheses because of the data frame, and here the curly braces because of the dictionary. And inside a dictionary, we have to set a key. So here we open single quotes and write the key. So I want first to create a date, and I'm going to write the date key, and inside I'm going to put the list. So this is the structure of a dictionary. You have the key, then column, and then the list. So I'm going to write one key for one list. Now it's time for the home team. So I'm going to write here home team, then column, then the list, then score. So I create the key and then the list, and finally away team. So first the key, column, and the list. Now I'm gonna set this to a data frame named df. So this is the data frame I'm gonna create. And now to export all of this data to a CSV file, we have to use df and then the to CSV. So here you can see that you can export it to JSON, Excel, and also CSV. CSV is the most popular choice, and I'm going to use it. Stands for comma separated values, and it's a simplified version of Excel. So it's really common for managing small data sets. So I'm going to use to CSV, and now open parentheses. So inside here you have to create the name of the CSV file. In this case, I'm going to name it football underscore data, and you have to specify the extension. So it's .csv. And now you can export it as it is, but I like to add one more argument, and this is the index. So by default, data frames works with index, and if we export it in a CSV file, we're gonna get a column with that index data. So it's gonna be a column with 1, 2, 3, and so on. If you want to disable that, you just have to add index and here write false. Now let's print this df to see how it looks in the terminal. So I write print df, and now the code is ready to be executed. So I'm going to uncomment this So the driver quits after the scraping process is finished. And now I'm gonna run this script. So I click on run, and now let's see what happens. So the browser is open now, and now click on all matches, and now Selenium should be scraping all this data. So let's see here, and yeah, it's printing this home variable we created before, and probably this is going to take some time. Remember that Selenium, it's not so fast. For example, Scrapy, it's way faster than Selenium. So later in this course, I'm going to compare both of them so you can see yourself how fast is Scrapy compared to Selenium. Now, it took Selenium around 1 minute to get all of this data, and finally it printed this data frame. So I have this data frame, and I'm gonna check if the CSV file was created. So I'm gonna open it here, and yeah, it's here, football_data. So I double click on it, and here we have the 4 columns: the date, home team, score, and away team. And that's it. You learned how to export the data we scraped into a CSV file. Okay, now it's time to show you how to extract data from a table using Selenium. So the code we wrote so far opens a website and then clicks on the All Matches button. So it opens this website and then clicks on this button. But now we want it to scrape this data too. So usually when you have to extract data from tables, you will see that tables use tag names that are TR or TD. Those represent the rows here. You can see the rows and the data inside the rows. So for example, TR is going to be this first row, and TD is going to represent the data on each column. So TD1, it's going to be the data on the first column, TD2 on the second, and so on. So let's see if this table works in this way. So to find out, let's inspect the website. So first right click and then click on inspect. And now we get the code behind this table, and as you can see here, we got this TD because we inspected this name, and we got the second element in the first row. So we have TD, and it's the second TD. Also, here we have 4 TD elements. Here the first, the second, the third, and the fourth. And all of them have a common parent node, which is this TR. So this is the parent node of these TD elements. So as you can see, this table is built with these TR and TD tags. So this is how most websites build tables. So now I'm going to show you how to scrape these kind of tables. So let's go back to PyCharm. And here what we're going to do is to find elements by tag names. So we write driver dot find element by tag name. So here inside we write the tag name. So back to the browser here, and the tag name, as you can see here, is TR. So we have only to copy this TR, and here I'm gonna write TR. So if we run this code, what we're gonna see is that Python is gonna return just one element, because this find element by tag name just locates one element. But here on the website, we can see that we don't want just one element, because here there are many rows and we want all the rows here. So we want Selenium to locate all the TR elements, so all the rows. So if we want to locate multiple elements with the same class name or tag name, we have to use elements in plural here. So instead of just writing find element by tag name, we add the S to find multiple elements. So with this, we're gonna get all the elements with that TR tag name. But one important thing that you have to know is that when you use find elements in plural, you also get a list. And in most cases, we have to loop through it later. So I'm gonna show you this, but first I'm gonna create a new variable named matches, and I'm gonna set equal to this code. Now, to get the data inside this matches list, we have to loop through the list. So we write for match in matches, colon, and inside this for loop, we have to write match and that text. So this that text will return the text of that element. So with this, we're gonna get these words instead of code, because so far the matches list only have the raw response that we get from the website. But with that text, we get the data we want. So now I'm gonna print this to show you how it looks like. And now it's time to run this script. So I'm gonna right click and then I'm gonna click on run to see Selenium in action. So now it opened a browser, it click on this button, and now it should be scraping all the data. So let's go back here, and yeah, as you can see here, Selenium is scraping the data row by row, and it's printing each of them. Now, there are around 700 rows, and Selenium scraped it in a decent amount of time. So now let's verify the data. So the first row is Fulham 0, Arsenal 3, and let's go back to the browser to see if that's correct. And yeah, that's the first row, and now let's check the last row. So it's Wolf 1, Man United 2, and let's see here 2, and yeah, this is the same data. So Selenium successfully scraped the tables. Now, one little detail here is that all the data is contained in one variable. So this is okay, that's fine, but if you later want to store that in a data frame, you're gonna get one column with all this data. And then you have to use some Python techniques like regular expressions to put each data in different columns. So if we want to avoid this, we can store each data inside a variable. So for example, we can create a list for this date, then another list for the home team, another for the result, and one for the away team. So let's do this. So first, I'm gonna create empty lists. So I write date equal to square brackets. These square brackets represent empty lists. And now I'm gonna duplicate this 3 times. So here I'm gonna write home team. Here I'm gonna write the score or the result, and here away team. So we have the lists. Now we need to scrape the data. So instead of doing match that text, we can scrape the TD elements inside the TR. So let me show you here in the browser. I'm gonna quit this browser, and now in the original window we had before, here we can see that each TR has these 4 TDs as I mentioned before. So here we have 1 TR and 1 TD for the day, then the home team, score, and the away team. So if we want to get this TD element, we have to write TD and then add square brackets. It's like indentation. And inside square brackets, we add the number of the TD element. So if it's the first, we write 1, the second 2, the third 3, and the fourth 4. This is different from Python because indentation in Python starts with 0, but when we work with XPath, we have to start with 1. So let me show you here. We're not going to use here tag name, but we're going to use XPath. So let me show you. I'm going to press Control F or Command F, and now I'm going to write /tr. So this is how you locate these tr elements. Before we located with tag names, but we can also do it with XPath. So as you might remember, to locate with XPath, you write / and then the tag name, in this case tr. So if I navigate here, we get all the rows. Now, if we want to get the TD inside this tr, we only have to write / because we want the immediate child nodes, and then we have to write TD. So I'm going to write TD. So now we have here all the TD elements. So if we navigate, we go one by one. And now let me show you how to get only the date. So as I said before, if we want only the date, we write square brackets and then we write number 1 because it's on the first column. So if I navigate here, now it only goes through each date, as you can see here. And if I change for number 3, we only get the scores. So this is what we're going to do. So now I'm going to copy this, and now back to PyCharm. So I'm going to minimize this one, and now I'm going to change this code. So I'm going to write here match find element by XPath. So as you can see here, we're not using driver find element by XPath anymore because we want to use this match context. So we want to have this as a reference for our XPath. So if we want to use that match context, you have to write match instead of driver. And then in the XPath, you have to write the dot sign because the dot sign specifies that you want to use the current context. And then we have to build the XPath. So we write single slash and then TD. So as you might remember, I copied the XPath and I'm going to paste it here. And I'm going to just add quotes to compare. So here we have double slash tr. This is this expression. And then this TD, it's what you can see here. So I only included this dot to replace the whole code here. Hope that makes sense. And now I'm gonna add the square brackets to locate the first element, which is for dates. So now to get the text, I'm gonna write dot text. And now I'm gonna duplicate this 3 times, and I'm just going to change the data inside the square bracket. So 1, 2, 3, and here 4. And now I'm going to store each of them in a list. So this one corresponds to the date list. So I'm going to write date, and then I'm going to use the append method to store this data into this list. So we have this text here that represents the date, and we're going to append this inside the date list. Now we do the same for the home team. So I write home team, append, parenthesis, score, append, parenthesis, and finally away underscore team, append, and finally parenthesis. But now to see how the process is going, I'm gonna print one of these elements. So I'm gonna copy this one, and now I'm gonna create a new element called home equal to that. And now I'm going to replace this for home. Next, I'm going to print the home variable. So this is useful to see how the scraping process is going, and also helps to debug code. So now it's time to run this script. So I'm gonna right click and then click on run. And let's see what happens. So now a browser was opened. And now Selenium, click on this button. And now it's supposed to be scraping the data. So let's go here. And it's scraping that data one by one. So this could take a little bit of time. So I'm gonna stop the process with this red button. I just don't wanna make this video so long. And that's it. On the next video, I'm gonna show you how to store all this data inside a data frame. On this video, I'm gonna show you how to select elements within dropdowns. So you can change the value here. For example, I'm gonna change it to Germany, and all this data is gonna load. Okay, before I start with this explanation, I have to make a note here. The type of dropdown that we're going to select in this video is some dynamic dropdown, because if you click on it, for example, I change to another value, the link doesn't change, but only the content. I believe these kind of dropdowns are built with Ajax. I'm not so familiar with that, but in any case, these dropdowns helps the website to load all the data dynamically. So I'm gonna inspect on this element to see the code behind this dropdown. So as you can see here, this is the code, and if I try to inspect on the elements inside the dropdown, let me see if it's possible. So here I can't do it. If I try to open the dropdown first and then inspect, I lose the dropdown. So this is other kind of behavior that these kind of dropdowns have. With that traditional drop downs, you can just apply what we've learned so far and just inspect the element you want and locate the element and then click on the element as we did before on the clicking on a button section. But in this case, we're going to use a different approach. So here on PyCharm, we write from Selenium .webdriver.support and then .ui. I know this is a bit long, but you can just copy it and paste it from the cheat sheet that I include in this course. And here I'm going to write select. So this is what we're going to use to tackle this kind of drop down. So here we inspected the element before, and let's see how we can locate this element. So here we have a class and we have multiple values, and fortunately here we can see that there is an ID with the name set to country. So probably this one will have an ID league and this one will have an ID season. So let's locate this country dropdown. So I'm gonna copy this ID and now back to PyCharm. Here I'm gonna open a space here for the dropdown part. And now I'm gonna write select, which is what we imported here. And I'm gonna open parentheses. And now we can write the usual code we've been writing so far. So something like this. So we write driver dot find element. So in this case, we found an ID. So we're gonna just find element by ID. And inside parentheses, I open single quotes and write country. So as you can see here, this is the usual stuff, but we have to include this inside select. This is what you have to do every time you see this kind of drop down. So now I'm gonna set this to a variable name dropdown. So now once we selected this, we can choose the element we want to select. So here there are many countries. So let's say that we want to choose now the element Spain. So here we write drop down that, and there are different ways to get that element. So we can do it by index, by value, and by visible text. The index, as I told you before, it's just the position it's located. So this is gonna be 1, 2, 3, and so on. We can do it also by the visible text, and I think this is the easiest one here. So we're gonna select by visible text. So now I'm gonna open quotes and write here Spain. So with this, what Selenium is gonna do is click here and then click on Spain. And as you see, every time we change this option, the website takes a couple of seconds to render the results. So I'm gonna do it one more time. And now you can see this loading stats message. So sometimes if that goes slow, that can make our code to break, because the bot we built with Selenium scrapes the data fast. And if it doesn't find the data, it's gonna throw an error saying that the element wasn't found. So to deal with this, we have to use weights. I'm going to explain you weights in more detail later, but I can show you the most basic way to create weights. So we have to import time. So we're going to use the time library here, and we have to use the sleep method. So after we click on the country, as we've seen before, the page is going to show a message that says loading page, and it's gonna take like a couple of seconds. So we're gonna do time.sleep, and here we're gonna set the seconds we want this code to wait before it executes the next line of code. So let's say we want it to stop just for 3 seconds. So we write 3, and once it reaches this point, it's gonna stop for 3 seconds and then execute this code. Now it's time to test out the code, and I'm going to right click and now click on run. So I'm click on it, and then let's see what happens. So now the browser should be open, and first click on the all matches button, let's see, and then change to Spain. Yeah, it changed to Spain matches, and now it should be scraping all this data about match results in the Spanish league. So let's see here. Yeah, here it's printing the home teams of the Spanish league, and it's gonna take some time. So I'm gonna cut this part and show you when it's finished. Okay, now all the data was scraped, and now here is the data frame printed on the terminal, but I'm gonna show you the CSV file we created. So I'm gonna double click here on football data, and now you can see the results of the Spanish league instead of the Premier League that was by default on the website. And here you have all the data. It's around 760 rows, and yeah, let's check if the data is correct. So it starts with Alaves and Betis. Let's see here. So I changed to Spain and it's loading. Yeah, 1-0 Alaves Betis. And let's check here. The last one is Real Madrid Villarreal 2-1. So fast check, and yeah, it's here. So congratulations, you just built your first bot using Selenium. In this video, I'm going to show you how to handle pagination with Selenium. So we're going to scrape this website called Audible. This website belongs to Amazon and contains a lot of data about audiobooks. So as you can see here, there are a lot of information about audiobooks, and if you scroll down, you'll see that it has pages here, and there are 60 pages. So first I'm going to show you how to scrape one page, and then we're going to scrape all the 60 pages. So let's start writing some code. I'm going to PyCharm now, and as usual I'm going to write from Selenium import WebDriver, and then I'm going to define the variable that is the website I'm going to use in this video, and it's going to be this Audible website. So I'm going to copy and paste it here. I'm going to paste the link. Now we're going to define also the path of this Chrome driver file we downloaded before. So this is the path of my Chrome driver. In your case, you just have to paste the path of your Chrome driver. So now we're going to continue defining the driver. So driver equal to WebDriver, which is this one we just imported, and then we're going to write that Chrome, and inside parentheses we're going to write the path. So as you might remember, this is the WebDriver and we're using Chrome driver, so that's why we put this. And this is the driver that is going to help us locate elements later. Okay, next we're going to write driver.get, and inside this parentheses we're going to write the variable web. So this is going to help us get the web in the browser that we're going to open with Selenium. Then we're going to maximize the window once the driver is open. So we just write driver maximize window, and that's it. With this we have the window display all over the screen. And now it's time to analyze the website to find the best approach to scrape it. So I'm going back to the browser here, and now I'm going to click or right click, and then I'm going to click on inspect. So now I'm here on the developer tools, and now we have this element that represents the title. So we're going to scroll up a little bit until we find something that contains the whole information here. So I'm going to scroll up. We're here and we find this li tag that contains the whole title, and if we scroll up a little bit we see this little box here. Keep scrolling up and let's see what we find. Now we have the single audiobook, and if we keep scrolling a little bit we're going to find the whole thing that contains all the audiobooks. So I found it. Is this class ADBL impressions container. So this contains all the audiobooks listed here. So as you can see here, it contains all of them. So it's going to be our first reference, and our second reference is going to be the li because it represents each individual audiobook. So I'm going to show you here. This contains all the audiobooks, and this one the first, and so on. This one the second, this one the third. Now I'm going to copy this class name, and I'm going back to PyCharm, and we're going to define a new variable name container. So I'm going to write container, and here we're going to locate the element container. So I'm going to write driver as usual, and then we're going to find this element by class name. So we write find element by class name, and inside parentheses we're going to paste the class name we just copied, and this is the class name. And with this, we just got that container, and we're going to use this context to get all the audiobooks listed with li. So back to PyCharm, and to locate all the audiobooks listed, we have to write container to represent the current context, and now find element. And in this case, we're going to use XPath. So I'm going to write find element by XPath. And now inside the string, these quotes, we're going to write the string that it's dot slash and then li. So this represents this dot, as you might remember of previous lessons, is the current context. So with this, we're telling Selenium or Python that considers this container context that we just created before. And then with the single slash, we're telling to get the immediate child elements. So we're getting the immediate li. So back here, you see that this is the container, and we're getting the immediate li that it's here. So that's what we're building right now. Now with this, you just get the first li element or the first audiobook. If you want to get all the audiobooks, you have to write find elements in plural with the s. Keep in mind that this is going to return a list, and we have to loop through it later. Now I'm going to define a new variable called products. So I write products, and this is going to be a list. Now let's see the data we're going to scrape. So I'm going back to the Audible website, and here I'm gonna scrape the title, the author name, and also the runtime, which is the length of the audiobook. So let's see how we can get this element. So I right click and then click on inspect, and that title. So this is the element title here, and we don't see any ID or any other thing that can help us easily locate these elements. So I'm going to scroll up a little bit to find something easy to use for our code. And now I found here something interesting. So here, this first we got this A tag, but above this A tag we have this H3, which represents something like a title, and this has a class named BC heading, BC color link, which doesn't tell anything, and BC pop break word, which doesn't tell so much either. So here the thing that I think it's kind of representative, it's the heading, because heading is also known as title, so it can represent the title of the audiobook. But let's see how the author name and the runtime is displayed in the HTML code. So I clicked on the author name, and we got this. So here again we have this that is the A tag that doesn't tell us much about this, but contains the text we want. But up here we have the, again, span, and we have this li, and this li has the author label. So here again we found a representative word, which is the author label that represents the authors that wrote the audiobook or the book, and this is gonna be also helpful, I think. And let's see the runtime. Let's go into inspect this length, and here again this is a span and doesn't have anything interesting. BC text size small, it's not so representative to locate this. And let's scroll up a little bit, and I found the word runtime label, which I consider representative. So here we found 3 representative elements to locate the title, the runtime, and the author's name. But as you can see here, the class name contains 2 words. One which doesn't tell us much about this element, and the second that it's interesting or it's representative for us. This is the same case for the author and the title. The first one is here BC list item, doesn't tell much about this element, while the second is the author label. And the same happens for the title. So what we're going to do here is to use the contains function. This is going to help us identify an element by 1 word. We've seen this contains function in previous videos, and now we're going to see it in action. So let's go back to PyCharm to write some code. And now I'm going to write for product in products. So we're going to loop through this products list, and now I'm going to write expression. But first I'm going to do it on the browser so you can see that it's the correct expression. So I press Command F or Control F, and now I can test here the XPath I want to build. So let's locate first the title. So I'm going to inspect the title, and we're going to see the element that we've seen before, which is here, just above this A tag. So I'm going to locate this. So I'm going to write /, and now I'm going to copy the element we want, which is the first word that represents this title, BC heading. So I'm going to copy this, and now we're going to build the XPath expression. So as you remember, we have to write the tag followed by brackets, and then we have to write add, in this case class, and then the name of the attribute. In this case, I'm just going to use BC-heading because I'm going to use also the contains function, and now I'm going to write this. So first the tag, which is h3, and now I'm going to write square brackets. Then we're going to write contains. So this is the contains function, and this uses parentheses. So now I'm going to write the attribute, which is class, add class. Now comma, we use comma when we use the contains function, and then we write the attribute name, which is BC heading, but we have to put it inside quotes, double quotes or single quotes. And this is the XPath expression we just built. So here on the right, you can see how many elements match with this XPath expression. And as you can see here, it says that 23 elements match. But here's a thing here, because in this page, we have only 20 audiobooks. So I'm going to show you much better here. We have just 20, show 20 items per page. So what's going on? Why we have 23 elements if there are only 20 audiobooks? What is happening is that 3 additional elements have the same XPath. So I'm going to look at them. So I just press here. And as we can see, the elements are not visible because here you can see that the 4th element is the first here. So it means that the first, the second, and the 3rd element that has this XPath expression, they are not visible because we can't see it here, but they are there. So to avoid matching these 3 hidden elements, we use this containers and containers products. So don't worry, because we're not going to match those 3 hidden elements, because with this current context, we avoid matching those 3 elements. So here, although it says 23, we're actually just going to match 20 because we're going to use this product context or reference. So now let's continue writing the code, and I'm going to locate the elements inside the for loop. So I'm going to write here product, and then I'm going to write that find element by XPath. And inside this, I'm going to write the XPath expression we just built. So I'm going back here to the browser, and I'm going to copy the XPath expression of the heading or the title of the audiobook. Here I'm gonna paste it, and this is done. So now to get the text inside this element, I'm going to write that text. Now let's do the same, but now for the author's name. So I'm going to inspect the author's name, and here we can see the author label. So it's inside an li tag, and it has the name author label. Well, with this, but we're going to use content, so we only use author label. So here I'm going to replace h3 for li, and I'm going to copy this first. So only author label. We're using a class, so we keep this class, and I'm going to replace this one here, author label, and li here. So I'm going to delete this and li. So now you see highlighted in green this author label, and it's only the author, as you can see here. So I'm going to copy and go back to PyCharm, and I'm going to duplicate this. So Command D to duplicate this, and now I'm going to replace this XPath expression. So I'm going to delete this and paste it here. Now I'm going to add the dot for both expressions, so we consider here the current context, that is product. Now let's do the same for the runtime, and I'm going back here, and now to the runtime I'm going to inspect it, and now I'm going to copy this runtime label. I'm going to paste it here, and it's also using a class attribute, and it's using the li. So I'm going to keep it there, and here is runtime. I didn't copy the r, and now I'm going to copy the whole expression. So I'm going back to PyCharm. I'm going to duplicate this, and now I'm going to replace it for this. Now let's create some lists to store the data we're about to scrape. So I'm going to create a book underscore title, and I'm going to set it to a list with square brackets. Then I'm going to duplicate this, and I'm going to write here the author, and here the length, which is the runtime. So length. So it's ready now, and I'm going to use the append function to store the expression inside the list we created. So I'm going to write book title append in our parentheses, and inside here, inside the parentheses, I'm going to copy the first one, that is the title, and I'm going to paste it, and the same for the others. So I'm going just to write this book author, and now the same append parentheses, and put this inside parentheses, and the same for the third, book length append parentheses, and put this inside, and that's it. So with this we store the data inside these lists, so we can later export it in a CSV file or JSON file. So now after the scraping process is finished, we have to quit this driver we opened. So we write driver.quit, and that's it. With this, the scraping process is finished. Now we have to create a data frame to export the data in CSV file or JSON file. So I'm going to import here pandas as PD. So I write import pandas as PD. And now we're going to create a data frame. So I'm going to write PD, which is the pandas library, and I'm going to write data frame. And now inside data frame, we're going to use dictionaries to create this data frame. So the first element of this dictionary, that it's represented by curly braces, is title. So title, we write title, and now colon, and followed by the list, book title. Then we have to write the author, so author followed by the book author, the list, and now the length or runtime, so it's length and book length list. So this is how you create a dictionary, and this is also how you create a data frame from a dictionary. So now I'm going to create a variable named df books, and I'm going to set equal to this. And now I'm going to export this to a CSV file. So I'm going to write df_books to CSV. So to CSV. You can also do it to JSON. Just write to JSON here instead of CSV. And now I'm going to set the name of the file. So it's going to be just books.csv. And now I'm going to set the index. It's not going to be there, so false. Remember that pandas works with index, which is the names that are on the left of the data, and I don't want it to show up on the file. So I set it to false. Now everything is ready to run the bot. So I'm going to right click and run this script. So I'm going to run the script and we're going to see what's going to happen. So first the browser is going to be opened, and as you can see here, I suppose now it's going to maximize. Yeah, it maximized the window, and I think it scraped all the data and then quit, because this is the first website I had before with example here with the developer tools. So I'm going back to PyCharm to see what happened. So process finished with exit code 0, which represents that everything was fine. And now I'm going to open the CSV file that should be named books.csv. So I'm going to open here, and here we have a new file named books.csv. I'm going to double click on it, and now I'm going to minimize this, and we can see that we have the title, the author, length, and we have 20 elements here. And the first is landslide. Let's check if that's correct. Yeah, landslide. While the last one is how I saved the world. And yeah, it's here. So we successfully scraped the first page. And on the next video, I'm going to show you how to use headless mode, which will help us scrape the website without opening the driver as we did on this video. Okay, on this video, I'm going to show you how to use headless mode on Selenium. Headless mode is an option that Selenium has that let us run the bot we create on the background. This is useful when you're doing other tasks and you don't want to see that browser opening over and over again every time Selenium is scraping the website. So you can let the machine do the job silently on the background. Okay, to use this cool functionality, we have to import options. So we write from selenium.webdriver.chrome.options, and here import options. I know this is a bit long, but fortunately you have the cheat sheet that I included in this course, so you can just copy it and paste it every time you have to use it. So after you write this, we're going to write options, and we're going to initiate this. So options equal to options, and with parentheses. Here we're initializing an instance of the option class. So this is going to be our instance that we call options. And now we have to write options.headless to use the headless mode. And then we write equal to true. So this represents that headless mode is activated. Then usually when I do this, I also add another argument that is not necessary, but I do it because I just want to scrape as much data as I can. So I use this one that is options add argument, and inside here we write window size, and this let us customize the window that is going to open. So I'm going to write 1920 x 1080. So here, if you write a small screen, you are going to get less data because it's how screens work. The bigger the screen, the more data will fit on the screen. And now you might be asking yourself, why do you need this when you have this driver maximize underscore window? So in my experience, this maximize underscore window function doesn't work so well when you use headless mode. It works perfect when it's just headless disable, but when it's headless true, it doesn't work so well. So this is why I use this one. So I'm going to comment this one out. And now we have to write the argument here inside Chrome. We have to add an argument, and we write options equal to options. So the first is the options argument, and this is the options instance we just created from the options class. Sounds a bit redundant, but that's how it works. Now, before we run this script, I'm going to print an element so we can see how the scraping process is going, because we're not going to see the process on the browser, but we have just to wait until the process is finished. But just for the sake of this video, I'm going to print this, and I'm going to print the title, which is this one. So I'm going to change this code a little bit. I'm going to copy this expression that we built before, which represents the title, and now I'm going to define a new title variable. So I write title equal to this, and now instead of writing the whole expression, I'm going to write title here to append, and here I'm going to print this title element. And now I'm going to store this in a CSV file named books_headless, just to verify all the data was scraped. Now everything is set, so I'm going to run this script. So I'm going to click on run and wait to see what happens. So as you can see here, the titles are being printed, and now everything is finished. So here we have the first audiobook, and here we have the last one. We didn't see the browser open because we used headless mode, headless equal to true. And now let's see if all the data was scraped. So I'm going to open this CSV file named books_headless. And this is the data we scraped, which is the same as the CSV file we obtained from the video before, but now we use headless mode. And as we can see here, all the data is correct. We got 20 elements as in the video before. And that's it. Now you know how to scrape with Selenium using headless mode. Okay, in this video, I'm going to show you how to scrape all the pages of this Audible website. But before doing that, let me disable the headless mode so you can see how the bot we're going to build is going to work on the browser. Also, I'm going to comment this out and use this one because I'm not using headless mode. So I'm going to use maximize window, and here I'm going to set it as it was before. So I'm going to delete the title variable, and I'm going to put this inside the parentheses. So that's it. Okay, now to start building the bot, we're going to the website, and let's analyze the best approach to scrape all the pages of this website. So I'm going to scroll down, and here we see that 60 pages. So I'm going to right click here and click on inspect, and we're going to get the HTML code. And now I'm going to get this here, which represents all the pagination bar or the navigation bar, and I'm gonna click on it, and we have here this element that contains all the pages. So it's called paging elements with UL tag. So as you can see here, this one contains all the pages here. The back arrow, page number 1, number 2, number 60, and the next button arrow. So we can locate this one first, and then we can locate these pages by the tag name li. So this is what we're going to do. We're going to locate this using the contains function. So we locate paging elements, and then we locate with tag names li. And now back to PyCharm, and let's do this. So here, let's open some space for this code that I'm gonna, this block is gonna be called pagination. And now I'm going to define a variable that I'm going to call, well, pagination. And this is going to be equal to driver and dot find element by xpath, because this is how we're going to locate that first element. Now we open parentheses, and now it's time to build the first XPath. So back to the browser, we press Ctrl F, and now let's locate this first element. So I'm going to copy this paging elements word because I consider the word that represents better this element. Actually, you can also consider the whole thing. So busy list here, busy dash list, paging elements, and copy everything inside double quotes. So busy list not style and all of that. But I like to do it with some meaningful word so I can understand the code later, and I avoid copying all the meaningless words that are inside the class. So I'm going to copy paging elements, and I'm going to use the contains function in the XPath. So this is inside a class and it's inside a UL tag. So let's write double slash, and then we're going to write the tag, which is UL. Now square brackets, and now we write contains. Now parentheses, and we write add class because that's the attribute. And now open quotes, and inside quotes we're going to paste the paging elements. So the XPath was successfully built, and as you can see here, it's highlighted in green and there is only one element, so everything great so far. Now let me copy this, and now back to PyCharm, and I'm going to open single quotes just to avoid repetition with this. And now we have the XPath here. Now let's locate all the pages. So I'm going back to the browser, and here I'm going to locate these li elements. So here we can use XPath, or we can use tag names to locate with Selenium. I'm going to show you how to do it with XPath. We just write slash and then li. And as you can see here, we get the 6 elements, which are each page here. And now I'm going to show you how to do it with tag name. So back to the code here, and we define a variable named pages, which is equal to pagination. I'm going to use this context, and then I write find element by tag name. So here in quotes I'm going to write li because that's the name of this tag. Here I forgot a little detail. I forgot to write the S, so it's find elements in plural because we have multiple li tags elements. So we have here all the pages, and we want to match with all of them. So now that we have this pages list, we're going to get only the last page to have it as a reference. So I'm going to create a new variable called last page, and this is going to be equal to, and now let's go back to the browser, and I'm gonna show you something. As you can see here, the elements highlighted in green are those we match with the XPath or tag name, and to get the last page we have to get the number of the page by its index. So let me show you. Here the first element is going to have index 0. So this arrow that goes to the previous page is going to take that index 0. So if we do pages square bracket 0, this is called indentation. This is going to return the first element, which is this one. And if we write 1, it's going to give us the first page, and 2 the second page, and so on. So here we want to get the last page. So here, as you can see, if you go to the third, you get those 3 points, and if you get the element by index 4, you get the page 60. And finally the element by index 5 is gonna take the arrow that goes to the next page. So if we want to get the last page, we should write this pages in here number 4, because it's the index that it's going to return the page 60. But to use better code, let's use reverse indexing, which consists of using negative numbers to get to the element we want. So let me show you. If you want to get the last element, you use -1, and one before the last is -2, and this is the one we want because the last page usually it's one position before the last element. That's usually how this navigation bar works. You have this left arrow, this right arrow, and one before the right arrow is the last page. So this is going to work usually in most pages. So let's use this one. So I'm going back to PyCharm, and now I'm going to use -2. And now I write that text to get the text inside this page -2, which is 60 in this case. And now I write int. Now parentheses, and I have the number 60 in this expression. So this is how you get the last page from the paging elements here. So now let's locate the next button here, so we can click on it around 60 times to get all the pages. So here I'm going to inspect the button, and now we have the code behind that button. So it's here, and apparently inside this element there isn't any meaningful word. We have BC icon, right, BC icon field base, and let's find something more meaningful to locate it with XPath. So I'm going to scroll up here and nothing. This one could be a good one, BC button text. Let's check if we can find an ID or something as good as that one. In here, let's see, we have here, there is a good one, next button. So we can use this word to locate this next page button, and this is even much better than the one we found before, which is this one, BC button, because it doesn't tell so much. There are many buttons, but probably there is only one next button. So this is the one we're going to choose, and we're going to use the contains function again. So let's write the XPath. So I'm going to copy this next button word, and now I'm going to slightly change this XPath. So instead of UL here, I'm going to write span. So I write span, and here I'm going to replace with next button. So here we found it. We found this element, and there is only one here, as you can see. Now let's copy this, and now back to PyCharm, and I'm going to create a variable called next underscore page, which is equal to driver that find element by XPath. So I'm going to write find element by XPath, which is this one. And now I'm going to put double quotes and then, well, single quotes then. Now to click on this button, I write next page dot click. And now it's time to write some conditions so the bot can scrape all the pages and stop in the last page. To do so, I'm going to use the while keyword. So I write here while, and here I have to build a condition. So first I'm going to set a new variable, which I'm going to name current underscore page, which is equal to 1. So we're going to start, of course, in page 1, and this variable is going to be less than the last page. So now I'm going to explain you what this means. So the while keyword is going to execute the code behind every time this condition is true. So if the current page is less or equal to the last page, we're going to click on the next page element. But if the current page value is greater than the last page, the code inside the while loop is going to break, and the execution will continue with the immediate code below. So I'm going to show you this with the code so you can understand much better. So what I'm going to do first is to indent this expression, which is going to be inside the while loop. So here, this is going to be inside the while loop, which is, by the way, the part of the code that helps us scrape the website. Now we're going to cut this next page, and we're going to paste it here inside the while loop. So I'm going to put it here. And now I'm going to increment this current page variable by 1. So I write current page is equal to current page plus 1. So for every iteration of this loop, this current page is gonna be increased by 1. So for example, let's say we're in page number 1. So we're in page number 1. We scrape all the content of page number 1, and then 1 plus 1 is 2. So the current page value is set to 2. Then we locate this next page element and we click on it. And then we start this again because 2 is less than 16. So this condition is true. So the while loop is gonna continue the execution. However, when the current page variable reaches the value of 60, this is going to be increased by 1, so 61, and in the next iteration 61 is not less than 60, so this while loop is going to break. So this driver quit is going to be executed. This means that if we go back here, when we reach page number 60, it's not going to page number 61 because there is no page number 61. Now finally, we're going to use the try except block. So in case the next page button is not located, just the code is going to be passed. So we write try except and then pass. So if this fails, the code is going to pass to the next iteration. So that's how the try except block works. And now before running this script, I'm going to place these lists we created outside the while loop. So it's going to be created once, because if this is inside the loop, the lists are going to be created on every iteration, and we don't want that. So now it's time to run this script. But to show you how this works, I'm going to use another tab. So let me show you here. Instead of using this page with 60 pages, I'm going to use another one, which is inside here. Just go to browse and then inside popular list, best sellers. I'm going to choose this one because this one has only 5 pages while the other has 60 pages. So with this one, I can show you how the bot is going to work because it's going to take less time. So now I'm going to just copy this link and I'm going to replace it for this. Finally, to make sure each iteration works fine, we're going to use implicit waits. So we just have to import time, and then with this we have to use this time.sleep. So here, every time the Python code goes here to this line 28, the process is going to stop for 2 seconds. So it has time to render the page correctly. This is just a good practice to follow in web scraping to write a more robust code. As I said before, this is an implicit wait. There is also explicit wait, which is even much better, but we're going to see that on the next video. Now it's time to run this script. So I'm going to right click and click on run. And now the browser should open on the Audible website, and we should see that the browser should be maximized. And yeah, it was maximized. Now it should navigate through each page. So now it's in page number 2, and then it's page number 3. As you can see, it waits 2 seconds before it scrolls down and go to the next page. So now it's in page number 3, I guess, and it's going to stop in page number 5, and then it's gonna quit. So I think it's in page number 5, and yeah, it quit. And now let's go back to the code, and it was perfect. And now let me check the files. And here we have the books underscore pagination CSV file we just created. I'm going to click on it, and here we have all the data inside the 5 pages. So it starts with this book called Landslide, and it ends with this other book. So it has 100 pages, which makes sense because here there are 5 pages and 20 audiobooks per page, so 100 in total. And here we have 100, so everything was perfect. And that's it. Now you know how to handle pagination with Selenium. In this video, I'm going to explain you the difference between implicit and explicit waits. And also, I tell you when is the right time to use each of them. But first, why do we need to use waits? Well, one of the problems of scraping JavaScript-driven websites is that the data is loaded dynamically. so it can take some seconds to display all the data correctly. As a result, an element might not be located when scraping the website, so we'll get an element not visible exception. This is why we have to make the driver wait until the data we wish to scrape is loaded completely. There are two types of waits, implicit and explicit waits. An implicit wait is used to tell the WebDriver to wait for a certain amount of time when trying to locate an element. In Python, you can import the time library and then make an implicit wait with time.sleep, and inside parentheses you specify the seconds you want the driver to wait. For example, if you want a wait of 2 seconds, you write time.sleep and 2 inside parentheses. We used an implicit wait in the previous video. As you might remember, I set a wait of 2 seconds to make the driver wait 2 seconds after going to the next page. I did this to make sure that all the data was completely loaded when navigating through all the pages. On the other hand, an explicit wait makes the WebDriver wait for a specific condition to occur before proceeding further with the execution. To work with explicit waits, we have to import 3 libraries: by, WebDriver wait, and EC, that stands for expected conditions. After this, we can create an explicit wait. Now let's see the syntax of an explicit wait. The explicit wait is a bit long, so I split it in 3 parts. In the first part, you have to write WebDriver wait, and then inside parentheses, you set the driver and then the seconds you want the driver to wait. Then you write that until. Inside until, we're going to write a condition. So this first part means wait until this condition happens and wait at most 10 seconds. So if after 10 seconds the condition isn't satisfied, the code is going to break. Now let's see the syntax of the condition, so what it's inside the parentheses. So inside parentheses we write EC, that means expected condition, and then that. And what follows is the condition. There are different types of condition, for example, presence of element located, or element to be clickable, or element to be selected, and so on. You have to choose the one you need. One of the most popular conditions is presence of element located. This one makes the driver wait until the presence of an element is successfully located. Otherwise, the code will break. Finally, the last part of this syntax is how we locate this element. So, as you might remember, there are many ways to locate an element, with XPath, class name, ID, and so on. In this case, we have to write by, and then that, and then the attribute or the XPath. Then we add a comma and write the value inside quotes. If we put these 3 parts together, we'll get this whole syntax. It might look a bit scary, but don't worry, you will get used to it. Now it's time to show you how to make an explicit wait in the code we wrote in the previous video. Okay, to make this implicit wait explicit, first we have to import some libraries. So I'm going to paste the libraries that we have to import here. You can download the script and copy it if you want. So I'm going to add the F here that was missing. And these are the extra libraries we have to import. So now back here, and now here we're using just find element. So it's a single element. So to rewrite this code, I'm gonna duplicate this. Then I comment this out. And here I'm going to delete this. So I write WebDriver wait. We always start with WebDriver wait and then parentheses. Then we write the driver. So I'm going to copy this one and I paste it here. And here we have to set the seconds we want to wait. So this is the maximum number of seconds Python is going to wait. So I'm going to set this to 5 seconds. But the seconds depend a lot on the website you want to scrape and also on your machine. Next, I write that until, and inside parentheses I write the condition. So I write EC, so expected condition, then that, and here the condition we want to set. So I'm going to set it to presence of element located because it's a single element. So I click on it and then I'm gonna open parentheses. So I write double parentheses, and here I write by, and then dot. And here I can choose the attribute. So in this case, it's gonna be class name, because we used class name before here when it was implicit. Then I write comma and write the value. So I open quotes, and here I'm gonna copy the value that I commented out and I paste it here. And here I made a typo. It's not Y with capital letter, but this way. So now it's fine. Now I'm gonna add explicit weight for this second variable. So I duplicate this, I comment it out, and now I'm gonna delete this. So again, we start with WebDriver weight, and in this case we were using the container element as a context. So this was our reference. So I'm gonna use it again. So instead of writing driver, now I write container. And here the seconds. So again, 5 seconds. Now I write dot until EC of expected conditions, and the condition is gonna be similar. So I write presence, but in this case, it's not gonna be just of element located, but in this case, it's gonna be of all elements located, because here before we use find elements by XPath, so elements in plural. So here we need to do the same. So I'm gonna write presence of all elements located. Now double parentheses, and I write by XPath in this case. Then comma and open quotes. So I copy this XPath and I paste it here inside quotes. And that's it. That's how you add explicit weights. Now I'm gonna comment out this implicit weight just to test this script. So let's see if this still works. So I right click and then click on run. And now we wait until this is done. Now as you can see, Selenium is going to the next page and is supposed to scrape all the pages listed in this Audible website. So now let's wait until it gets to the last page. I think there are 5 pages, so it's not gonna take so much. So now I'm gonna open the CSV books underscore pagination that we created. So I open here and now I click on the books underscore pagination.csv, and here it's the file. So as we can see, all the data was successfully scraped. So there are 20 audiobooks per page and we scraped 5 pages. And that's it. This is how you use explicit weights with Selenium. Now, when should you use implicit and explicit weights? Usually, implicit weights are used when testing a script. They are short and simple, so it helps debugging code faster. On the other hand, explicit weights are long, but they help us write robust and efficient code, so the driver doesn't have to waste time waiting a specific number of seconds, but continue with the execution as soon as the condition is satisfied. To sum up, we can say that explicit weights are good to implement when the script is finished and we want to make the script more efficient, while implicit weights are better choice for testing the code we write. And that's it. You learn how to use implicit and explicit weights in Selenium. In this video, we're gonna learn how to log into websites using Selenium. So we're gonna log into this Twitter website, but before we do it, I want to tell you that logging into websites for web scraping is not a good practice, because not only your IP could get blocked, but also your account can be banned. So for example, if you log into Twitter so many times, you could lose access to your account. So try not to do it unless it's absolutely necessary. I try to avoid it at any cost, and I don't use it so much, but just for educational purposes, I'm going to show you how to do it. That being said, let's go to PyCharm and let's start writing some code. So first, as usual, we import WebDriver from Selenium. So we write from Selenium import WebDriver. And this is the first thing we're gonna do. And then we set the website variable. So the website, as you can see here, it's twitter.com. So I'm just gonna copy and paste. and then the path, and I'm gonna paste it. You have to write yours. Now after this, we do the usual step. So we set a driver here, we create a driver variable, and now we write WebDriver, which is this one, that Chrome, because we're using the Chrome WebDriver, and inside the path. Next, we open this website doing driver.get and web inside parentheses. And finally, we write driver maximize window to get the whole window maximized. Now here to log in into Twitter, first we have to click on this login button. So let's inspect it. So right click and then click on inspect. So we got this div element here, and it doesn't tell us much about this button, but above this element we have this a tag with href equal to /login, which I think it's really useful to locate this login button. So I'm gonna locate this with XPath, so I press Ctrl F to build an XPath, and as you can see here we have an a tag, href attribute, and login attribute value. So let's build the XPath with this data. First double slash, then a square brackets at href equal to quotes and inside quotes /login. So here the element highlighted in green is the button we want. So the XPath was successfully created. Now let's copy this XPath and now back to PyCharm. And now I'm gonna create a login variable. So login equal to driver and that find element by XPath. And inside this double quotes and this XPath we created. Then we're going to click on it. So login.click. Now after we click on the login button, let's give some time so that page can render correctly. So I'm gonna import time and set here time.sleep, let's say 2 seconds. Okay, so now let's go to the browser to repeat this action. So I'm gonna click on login, and now we have this second page. Now here we have to write a username and password. So I'm gonna locate these elements. So I'm gonna click on here. So we get this element, but it doesn't contain any meaningful word. So we have to find something better. So I'm gonna scroll down a little bit, and let's see here we have this dir with auto, then autocomplete with on, and then we have this name attribute with session, username, or email. So I think this is good for locating this username box. So I'm gonna copy this one and I'm gonna use it for my XPath. So we have to locate this input element. So I'm gonna modify this XPath we created before, and we're gonna use an input here, and the attribute is gonna be name, and the value this session, username, or email. I just copied. So let's write it. So here input, and here href. Instead of href we write name, and here the value. So I paste it. So we got two values, as we can see here. One is this one we just want, and the other apparently is not visible. So we have to use another element as a reference to get only this one. So let's get something that contains the whole thing, not only this username individually or this password, but the whole login box. So I'm going to inspect here, and now let's check for something good. So I inspected this one and we got this, and again, meaningless words that doesn't mean anything. Of course you can copy and paste it, it's okay, but I just like to use something more meaningful. And let's scroll down, and here I think this is a good one. It's action attribute and the name is session, and it contains the username and password. So I think we can use this one to exclude that invisible element we got before. So I'm gonna copy this XPath we created before so we don't lose it. I'm gonna paste it here to use it later. And now let's build this new XPath. So I'm gonna copy this session and I'm gonna put it in here. So instead of this one, session, and form, the tag, and action, the attribute. So here session, here action, and here form. So we got the element we wanted. So I'm gonna call this the login box, which is gonna be our first element here. This one is gonna be our second. We pasted before. So first the login box. So login underscore box equal to driver dot find element by XPath. And inside it, I'm gonna open double quotes and paste that XPath inside. Now I'm gonna use this context to locate the username and password. So I'm gonna write here username equal, and here login box find element by XPath. So here I'm gonna paste this one, just copy and paste. But since we're using this login box as a reference, we have to add that because this indicates we're using the current node, which is login box. Now let's locate the password. So back to the browser, and now I'm gonna inspect the password. So here we have the element again, and it's similar to the username because as you can see here, we have a name attribute and the value is session password. So I'm gonna copy this one, and I think I'm gonna duplicate the code I wrote before because it also has input. So input name and this value. So here the input, the name, and the value. So I'm gonna duplicate this. And here set to password. And now I'm gonna replace this for the, sorry, not all of that, but this value right here inside these single quotes. Now, once we have this username and password, we have to send the text. So we use Selenium the send keys method. So we write username and then we write send keys. And inside send keys, we have to write the email and the password. Well, here password, send keys to. So you have to write your password and your email to log in your Twitter account. Next, to log into Twitter, we have to click on this login button. So I'm gonna inspect this login button. And here we find this div element that has this role attribute with this button value. So I think this is gonna help us to find this login button. So I'm gonna build the XPath, which is gonna be a div role and button. So I copy button. Now here, instead of form div, in here the role. And now I just have to delete this slash. And here we have this. Now we have here two elements. We can use the same trick we did before to just isolate this whole thing and exclude the second element, which is invisible, which is the one here. The other is the one we want, but also we can leave it as it is because when locating the XPath, if there are two or more elements with the same XPath, Selenium is always gonna take the first one. So this is the first one listed and it's gonna click on this one. So I'm gonna copy this and now back to PyCharm. Now I'm gonna write driver dot find element by XPath, and inside I'm gonna write the XPath we built, and this is gonna be I'm gonna set this to a variable. I'm gonna name login button, and then we click on this button. So login button dot click. Okay, now everything is ready to run this script, but I have to introduce my email and password. So before making this video, I set my email and password as global variables, so I just have to import OS. You don't have to do this because you can only write your password and email. I just don't want to write my password here and share it with everyone, so I have to use this. So instead of writing email, I'm gonna write OS, which is operating system, and I'm gonna use environment.get, and inside this I'm gonna write a variable I created before making this video, which is Twitter _user, and I'm gonna do the same for the password. So I paste this one, and instead of user, I write pass. So now everything is ready. You don't have to do this, just write your password and your email, and it's gonna be fine. So I right click and then run. Now let's see what happens. So the browser should be open now on Twitter, then login, then my username and password, and then the page should be loaded. So we have here the page. Everything's okay. As you can see, I don't use this account. I don't use Twitter so much. But anyway, we successfully logged into Twitter. And that's it. On this video, you just learn how to log into websites using Selenium. Okay, now it's time to show you how to do infinite scrolling with Selenium. But first, we're going to create a function that is going to take care of scraping data of Twitter. And on the next video, we'll focus only on infinite scrolling. So let's start. Right now, we're on the Explore section of the Twitter website. And here, we're going to write anything you want on the search Twitter box. So, for example, I'm going to write Python to search all the tweets related to the word Python. So I have here many tweets with the word Python, and we're going to scrape at least those that show up on the first page. So what we're going to do is first to get this tweet box here, and then we're going to get the username and the text. So the username is the name after the @ sign, and the text, well, you see here. Now let's start locating the tweet card or tweet box that you can see here. So I'm gonna right click and click on inspect. So here we have an element highlighted in blue, which is a div tag, and with some attributes like the language, the class, and even has an ID. But I believe this ID is different for each card or each box, so it's not gonna be so useful. So I'm gonna scroll up a little bit to get a bigger box. So I scroll up and let me see if I get the whole card. In here I can get the whole card, but these words are kind of meaningless. So I keep scrolling up, and here we have a bigger box that belongs to this article tag element, and we can see that there are some words that doesn't tell us so much about this element, but I think we can use this one here, role equal to article. This might indicate that every tweet is represented by a role with article. Let's find out. Let's build the XPath and see if that's true. So I'm gonna build an XPath with article, role, and article. So I'm gonna press Ctrl F. I'm gonna copy this article here. Now / article square brackets @ role equal to single quotes, and then I paste article. So as you can see here, this is one card, and then if I click on the next element, I go to the next tweet and so on. So I think it's not so visible here, so I'm gonna move this to the right. So now I think it's more evident. Each element represented by the XPath goes to one tweet. So we match every tweet with this XPath. So this XPath will locate all the tweets located in a single page. And remember that I say single page because, as you might know, if you keep scrolling down, more tweets will appear. So that's known as infinite scrolling. So this is why this will only match those tweets displayed in the current page. And here, as you can see, I already wrote some basic code. So I imported WebDriver, the web I have, the path and the driver. I get the web and maximize the window. I think after many lessons of Selenium, you're able to write this on your own. So I'm just gonna change this link because we're not scraping twitter.com, but a slightly different link. So first I'm gonna paste this one here so I don't lose this XPath, and now I'm going back here and copy this page that contains tweets related to the Python word. So I'm going back here and I'm gonna replace it. So this is my new page. You can get it by writing Python here and then copying and pasting the link. Anyway, I'm gonna leave this link in the notes. So now let's define this tweets variable. So I write tweets equal to driver, which is the driver that I got here. Now dot find element by XPath. And now I'm gonna write double quotes and put this in here. So here again we have to add the s because we want elements in plural because there are many tweets, and this is gonna return a list. So this is a list and we're going to loop through it. So we write for tweet in tweets and then colon and then press enter. So as I told you before, we're going to scrape that username and the text. So back to the browser, and now let's see how we can find the username and the text. So I'm gonna click here on inspect, and then I'm gonna locate the username. And we got this element span in this class that has some words that are not so useful. And if I scroll up, I found more meaningless words. And here there is a div with an ID that I said before that is going to change for every tweet, so it's not gonna be useful. And we can't find anything good here. So when you don't find an element that can help you build a robust XPath, you have to find a different approach. And that's what I'm gonna do right now. So far we have this text card or text box that contains the username and the text. So we exclude everything that is outside this tweet. So we can use this @ sign as a reference because every user in Twitter has this @ sign. So I'm gonna inspect it again. So click on inspect here. And yeah, I think I can build this XPath with a span tag in here using the text attribute. So let me show you. First, this is a span tag. So I'm going to include this in my XPath. So what I'm going to do is replace this article for span. Next, we're going to use the contains function. So as you might remember, this will match attribute values that contain a specific word. So I'm going to use here the text attribute. And to use the text attribute, you have to write text parentheses and then comma. Unlike other attributes, the text attribute doesn't show up in this node. For example, the class attribute shows up here in blue, but the text doesn't show up, even though the text is here, right? This is the text of the username. But it doesn't matter. We can still locate it using text with parentheses, as we did here. So now I'm gonna open quotes and I'm gonna write inside the @ sign because every username has this @ sign. And now, as you can see, we just match all the usernames. So let's navigate here. So as you can see here, we are navigating through the usernames in this page and it's working well. So now I copy this back to PyCharm, and here I'm gonna write tweet to use the tweet context. And now I'm gonna find element by XPath. So find element by XPath, and inside here I'm gonna use the current context with the dot, and then I'm gonna paste the XPath. So I paste it. Now I add that text to get the text of the username. Now I create a new variable named user. Now it's time to locate the text inside a tweet. So back to the browser and let's locate this tweet. So I'm gonna inspect it, and now let's see. So here we got the first row, and I think this is the part of the second row. Well, it's split, but we want the whole text. So I think this element here in blue is going to help us because it takes the whole text. Now let's analyze this. It has an ID, a class, a dir, and an element lang, which I believe stands for language. And I think the attribute value is set to English, EN. If this is true, I think we can locate that tweet text with this language attribute because all the text has a language, right? It might be a tweet in Spanish or English or French, but the text will belong to a language. So let's build an XPath with this lang attribute. So now I'm going to copy this link, and the XPath is going to be really simple. So first, the tag is a div in square brackets, and inside square brackets add link. We don't need to specify the attribute value here because we don't care if the language is English or French or Spanish, but we only care that it has this attribute language. Now let's copy this back to PyCharm. I'm gonna duplicate this user code, and now I'm gonna change this to text. This is a new variable. Now I'm gonna use this tweet context, find element by XPath, dot to use the current context, and now I'm gonna change this and paste it. Well, we don't need 4 slashes, so only 2. Then that text, and this is ready. Okay, now let's store this user and text inside lists so we can export it to a data frame and then to a CSV file later. So I'm gonna create a user underscore data list. This is an empty list, and then I'm gonna duplicate and write text underscore data. Now to store the data, we're going to use the append method. So we write user data dot append, and inside parentheses I'm going to write user. Then I'll duplicate this, and now text data and append text. So after all the data is scraped, we're going to quit the driver. So we write driver.quit to close the browser. And now let's create a data frame so we can export it to a CSV file. So import pandas as PD, and now PD data frame parentheses, and let's use a dictionary. So curly braces, then user, the key, and the list is gonna be user data, and then comma, my second key is gonna be text, colon, and the list. So here is text data. Now I'm going to set this to a data frame named df tweets, and this is going to be exported to CSV. The CSV file I'm going to create is going to be named tweets.csv, and I don't want to show index, so I set index to false. Now I want to print also the data frame so I see how it looks like. And now everything is ready. I'm gonna run this bot. So I press run, and let's see what happens. Well, the driver was open and immediately it was closed because it was really fast. Now everything happened so fast that I think the data wasn't scraped at all because we got the message empty data frame. So this means we need to use waits. So I'm gonna set here just to test this hypothesis. I'm going to use import here time, and then I'm gonna do this time.sleep, and let's set to 5 seconds. So let's test this out. Now run, and let's see what happens. So now the driver should be open in some seconds. Now it's open, then it's gonna wait 5 seconds, and it's supposed to scrape all the data. So let's see. Yeah, it closed, and now, yeah, it was that. So the reason why we didn't get data before, it was because it was too fast and it didn't catch all the tweets on the page. So now that we set to time.sleep 5, it had some time to get all these elements. So all the data was successfully scraped. So let's open the CSV file so we can see this much better. And this is the tweets.csv we just got. And this is the first tweet. This is the second. This is the third. This is the fourth. And this is the fifth. So first of all, Selenium only scraped 5 tweets because those are the only tweets displayed on the page. So on the next video, we're going to scroll down many times and we're going to get many more tweets. But let's analyze the tweets we have right now. So as you can see here, the text has some blank spaces, so it's not well displayed. So we can take care of this. We can use the split and join functions to remove multiple blank spaces. So let me show you here. So we're gonna do some slight changes to this text variable. So I paste text, and now this text is gonna be equal to text dot split. What this split is gonna do is to separate each word in a sentence and put it inside a list. So we're gonna have like each word here, for example, some, skills, to. We're gonna have a list with some, then comma, skills, then comma, to, and so on. So with this, we're gonna get rid of these duplicate blank spaces. But as I told you before, with this, we get a list. So if we want to get back a string, we have to use the join function. Now let's add that join to join these elements of the lists. And now I'm gonna add a blank space. So with this, all the elements within a list will be joined with the blank space. So again, the split will get rid of the duplicate blank spaces and we'll put this inside the list, and the join will turn the list into a string again, using this blank space as a separator. So now let's test this code out. I'm gonna press run, and now let's see the results. So the driver was open, and now all the tweets will be scraped. So now back to PyCharm, and now let's check the CSV file. So I'm gonna double click on the CSV file, and now it has a better format. So all the text is inside a single line, as you can see here. So now back to the script, and now let's write better code by using explicit weights instead of implicit weights. So let's import the necessary libraries. In this case, I'm gonna paste it here so this doesn't get so repetitive. And now let's change the code. So I'm gonna comment this out, and then I'm gonna rebuild this with explicit weights. So I write WebDriver weight, parentheses, driver, then comma, in the seconds we want to wait. Then dot until, and then expected condition is C dot presence of all elements located. So this is the equivalent of find elements, and then double parentheses by dot xpath, then comma. So this here is the equivalent of find elements by xpath. Now we copy the xpath and we paste it here. So this is the equivalent of this code, but with explicit weight. So I'm gonna set this to tweets equal to, and then comment this out. Now let's build a function that is gonna help us scrape the data every time we call it. So we write def, and my function is gonna have the name getTweet. So parentheses, in here as an argument, I'm gonna write element. And then we're going to use this code we wrote before. So I'm gonna cut this and I'm gonna paste it here. Now, instead of tweet context, we're going to use this element context. So element. And now when we use functions, we have to return a value. So we write return. But unfortunately, a function only returns one value. So we have to use here a list because we want to return two values. So I'm gonna set here a list, tweets underscore data, and this is gonna be equal to user, comma, text. So this is how you return a list that contains two values. Now, something I forgot to do before was to use the try except block. So if there is no user or there is no text, we're going to get an empty list or a list with a predefined text. So let me show you here. I write try, and now I'm gonna indent this, the whole code, and now except, and now colon, and here. So if this block fails, we're going to return a tweet data. In here we can just set to blank spaces, but I think I'm gonna use just a string that says user and text. But again, you can use just a blank space. But anyway, I think this is gonna be much better. So remember, the try except block is really useful in case your code breaks because it doesn't find the element. Then we're going to call this function inside this for loop. because as you might remember, we cut this this code and we put it here. So we're going to call it now. So I'm gonna write get tweet, or I'm gonna copy and paste it here, and here I'm gonna use as the argument tweet. So this tweet that belongs to this tweets list is gonna replace this element when we call it. If you have a good memory, you probably remember that before we have tweet.findElement and here tweet.findElement by XPath. So it's absolutely the same. Now I'm gonna set this to a variable. I'm gonna call tweet underscore list. And now instead of appending this user and text that is inside the function, we're going to append this tweet underscore list, which is the result of this function. So with this function, we get a list, which is tweets data, which here is represented by tweet underscore list. So here we're going to delete this and delete this, and instead write tweet underscore list index 0 and tweet underscore list index 1. So index 0, it's the first element, which indicates this user, this user, and index 1 is the second element, which goes to this text element. Now let's apply this join split here to the second element, which is the text. So I'm going to cut this here and paste it here. This is text and this is text dot split. And now all of this inside parentheses and join with the blank space. So here blank space that join, this is the text and that split. So that's correct. So now I delete that. And now I think that script is ready to be tested. So I'm just going to delete this time.sleep because we're not going to use implicit weights. So I'm gonna cut this one too and put it here so it looks much better. So now delete the space and this one here, and yeah, I just wanted the script to look much better. And now I'm gonna run the script and let's see what happens. So I click on run and now it's gonna open the driver, then maximize and scrape the tweets. So yeah, it's scraped. Now back to PyCharm, and well, the data was scraped as we did before. And let's open the tweets.csv. So it's here and it scraped all the data successfully. Now, although this function we just created looks not so useful right now, this is gonna be really useful in the next video when we implement infinite scrolling. So that's it. I'll see you on the next video. In this video, we're going to learn how to handle infinite scrolling. Some websites, like Twitter, are built in a way that if you scroll down, more content will load. This is known as infinite scrolling. And I would say that Selenium is the best choice to handle infinite scrolling. On this video, we're not going to scrape this website that we scraped in the previous video, because in the search we made, we obtained countless tweets. So probably Selenium is going to keep scrolling this page for a long time, and I don't want to make this video so long. Instead, we're going to scrape this second page, which is the Twitter account of Twitter support. You can choose any account you want, but make sure that that tweet that you're going to choose has not so many comments, so Selenium doesn't keep scrolling forever. In this case, I'm gonna choose this first tweet that was published on July 15th, and this one has 334 comments. Probably Selenium is just going to scroll down like 10 times or so. So I'm going to click on it and I'm gonna copy this website. So go back to PyCharm, and now I'm gonna change the website. I'm gonna paste it here and that's it. Then to focus on infinite scrolling, I'm going to comment out the code we've written so far so we can easily see how this is gonna work. So I'm going to comment this out, this one too, and I'm just going to leave driver.quit. So now everything is ready. Okay, to make Selenium scroll down to the bottom, we have to use the execute script method. So we write driver.execute and we choose execute underscore script. Now inside parentheses we have to open quotes and write the following: window scroll to, then open parentheses, and here we have to define the height. So I'm gonna write 0, document dot body dot scroll height, and outside parentheses we have to add semicolon. So this command is basically telling Python to scroll all the way down to the bottom. This second argument is the height of the screen. You can set it to 1080, for example, but if you write this command, it's gonna work for any screen. Okay, now let's see how this works. I'm gonna add a time.sleep 5 seconds so we can see how it works before it closes the browser. So I'm going to right click here and then run this script. So let's see what happens. So now the browser was opened, and now let's see if it scrolls down. So it opened and maximize, and yeah, it scrolled down one time. This is how you make the browser scroll down once, but we want it to keep scrolling until it reaches the end of the website. In that case, we have to use the while loop and set a condition. So let me show you. So first I'm going to write while true, and now I'm going to indent this. As we've seen before, this while keyword keep executing the block here until this condition is false. So as you can see, this is true, so it will never be false. But we can set inside a break to break this code and execute the immediate code below the loop. Now we have to set a condition so it only breaks when Selenium, after scrolling many times, reaches the end of the website. So we can use the height as a reference because as Selenium scrolls down, the height increases. So with every new page, the screen is going to increase. But when there is no more page to load, so when Selenium reaches the end of the website, the height of the screen is going to be the same. So here's when the code is going to break. Now let me show you how we can do this with some code. First, I'm going to create a variable I'm going to name new height. So this is the variable, and now I'm going to set this equal to driver.execute script. So I write double quotes, and here what I want to get is the height of the screen so we can make some comparisons. So to get the height of the screen, we're going to write return and then document that body that scroll height. Well, basically what we had above. Now I'm going to create a new variable named last height. So I copy this and just change here last height, and this is going to be equal to the same code. So I'm just copy here and then paste it. So this is going to be the original height of the website, while new height is going to be the height obtained after scrolling down. So now let's make a condition. So if new height is equal to last height, last height, then colon, and if this happens, so break the code. But if that's not the case, so if new height is different from last height, then last height is gonna be equal to new height. I have to add here the column. So what this block of code does is that the height is going to be updated with each loop. So let's say that the height of each page is 5. So here we'll get a height of 5. Now Selenium is going to scroll down here with this code, then it's going to stop 5 seconds, and here in the new height is going to be 10 because since it scrolled down, now we have 5 plus the new page 5, then it's 10. So 5 is not equal to 10. So the while loop is not going to break, but the last height is going to be set to 10. So to the next loop, and here again scrolls down, so we have a new page, then stop 5 seconds, and then here the new height is going to be 10 plus 5 because now we have 2 new pages. So 5 times 3, 15. And here again 10 is different from 15, and this will keep increasing. So when it gets the value of 20, and it doesn't have more pages to load, this is gonna be set to 20 and last height is gonna be set to 20. So 20 equal to 20 and then the code is going to break and the driver is going to quit. So this is only a trick to make Selenium keep scrolling until there is no more new pages. Hope that makes sense. Otherwise, write me in the comments below and I will answer any question you have. So now I'm going to run this script. So right click here and now run the script. So let's see how it's going to work. So the driver was open again. And now I suppose since there are 300 tweets and one page has about 20 tweets per page, maybe it's going to scroll down around 15 times. Let's see how many times it scrolls down. So now Selenium is scrolling down and this probably is gonna take some minutes. So let's wait. I'm gonna speed this up so you don't have to wait for a long time. So now Selenium reached the end of the website and the browser was closed. So now back to PyCharm. And yeah, the code was successfully executed and that's it. You just learned how to do infinite scrolling using Selenium. On the next video, we're going to implement infinite scrolling with the code we wrote before to scrape Twitter. On this video, we're going to learn how to do infinite scrolling and also scrape all the tweets on Twitter. So first, I'm going to uncomment this code we previously commented out and then these lines of codes. Now I'm gonna delete this and okay, everything is ready to start. First, let me show you how we're going to scrape the Twitter website with infinite scrolling. Twitter has a particular way to load tweets. For example, here we have this random username in the first page. Now, let me copy this username so I can show you something. Now, let's try to find this username pressing Command F or Control F and then pasting this value. So here I have the username and the name, so I don't care about the name, but I'm only going to search the username. So as you can see here, we can easily find the username because we are on the same page. However, if we close this and scroll down, go to other pages, and then try to find this username, so I press again Command F and then paste it. As you can see here, the browser couldn't find this username. So what's going on? Why we can't get the username if we're still on this link? So apparently Twitter only loads the tweets of the page we're currently in. So this means that we'll only get the tweets of the page we're in at the moment we scrape. That is, we'll have to scrape each page as we scroll down and not wait till the end to scrape everything. Unfortunately, one of the disadvantages of this approach is that we might get duplicate tweets because Selenium might catch elements it already located from the previous pages. But we're going to handle these duplicate tweets with sets. So let me show you. Here I'm going to create a set, writing set in parentheses. So in Python, sets are similar to lists, but they store only unique elements. So duplicate elements are not allowed. So I'm going to name this set as tweets underscore IDs because IDs are also unique. And now we're going to work with this code that scrapes the website. So first we're going to define a while loop. So we write while, and here I'm going to create a new variable. This variable is going to be named scrolling. So scrolling equal to true. So I write while scrolling and then colon. So while this variable is true, this while loop is gonna work. Now I'm going to indent these lines of code that let me scrape that Twitter website. And now I'm going to create a new variable named tweet underscore ID. So this tweet ID variable is going to help us filter out duplicate tweets. So we have to create a unique ID from the tweets we scrape. But we can use the username to create an ID. Although usernames in Twitter are unique, a username can publish multiple tweets. So if we set the username as an ID, we'll only get one tweet from that username. Also, the text alone can be an ID because two different users could write the same text. And in that case, we'll just get a tweet from one user and not the other. So what we're going to do is to concatenate the username and the text. To do so, we're going to use the join function. So here we have a list from this tweet list that comes from this function that returns the user and the text inside the list. So we write quotes dot join and then open parentheses, and inside parentheses we copy and paste tweet underscore list. So with this, we make sure that we're going to create a unique ID. Next, we're going to write the following condition. If tweet ID not in tweet IDs, then column, press enter, and here we write tweet IDs dot add parentheses and here tweet ID. So now I'm going to explain you what this means. So as you might remember, the tweet IDs in plural is a set. So here we only store unique data. And here we're going to add the tweet ID. This is the ID we just created before. But we're only gonna add this data if this wasn't previously stored in the tweet IDs set. So if Selenium extracts duplicate data, this is not going to be stored in the tweet IDs set. Then we're going to indent this code. This represents the list that help us create the data frame here. So we use this list to create this df tweets data frame, and the code is not going to change at all. But the CSV that we're going to export, I'm gonna rename it. So it's gonna be tweets underscore infinite underscore scrolling. Now let's make sure that Selenium is just going to take the last 10 or 20 tweets on a page. On average, that's the number of tweets that are displayed on a page. So on average must be around 15. So I write -15 and here colon. So this represents a range that will return only the last 15 elements from the page that Selenium is currently scraping. Remember that Selenium might scrape pages that were already scraped. So with this, we avoid wasting time scraping the same tweets. Now to finish this, let me put the infinite scrolling code we wrote before inside the while loop. So I'm going to delete some spaces here too, this blank space, and I'm gonna paste that code here. And now we have one while loop inside another while loop. So we have to make sure that this first while loop breaks inside this second while loop. So we'll make this first while loop break when the new height is equal to the last height. That is when Selenium reaches the end of the website. So there is no more pages to load. So I just press enter and add here scrolling equal to false. This means that when Selenium reaches the last page, this is gonna be equal to false, and then when it goes to the next iteration, it's gonna set y scrolling, but now scrolling is set to false. So since it's false, then the whole loop is gonna break and the immediate code is gonna be executed. So driver.quit. Now we're also gonna decrease this sleep time because after Selenium scrolls down, we don't want to wait so much time, just the necessary time to let the page render correctly. So I'm gonna write 2 seconds. That will depend a lot on your machine. So if your machine is fast, maybe 2 or 3 seconds will be fine. But if your machine is slow, then maybe 5 seconds or 4 seconds will be okay. Just test it and find the perfect time for your machine and your internet connection. Finally, I need to break this nested while loop on every iteration. This happens because, as I told you at the beginning of this video, we're going to scrape as we scroll down. So we're not going to wait until Selenium reaches the end of the page. So far this code will keep scrolling down until it reaches the end of the page. And this code is only being executed once. But if we write here break, Selenium is going to scrape on every iteration. So let me show you here. Let's say we're in page 1. So we're in page 1, this is set to true, scrolling is true, and it will scrape the first page with this code. Then we're going to take the height of the page, and since while it's true, it's always true, it's going to execute this code. So we're going to scroll down with this code, wait 2 seconds, and then the new height is going to be, well, the height of the first page. And then it doesn't matter if the new height is equal or different to the last height, but the code is going to break and go to the next iteration to scrape the next page with these lines of code. And on the second page, it's going to be the same. It's going to scrape the second page, and then it's going to break here again, and then to the third page, and so on. But when we reach the last page, not only the infinite scrolling here will be broken, but also the scraping process, because here we're setting to false, and the scraping process is also going to break. So the whole thing is going to break. So in summary, we're going to break after we scroll down the page, and only on the last page we're going to break the whole scraping process. So now it's time to test this code out. So I right click, and now I'm going to run this code. So let's see the scraping process. So first the browser will be opened, and now it's gonna scroll down many times. So I'm going to speed up this part so you guys can see the whole process being executed without wasting so much time. So okay, finally the scraping process was finished. So back to Python, and now we have 195 tweets scraped. So let's examine the CSV file created. So I'm gonna minimize this and open the CSV file we created, tweets_infinite scrolling. So I double click on it. So here we can see much better the data scraped. So as we can see, the usernames and the text were successfully extracted. So everything is fine. And now let me show you another way to do this infinite scrolling. So back to the script, and here we can slightly modify this condition. So I'm going to comment this out, and at the same time I'm going to duplicate this. So now I press here enter, and I'm going to uncomment this. So this is going to be a second way to do this infinite scrolling. So I'm going to indent this inside the if condition. And now we're going to use these lists we created before. For example, this user_data, and we're going to set this as a condition. So if the length of user_data is greater than 60, we're going to break the outer while loop and the inner while loop. So this second way to deal with infinite scrolling is just a way to keep scrolling until you get the sample you want. So for example, if you want 1000 tweets of sample, you can write here 1000. Or if you want 100, you can get 100. And Selenium is gonna continue scrolling down until you get this number of tweets. So the first one will scroll down until the end, so we get all the data in a page, while this second condition will only get the data we need. So you don't waste so much time scraping unnecessary data. And that's it. You just learned how to scrape data using infinite scrolling. To install Scrapy, first we have to download Anaconda. So we go to anaconda.com, and then we click on Get Started. Then we click on the last option that says Download, and we check which is our operating system. In my case, I have a Mac, so I'm going to click on the first option. Then wait until the file is downloaded, and in the meantime, I'm gonna tell you why we're using Anaconda. Basically, you can just install Scrapy with pip install Scrapy. However, you need to install some dependencies. This can make the installation a little bit harder, especially on Windows. Fortunately, if you use Anaconda, you can manage this easily. Now I'm gonna open the file that I downloaded and I'm going to click next until the installation process is finished. Now we have to open Anaconda, just double click on the icon. Now we have to wait until the window is opened. Now we have to create a new virtual environment. So we click on the option environment on the left and now we click on new and we give the name of our new virtual environment. In my case, I'm going to name it my underscore Scrapy underscore VNV, which stands for virtual environment. So now you can choose the version of Python and now you click on create. So now the virtual environment is going to be created. You just have to wait until it's done. And once this is created, you have to open a terminal. So click on the play button and then open terminal. And now as you can see, within parentheses is the name of our virtual environment. So now we can install Scrapy correctly. So to install Scrapy, write conda install c condaforge Scrapy. Then press enter and wait until the installation is done. Now here you see proceed. Now write Y, so it means yes to continue the installation, and now wait until everything is finished. To set up PyCharm and an Anaconda environment, we have to write the following command, which Python in case you're on Mac, or where Python in case you're on Windows. Now the output is the path where your Python interpreter is located. So we have to copy this because we're going to use to sync PyCharm with the Anaconda environment. Now open up PyCharm and locate the environment folder that we just copied. So in my case, I'm on Mac, so I can press Shift Command G to go directly to this path. So as you can see here, I have the path. So I'm going to compare it with the path that I got from the terminal. So I have this on my Mac. This is the path I have to go. So you can do it manually in case you are on Windows. So what we want is this NVS folder, So this is what we're going to open on PyCharm. So we click on it and we open this folder inside of PyCharm. And now we have the folder on PyCharm. Now to set up the environment, just go to File and then Settings on Windows, or go to PyCharm and then Preference on Mac. So I'm going to Preference because I'm on Mac, and now we have to click on the option that says Projects and VS. And now click on Project Interpreter. Then we go to this icon, we click on it, and then we click on Add. Then we go to Conda Environment, and then we click on Existing Environment. Then we search our path. We just have to paste the same path we copied before. We paste and we automatically get the Python interpreter. We need to sync PyCharm with the Anaconda environment. So just click on OK and that's it. Now Anaconda and PyCharm are set up. Now the last thing we have to install to finish this process is prod-go. So just write conda install c condaforge prod-go to install this last package we need for Scrapy and Anaconda to work correctly on PyCharm. If you're Mac, you probably have noticed that the folder that contains Anaconda is hidden. If you're on Windows, you shouldn't have this problem, so you can skip this video. Okay, to fix this issue on Mac, just open the terminal and run the following command. ch flags no hidden. Then add the path of the hidden folder. So in this case, I can just drag the hidden folder to the terminal to obtain the path. So I drag it, and now I'm gonna add a space and press enter to run this command. Now, in case you get this message, permission denied, you have to add sudo to the command. So just write the command again, and now add sudo in the beginning of the command. So I'm gonna write sudo, and now you just have to write your password. After you write your password, the command should run successfully, and you should see the folder now unhidden on the directory. And that's it. Now you can see all the contents inside the Anaconda folder. In this video, I'm going to show you the commands available on Scrapy. So first, go and open a terminal. To do so, go to Anaconda and click on the project, and then click on Open Terminal. And then you'll get this window that you see here on my screen. You can also open a terminal inside of PyCharm. Just go to the left corner and click on terminal, and then you'll see the terminal inside of PyCharm. Now that we're on the terminal, let's write Scrapy to get all the commands available. So now I wrote and I run the code, and now we can see the version of Scrapy. In this case, I have the version Scrapy 2.4.1, and we can also see the syntax that we can use to write a command. So we write Scrapy, then the command, and then any option or argument. And then we see the available commands. So we have a list here, and not all of them are so useful. Actually, I don't use all of them. I just use a couple of them in my everyday project. So first we have the bench, and it's just to have a benchmark test, just to see how Scrapy works in our computer. So for example, I'm going to write the command Scrapy space bench to see how it works this on my computer. So let's see how efficient Scrapy is on my machine. So now, as you can see, scraping, it's making a test, and we see the message that the spider was opened. Then we see the number of pages scraped and the speed. And then we have a section with the stats. So we have the request count. In this case, my machine has 462. The response count, which is the same, and other important stats. Now let's see the second command. So write Scrapy again, and now we have the command available. And the second command we're going to see, it's fetch. So fetch helps us get the HTML markup of a website. So we have to write now Scrapy and then fetch. And then we have to write the name of the website we want to get the HTML markup from. So in this case, I'm going to test it with Google. So I'm going to write google.com. So here I got an error because I didn't write the HTTP protocol. So you have to write it as shown in the last line of code. So in the command, write http.google.com, and then everything will work fine. So now I run this command, and you see the HTML markup of google.com. Now let's write Scrapy again to see one of the most important commands available, which is genSpider. This is a command we're going to use often that allows us to generate spiders with a predefined template. So every time we want to create a new spider to scrape a website, we're going to use this command, and we're going to use it a lot in the next videos. Next, we have the settings command that only will display the default setting, and then we have the shell, which is really important to test our code. So if you don't want to create a new spider and you just want to test your code on a website, you can use the shell command to test it. And then we have the start project command, which will help us create a new project on Scrapy. And finally, we have the version command, which will tell us the version of Scrapy that is running on our computer. And that's it. In the next video, we're going to see how to create a new project with the start project command. Now I'm going to show you how to start a new project with Scrapy. First, let's write the command Scrapy start project, and then write any name you want for your project. In this case, I'm going to use the name spider_tutorial, but you can use any other name. Then press enter to run the command, and after that you'll see the message that you created using a template directory, and then that you can start your spider with cd. So you have to change the directory to this new folder you created. Now I'm going to show you how my directory looks like. So I have this envs folder, and inside this folder I have the new spider created, which I named spider tutorial, and inside I have another folder with the same name, and inside that folder it's the spider folders, which will contain all the spiders we're going to create later. Inside this new folder we just created, we also have this scrapy.cfg file, which will help us run commands. And now let's check other files inside the spider tutorial folder. The first file we're going to see is the items.py. Items provide the ability to better structure the data we scrape. We don't have to make use of Scrapy items right away, because we can simply yield page elements as they are structured, as I'm going to show you later. We also have the middlewares.py. Here we can plug custom functionality to process the responses and requests. If you open that file, you'll see that there is a spider middleware and a downloader middleware. I'm going to explain you how they work later. The pipelines.py stores items we scrape in a database, like Mongo or SQL. And finally, the settings.py adds extra configurations to our project. So that's all the files we just obtained after creating the new project. If you didn't understand any of them in particular, don't worry, because we're going to check them in detail in the following videos. Now it's time to create our first spider. But first, let's have a look at the website we're going to scrape. This website is called Worldometers, and it contains the population of many countries. As you can see, the countries are sorted by the population they have. So each country have a detail of the population in the past 50 years. So now I'm going back to my terminal, and I'm going to change directory to this spider tutorial folder as it indicates here in the message we got before. So I do cd spider underscore tutorial, and now I'm located inside my spider tutorial folder. So now to start a new spider, we just have to write the command scrapy gen spider and then the name of the spider you want to create. In this case, I'm gonna name it as the website Worldometer. Then you have to copy the link of the website as it is. So I just copied this link, and now I'm going to delete the HTTP protocol because Scrapy takes care of this. And I'm going to delete the last /2 because Scrapy takes care of this too. With this said, we just run this command to create our first spider. So press enter, and now we got the message that the spider Worldometers was created using a basic template. So we just created this first spider, and now we're going to check this in PyCharm. So now I'm in PyCharm, and as you can see, I'm in the NVS folder, which contains our project we created, which we named spider tutorial. And inside this spider tutorial, it's again another spider tutorial folder, and inside is the spiders that contains all the spiders we're going to create, which includes the Worldometers spider we just created some seconds ago. And I'm going to open it up. So as you can see here, we have the template of this spider. So first we have the name of the spider. If you remember, I named it Worldometers, and that's the name. This name is unique, so you can't create another spider with the same name. You have to use a different name. So then we have the allowed domains. This is the domains that are supposed to be scraped. So if the website has any other, let's say ad or something else with another link, it's not going to be scraped unless it has this worldometers.info domain. So only the links that have worldometers.info are going to be scraped. Keep in mind that we should only leave the root of the page, also known as the home page, in allowed domains. So in this case, we should leave only worldometers.info/. Then we have the start underscore URLs. And as you can see, Scrapy automatically added the HTTP protocol. We have to manually add the S of security, which is in the link of the website. We add it just manually. So then we have this function parse with self and response parameters, and we're going to edit this function to scrape the website in the next video. In this video, I'll explain you some things you need to know about the templates we use to scrape websites with Scrapy. And also, I'll show you how to find elements with Scrapy. Okay, in Scrapy, there are two popular templates, the Scrapy Spider and the Crawl Spider. The Scrapy Spider is the simplest spider and the one we'll use more often in this course. It doesn't provide any special functionality, but we can customize this template to scrape the way we want. On the other hand, the Crawl Spider is the most commonly used spider for crawling regular websites. It provides some mechanisms for following links by defining a set of rules. Note that crawling is not the same as scraping a website. A crawler usually browses the World Wide Web for the purpose of web indexing. But web scraping is more about extracting information from websites. So a crawl spider might not be the best suited for your web scraping project. Now let's have a look at the Scrapy Spider template. So this template has by default a class with the name of our spider. Here we'll send requests from the start underscore URLs spider attribute, and we'll call the spider's method parse for each of the resulting responses. So here we will yield all the data extracted. We'll see this template in action in the following videos, but now it's time to see how to find elements with Scrapy. So in Scrapy we use response to find elements. This is just like the driver in Selenium or the soup in BeautifulSoup. This response represents the response we get after we send requests to a website. Now, unlike Selenium, we can only find elements with XPath on Scrapy. Scrapy doesn't have functions like find element by IDs or class names or tag names, but we can still find these elements writing an equivalent XPath. So to find elements with XPath on Scrapy, we have to write response.xpath and inside parentheses write the XPath syntax we've been using so far. So / tag, square brackets, the @ sign with the attribute name equal to the attribute value. Now, just like on Selenium or on BeautifulSoup, we can find multiple elements with Scrapy. In this case, we have to use getAll to get all the elements with the same XPath. And here again, if you use getAll, you'll get a list with all the elements that match the XPath inside the list. But if you use .get, you will only get a single element. Finally, you'll see later that we'll use a lot the yield keyword. Don't be afraid if you never worked with yield before, because it works the same way the return keyword works when you define a function. However, with the yield keyword, we can return values from a function without destroying the states of its local variable. And that's it. Now you're ready to start scraping websites with Scrapy. Before we start scraping this website, let's test our code with the shell command. So first, we're going to inspect this website. So we right-click on the title and click on Inspect. So as you can see in the HTML of this website, this title is inside this H1 tag. So we can locate this by pressing Ctrl F or Command F on Mac, and then we can find any element by writing the XPath. So if we want to find this H1, we just write H1, but first we write // and then the element highlighted in green is the element we want. So we just verify that this /h1 is the XPath of the title we want. Now let's go back to the terminal to test some code, and I'm going to clean this app. And now let's write the command Scrapy shell. Then you'll get the 3 arrows that indicates that we are in shell mode. So now we can test our code. So let's start by making a request. Just write r equal to Scrapy that request, and then open parentheses. And inside write URL and equal to the URL we just copied before. So I'm going to copy again this Worldometers URL, and now I'm going to paste it. Now I press enter and I can fetch this. So I write fetch parentheses r. Now with this we open the spider and we see the results of this request. Now we can see also the HTML of this website. We just have to write response.body. Here I made a typo, so I have to modify it and write response.body, and now we get the HTML of this website. So it's not in a readable format, but it's just a way to get it. Now we can get also the specific element we want. So we can write response.xpath, and inside we can write the XPath expression we just saw before. So /h1, and we get the element that contains the title, which is countries in the world by population. So now if we want to get only the text and not the whole element or node, we have to write response.xpath, and inside the expression we have to add the text. So we write slash and text with parentheses. Now as you can see, we just got the text element, but we still have the data value. So if we want just to get the plain text, you have to add that get and parentheses. So now I press enter and I just got the text that is the title without anything else. Now let's say we want to get the country names from the list. As you can see, the country names is inside a tag whose parent is a TD tag. So to locate it, we just write /TD and then /A. So now back to the terminal, we're going to write that XPath expression. So we write response.xpath, and now we delete the expression we wrote before and write the expression we just built. So it's TD/A/text to get the text, and in this case, since we have a lot of elements, we have to write get all with parentheses. Now we press enter and we get all the countries listed in the website. So that's it. Every time you want to test some code, use the shell command. In the next video, we're going to build our first spider using Scrapy. Now it's time to create our first spider. So open the worldometers.py file we created before, which is inside the spiders folder. And once it's open, let's edit the parse function. Every time we want to locate an element, we're going to use the response variable. So we write response.xpath, and inside parentheses we write the XPath expression. So we're going to use the XPath expressions that we used in the shell command in the video before, and now I define a title variable which is equal to response.xpath, and inside is the XPath expression we tested before, which is the /h1 that contains the title of the website. Now we include that get to get the text, and the second variable we're going to define is the countries. So this one is obtained with the /TD/A, as I explained you in the video before. So this is equal to response.xpath, and now we write the XPath expression, which is TD/A/text parentheses. In case you don't remember this XPath expression, I highly recommend you check the shell video that is before this one, where we built this XPath expression. Now to display this data in a dictionary, I'm going to use the yield keyword and open curly braces, and then write titles colon title, then comma, and then the country name. So I just define countries and colon countries. And now I'm going to open up the terminal. Of course, you can use that terminal inside PyCharm, but I'm going to use the terminal that I opened with Anaconda, which is absolutely the same. So I'm located in my Spider tutorial folder. This is important. You have to be located in the folder that has the scrapy.cfg file. The name of this folder is the same as the name of the project you created for. In this case, the name of my project is spider_tutorial. So now that you're located in that folder inside the terminal, let's write the command scrapy crawl, and now let's write the name of the spider we created. In this case is Worldometers. I just copy it and now I'm gonna paste it. So I write Worldometers and now press enter, and now we get all the country names and the title. So as you can see here, I have all the countries listed in the website, and that's it. In the following videos, I'm going to show you how to store this data in a CSV file or JSON file. In this video, I'm going to show you how to get the links or hyperlinks listed in a website, so you can get data from those websites too. So far, we've seen the XPath expression td/a/text to get all the text listed in a website. However, with this a tag or anchor, we can also get the href that contains the links in a website. So I'm gonna click on inspect to show you what I'm talking about. So as you can see here, we have that td tag, and inside it I have the a tag, and here I have the href that contains the link we want. So if I write /td/a, I get this node I'm talking about, or this element. So as you can see, this element has the link we want. So I'm going back to the terminal to test some code, and now I'm going to clean this. So I write the command scrapy shell, I open quotes, and now I'm going to copy the website. So I copy the link of the website and I put it inside the quotes. Then I run this command and I open the shell where I can test some code and XPath expressions. So now I'm going to clean this app to show you better the code I'm going to write. So now I write response.xpath, and now I open parentheses. As you may remember, this is the structure we use to get an element with an XPath expression. Now I write /td/a, and now I get all the a tags inside this element. As you can see, it's not well displayed because it's the terminal, but you get an idea of what we'll get with this XPath expression. So now let's go back to PyCharm to implement this. First, I delete text parentheses, and I'm just gonna leave that with /td/a. I'm gonna comment the title variable out, and now I'm going to loop through the country lists. So I'm gonna write for country in countries to loop through this list, because as you might remember, this XPath expression /td/a will give me a list of a tags, which by the way contain the href that has the links we want. Now inside this for loop, I'm going to write the variable country_name, and this is going to be equal to country.xpath. So I'm going to use this country variable as reference. Then inside parentheses, I'm going to use that /. Remember that this that is important because it considers the XPath inside the country variable as a reference. Then I write text with parentheses to get the text, and then I write that get to get this element. Now I duplicate this line of code and I'm gonna define a new variable which is named link. Now I'm gonna edit the XPath expression and I'm gonna write that /at href and then that get. So this at href is gonna give me what is inside this href attribute, which is the links we want. So now just a recap to make sure you understand everything. The countries variable represent all the elements that contain an A tag. There are multiple A tags, so we obtain a list and then we have to loop through it. Inside the loop, we use / text parentheses to get the text inside the A tag and / at href to get the links inside the A tag. Of course, we have to include the $sign before the / to tell Python that we want to use the country XPath as a reference. This country XPath represents the / td/a we define for the countries list. Now I'm going to yield the results inside the loop. So first I copy the country names and link name to this string and also to the variables. Then I indent this yield expression inside the for loop. With this, we make sure that we print every country name and link. Now I go back to the terminal and I write the command Scrapy, crawl, and the name of this spider, which is Worldometer. Then I run this command, I press enter, and I wait till this is finished. So now I'm gonna scroll up a little bit to get the first results. And as you can see, here we can check the country names and also the links. So I'm gonna read one of them. For example, here we have a country name and China in the value and the link world population / China - population. So this means that we got the link of the China country, and I'm gonna go to the website to make sure it's the same link. So I go to the website, and as you can see, this is not the whole link of the website because it doesn't include the worldometers.info/, but only includes a part of the whole link. When you see that the website's full address is not displayed in the link, it means that you're dealing with a relative link. In the next video, I'm going to show you how to deal with this type of links. Okay, in the previous video, we got the relative link of the Worldometers website. This means that we didn't get the full address, but only a part of the link. The full address is also known as the absolute link because it represents the link that we see on the browser, while relative links only have a part of that link. On Scrapy, you can work with both absolute and relative links. And in this video, I'm going to show you how to work with both. So first, I'm going to yield a request. So I write yield scrapy.request, and inside parentheses, I write the URL argument and set it equal to link. So let's see what happens if we go to this relative link as it is. So let's open up a terminal and write the command Scrapy crawl Worldometers. Then press enter and let's see what happens. And now I'm going to scroll up to see the results. So here I found a value error that says missing a scheme in request URL. And then we can see the relative URL, world population / China population. So as you can see, we cannot work with this relative link as it is, but we have to make some changes. So a simple workaround is making this relative link an absolute link. So let's go to the website to show you how we can do this. Here in the website, I inspected one of the countries listed, and here I got an A element that contains the href that has the link of this country. So I click on it, and now we're on this page. So this is the full address, and what I'm highlighting now is the link that we already have in our code. So to make this an absolute link, we have to concatenate this relative link with the main page. So let's go back to PyCharm to show you how we can do this. So here in PyCharm, I create a new variable named absolute_URL, and this is going to be equal to f-string, and here I'm going to copy the main page. So I paste the main page inside the f string, and now I open curly braces to insert a variable. So I put inside the link variable. So we concatenated these two elements. Now in the URL argument, instead of URL, I write absolute underscore URL. Before we test this code, we have to get rid of the last slash in the link inside allow domains. So we delete the slash and go to the terminal. Now I open up a terminal to test this new code and run the command Scrapy crawl Worldometers. Then I press enter to run this command and then we wait. So now this is finished and I'm going to scroll up to see the results, and as you can see, all the data was successfully scraped. The code worked without any problems because as you can see, we got a 200 OK response. So this worked perfect, but this workaround is not the ideal way to handle this. So let me show you a better way to handle this. Now I'm going to comment absolute URL and then relative URL so we can differentiate the method we're using. So we're going to continue doing the absolute URL, but in this case we're going to use the join function. So I'm going to duplicate this line of code, but I'm going to write instead response.url joined, and inside parentheses I'm going to write the link variable. So in this case we don't have to concatenate two elements, but the URL join is going to take care of that. So now I open up a terminal and write Scrapy crawl Worldometers, and then I press enter to run this command. And as we can see, we're still getting the 200 OK response. So now that this is finished, I'm going to scroll up and show you this much better. So here we get the 200 OK response. So this means that the request has succeeded. Okay, so far so good. And now the third way to do this is going to be with relative URL. And to work with relative URL on Scrapy, we have to use the response that follow. So we write yield response that follow, and as an argument we set the URL equal to the link variable we created before. And that's it. We don't need to write anything else because we're using the response that follow. So now let's test this code out. So I'm going to open up the terminal. I clear this up and write the command Scrapy crawl Worldometers. Then I press enter and then we have to wait until this is finished. So now this is finished, and as you can see we got again the 200 OK response. So the request we sent succeeded. And that's it. Now you know 3 different ways to work with relative URLs. In this video, you're going to learn how to scrape data from multiple pages using Scrapy. Okay, we'll continue using this relative URL, but it will work the same with absolute URLs. So far, we're yielding a response that follows the link that we got in the previous video. Each link contains population data of a specific country. Okay, first we have to set a parse function that scrapes all the data of the country links. Now in parentheses, I set as an argument self and response. Now I add this function as an argument in the response that follow. So I write callback equal to self that and then the name of the function. So parse underscore country. So what this callback is going to do is call this parse underscore country every time it goes to a new link. And then with the parse underscore country function, we're going to scrape the data inside that page or link. Now let's go to the website to build the XPath that will help us get the data we want. So first, let's click on this country to get the page that we're going to scrape. So here we have the page of this country, and here it's the table of the population over the past 20 years, I guess. So now I'm gonna inspect this page. So I right click and then click on inspect. So here I inspect the table and we got this element. Now if we scroll up a bit, we can see that all this table is inside a div element that has a table responsive attribute. And below we can see that the table we want is inside this table element. Inside this element you can see the header and the body of the table and also the rows. So we have to build an XPath to locate this table element. Okay, to build the XPath, first we have to copy this long attribute name. and then I press Ctrl F and I start building the XPath with double slash, then the tag name, which is table, and then I open square brackets. Then I write at class equal to, and then I paste the attribute name inside quotes. Then on the right, we can see that two elements match because there are two tables with the same XPath. One is the historical population and the other the forecast. So we only want the historical population. So what we're going to do is to add square brackets to select one element. But first we have to add parentheses to the XPath. So we add parentheses and then we add square brackets with the number 1 that represents the table with the historical population. And now only one element match and it's the table we want. Okay, now to get to the population data, we have to follow this sequence. First, we have to get to the t-body element. And then inside this element is the tr element. This element represents the rows of the table. And inside this element is the td with the data we want. So let's locate these t-body and tr elements. So in the XPath we add slash t-body to get to the t-body child element, and then to get to the tr we add a slash and then tr. Then on the right we can see that 18 elements match. Each element represents a year with population data. As you can see, I can navigate through each year because each of them is inside a row. Now back to PyCharm, and here I'm going to create a new rows variable. But first I'm going to create the XPath. So I write response.xpath and inside parentheses I paste the XPath that we built. Now you can keep this long XPath or you can rewrite it using the contains function. So I'm going to use the first attribute name table to create a second XPath using the contains function. So here it is. The XPath is similar, but just I make it shorter with the contains function. So I said if the element contains a class with attribute name table, match that element, and the rest of the XPath remains the same. Feel free to choose the one you want. I'm going to choose the second one, so I'm going to comment out the first, and now I'm going to create the rows variable. So I write rows equal to, and then I'm going to loop through the rows list. So I write for row in rows, and then colon, and then I press enter. So I'm going to scrape the years in the population. So first I create the year variable. So I write year equal to row.xpath. So I'm going to use this row as a context. Then I go to the browser, and here let's see how we can locate this year data. So the XPath that we have now matches the rows, so the tr elements that you can see now. If we open this tr element, we can see that it contains the year we want inside a td element. And the second td element contains the population we want. So the first contains the year and the second td contains the population. Keep in mind that the population is also inside a tag that has the name strong. Now let's build the XPath of these elements. Okay, now to locate the year, we're going to write inside parentheses that represents that we're using the current row context, and then double slash. Then we write td square brackets 1. And finally we add a slash text with parentheses to get the text. Then outside the XPath we write that get with parentheses. Okay, with this we have the first td element. Now I duplicate this to create the population variable, and now I'm going to change the XPath. So I write td square brackets with the number 2, and between the td element and the text I add the strong element. As you might remember, this element is inside the td and contains the population. Next, I yield both elements. So I write yield, then open curly braces, and then I define the first key. Then I add colon and write the year variable. Now comma, and here I write the second key, which is population. So I write population and then the variable 2. Now let's open up a terminal to run the spider. So I write the command Scrapy, crawl, and then Worldometers. Then I press enter and wait until this is finished. Okay, now let's scroll up and let's see the results. So here we can see the data for the population of the US. If we keep scrolling up, we can see the population of other countries like Spain and Colombia. Now let's store the data into a JSON file. So we write the same command and now we add -o and we write the name of the JSON file we want to create. So I write population.json and then I press enter. So now we wait. And now it's done. So we go to PyCharm and let's open the population.json file. So I double click on it and here's the file with the data we extracted. So here we have the year and the population. So we successfully scraped the page. But as you can see, one variable is missing, the country. So let's add some lines of code to get the country. So we go back to the spider and here in the response that follow, we're gonna add a new argument, the meta argument. So we write meta equal to and then open curly braces. And here we're gonna write the key of the country. Then I write colon and set it to the country underscore name variable. The country key can have any name. For example, I can set it to only country. Now I create a country variable equal to response.request.meta. This meta is the meta attribute we added before. So now inside the square brackets, I'm going to write the country key. So I write country inside quotes. With this, we got the country underscore name from the meta argument. Now let's deal this country variable. So we add a country key and then we set it to the country variable. So we write country colon country. Finally, a recap. So this country underscore name is what we got here from the first for loop. So this one. And the country key, it's just the key from the meta argument. And we call this key in the parse underscore country function. So we call it with response.request.meta and here we call the country key with square brackets. And we set this to the country variable, as you can see here. And finally, we yield this country variable so we can see the results in the terminal and also in the CSV file or JSON file we're going to create. Okay, let's open up a terminal to run this spider. So we write the same command, but now I'm going to change the name of the JSON file to population_2.json. Then I press enter and we wait until this is finished. Now this is done, so we go to PyCharm and open this population_2.json. So I double click on this file and here we can see the data and now we have the country data. For example, this is the population of the country China in the year 2020 and we have also other years. And if we scroll down, we can see the population of other countries throughout the years. So we scraped around 4,000 rows. And that's it. In this video, you'll learn how to scrape multiple pages of a website using Scrapy. Now it's time to learn how to handle pagination with Scrapy. Handling pagination on Scrapy is easier than on Selenium or on BeautifulSoup. I'm going to prove this to you scraping this Audible website we previously scraped with Selenium. First, we'll scrape one page and then we'll scrape all the pages listed. In the end of this section, you'll see the difference between Scrapy and Selenium in terms of speed and complexity of the script. Okay, now it's time to create a new spider. So open up a terminal and write Scrapy gen spider and I'm gonna name this spider Audible. Now I'm gonna copy the link of the website and I'm going back to the terminal and I'm gonna paste this website. I'm gonna press enter to run this command and we get the message that a spider Audible was created using the template basic. Now as you can see, I created this spider in the spider tutorial folder, which is also the name of my project. Now I'm going to show you this on PyCharm and here on my spiders It's the Worldometers spider we created before and also the Audible spider we just created. Now I double click on the Audible spider and now I'm going to get rid of /search inside allow domains because we only want the homepage in allow domains. Next, we're going to add the S of security in the HTTP protocol. Everything is ready to start scraping this website. As a reminder, the name of the spider should be unique. In allowed domains, we should only write the root of the website or the main page. And in start URLs, we have to write the actual website we want to scrape. Let's go to the website to locate some elements. So here, as you might remember, in this website, there are many audiobooks listed. So we're going to inspect to locate the audiobooks. Now we have the developer tools opened and I'm going to inspect an element that contains all the audiobooks listed in the website. I'm going to inspect this first audiobook listed and now I'm going to scroll up a little bit to find the parent or grandparent. So maybe I find the element that contains all the audiobooks listed. I keep scrolling up and I found something. So each audiobook is inside an li element. As you can see here, it's inside the first li element and all of them are inside the div element, which has a class name adbl impression container. So this contains all the audiobooks listed and it's the first element I'm going to locate with Scrapy. First, I'm going to build an XPath to find this element. So I'm going to copy this class name and now I'm going to press Ctrl F to create a new XPath. So I paste here the class name and now I'm going to add quotes to build my XPath. Then I'm going to write class equal to and I add the @ sign and then I'm going to put this inside square brackets and outside I write div and /. With this the XPath is finished and the element was matched and it's highlighted in green. So as you can see, we located the element that contains all the audiobooks listed. Now let's locate each of the audiobook listed. So we add /li to get the immediate li child nodes of the div element. Now as you can see on the right, 20 elements were matched. Each of them corresponds to one audiobook. So I'm going to navigate. This is the first, the second, the third, the fourth, and so on. So it seems our XPath was successfully created. Now let's go back to PyCharm to write this in some code. So first I delete paths and now I write response.xpath and open parentheses. And inside parentheses, I'm going to paste this XPath we just created. Now I'm going to set this equal to and I'm going to create a variable named product_container. This represents the element that contains all the audiobooks listed on the page. Also remember that this new variable is a list because it contains 20 elements. Now back to PyCharm and we're going to loop through this list. So we write for product in product_container and then write colon. Now here we're going to get the author, the title of the book, and the length. To build the XPath of these three new elements, we're going to use the contains function. So we have to find a meaningful word inside the class name. So here in the title, we can use the bc-heading since heading is another word for title. Now let's inspect the author's name to find a useful word to build the XPath. So here we don't have anything useful in this element and above we can see that there is inside the class name an author label. So we can use this author label to build the XPath using the contains function. And below the author label it's the runtime label, which will be useful to locate the length of the audiobook. Now let's go back to PyCharm to build this XPath. So I write product.xpath parentheses and I'm going to copy this XPath we wrote before to help us write this new XPath. I write dot to consider the product node context. So I copy this and now I'm going to paste it here. So now I'm going to delete the class name and the attribute value, and I'm gonna write contains and I add parentheses. So inside the parentheses, I change the equal sign with comma. Now I add a space, and basically this is the syntax of the XPath. Now back to the browser, and I'm going to copy the author label. So this author label is inside a class name, and this is inside an li tag. So now back to PyCharm, and now instead of div, I'm going to write li, and inside contains, I'm going to write add class and then comma, and inside quotes author label. So we use the li tag, the class name, and the author label attribute name. We can verify here that it's correct what we used. And now I'm going to copy the class name value, and I'm going to paste it here just to show you that you can use this to build the XPath. But here I just prefer to use the contains function. But you can use this inside quotes and build the XPath as we usually do. So now I'm going to delete that. Now let's go back to the browser to build the XPath that will return the text. So here we have this li element, and below there is an span element, and below that one there is an a element, and this a element contains the text that we want to extract. So here you can see the name of the author. This is the text that we want to extract, just the author's name. So we have to follow that sequence. First the span, then a, and then text. So we're going to write that here in the XPath. So I write slash and then write span, then another slash to get the immediate child element, and write a, and then slash text with parentheses. Note that I'm using here single slash because I want to get the immediate child nodes. Also, these extra words we wrote for this XPath are necessary only on Scrapy, because remember that when we scraped this website on Selenium, it was enough just the initial XPath we built before it. But since we want to get the text, we have to follow this sequence until we get to slash text parentheses, and then write dot get all to get all these elements. Now I'm going to set this to a variable named book_author. Now I'm going to copy and paste this on the XPath we built on the browser, and I'm going to delete the last slash. And as you can see, 24 elements matched. Now we got 24 and not 20 because some books have more than one author. Now back to PyCharm, and now I'm going to duplicate this line of code to create also the other variables. So first let's check the length of the books. So here in the browser, if I open an li element, we can see that we have a runtime label, and as I mentioned before, we're going to use this element to locate the runtime. So back to PyCharm, and now I duplicate this line of code and create a new variable named book_length. And here inside the XPath, I'm going to use this runtime label. So I copy this, and now I'm gonna paste it in the XPath. So back to PyCharm, and I'm gonna paste it here instead of author label. So here's the class name, and now I'm going to delete this, and I'm gonna leave runtime label. So now back to the browser, and to get to the text, we only have a span element in the middle. So we have to write slash span slash text in parentheses. And instead of get all, I'm just going to use get. Remember that we needed get all for authors because a book can have more than one author, but we don't need this for the runtime, so only that get. I'm also gonna add the single slash that is missing. Now back to the browser to locate the title, so I click on inspect and then inspect the title. In here, as you might remember, we're going to locate this title with the BC-heading. So it's right here, and now I'm gonna copy the class name. So this BC heading is inside an H3 tag. Remember this when we build the XPath. So I copy only BC-heading, and now back to PyCharm. So I duplicate this element, and now I'm gonna name it book_title, and I'm gonna change the attribute value. So I paste BC-heading. Also, instead of li, now we have to write h3 because that's the tag that contains the BC-heading. And to get to the text, we only have the a element in the middle. So we write /a/text parenthesis, and we replace again. Instead of get all, we write just .get. Now it's time to yield the data we just located. So we write yield, open curly braces, and inside this we write the first key. So it's title inside quotes, then colon, and I'm gonna copy this book_title, then comma, and I'm gonna duplicate this twice. So in the second, I'm gonna write author, copy the book_author and paste it. And the last one is going to be length in colon and then book_length. And that's it. Now open up a terminal to extract this data. So I open the terminal, and now I'm going to clear this up, and I'm going to write the following command: Scrapy, crawl, and then the name of the spider, so audible. Then I press enter, and this is gonna take a couple of seconds, and now it's finished. And now I scroll up to see the results, and as we can see, the data was successfully scraped. So we can see the title, the author, and the runtime or length. So for example, this one, the title is American Marxism, and the author Mark R. Levin. So I'm going to clear this up, and I'm going to store this inside a CSV file. So I add -o, and then I write the name of this CSV file I'm gonna create. So I'm gonna name it audible_onepage.csv, and then I press enter to run this command. So then we wait till this is finished, and now that it's finished, we go back to PyCharm, and I'm gonna open the file we just created. So I open this audible_onepage CSV, and you can see here the results in a better format. So let's verify. The first is American Marxism, and it's also here listed with the same author and the same title. And that's it. We just scraped the first page of this Audible website. In the next video, we're going to scrape all the pages available. In this video, we'll scrape all the pages of the Audible website. Let's scroll all the way down and go to the pagination bar. So it's here, and now I'm gonna inspect it. Right click and then click on inspect. The developer tool is gonna open, and then we'll see the LI element that represents one page. So as we can see, each page is represented by an LI element. Let's scroll up to find an element that contains all these pages. And here I found this UL tag that has an attribute named paging elements. So we can use this word to locate the pagination bar using the contains function. And then using this context, we can locate the next page button. Now I copy this class name and go back to PyCharm. Here I'm going to create a new variable named pagination equal to response.xpath and parentheses. I open quotes, and we're going to build an XPath to locate this element. Now I'm going to copy the syntax we used before because we're going to use the same syntax that included the contains function. Now I paste it inside parentheses, and I'm going to delete the tag name, the attribute name, and the attribute value. And also we delete the child elements, so we only have the bones of the XPath. So this element has a UL tag and paging elements inside the value. So I'm going to write UL here and add class, and here paging elements. So I'm going to copy these paging elements, and then now in PyCharm I'm going to paste it inside quotes. Now I copy this XPath and I'll test it in Developer Tools. So I press Ctrl F and paste it. So as you can see, the pagination bar was matched. So we successfully built this XPath. Now I'm going to inspect the next page button. So I click on Inspect and then click on the next page button. Now I'm going to scroll up until I find a useful word to locate this element. So I keep scrolling and here I found next button inside a class. So this can be useful to build the XPath if we use again the contains function. Now back to PyCharm and I'm going to duplicate this line of code. And here I'm going to change the name. So I write next underscore page underscore URL. And I'll use the pagination context for this XPath. So instead of response, I write pagination. And inside the XPath, we have to add the that sign. So now we have to add the span tag. So I write span instead of UL. And now let's see the attribute name. So the attribute is a class and the value is next button. So I paste it here. Now remember that what we actually want to get is the href, because remember that unlike Selenium on Scrapy, we cannot click on a button, but we can get the href to be redirected to a new page. And here we find the href inside the a tag. This href has the link of the next page. So the sequence will be locating the next button, then the a child element, and then the href. And now I go back to PyCharm to write this sequence. So I write /a/add href. And I add that get with parentheses to get this attribute. Now to go to the next page, I'm going to write a condition. So I write if next page URL colon, and then I'm going to yield a response so we can go to a different link. So we write response.follow with parentheses. And inside parentheses, the first argument is going to be URL. And this is going to be equal to next page URL. So this next page URL is going to be this href we extracted before. And the second argument is going to be callback. And this is equal to self.parse. So this condition we wrote means if there is a next page or if the next page exists, go to the next page. But if there isn't a next page, then stop the scraping process. This is way easier than the while loop we use on Selenium. Now to extract data, open up a terminal and write the following command. Scrapy crawl audible-o and then the name of the CSV file you want to create. So in this case, it's going to be named audible_multiplepage.csv. Now I press enter. And this might take some minutes since I'm scraping the 60 pages. When this finishes, we're going to compare Selenium's speed with Scrapy's. Now this is finished and the time it took Scrapy to scrape the 60 pages was 98 seconds. When we scraped the same website with Selenium, it took Selenium 45 seconds to scrape only 5 pages. So we can say that Scrapy is way faster than Selenium. This is one of the reasons why Scrapy is preferred over Selenium. Now let's go to PyCharm to see the CSV file we created. So I open the file audible_multiplepage.csv. And here apparently all the data was successfully scraped. Now I'm going to scroll all the way down to check the last audiobook to verify if it was scraped correctly. So this audiobook is named The Easy Way to Control Alcohol, and then I go to the browser and go to the last page and scroll down until I find the last audiobook, and the audiobook is named The Easy Way to Control Alcohol. So it seems that even the last audiobook was successfully scraped. So this is a good sign that the 60 pages were scraped. And that's it. Now you know how to handle pagination with Scrapy. Okay, so far we've scraped all the pages of this Audible website. However, this website already knows that we're using Scrapy because we're sending requests using the default user agent. Now I'm going to show you how to see the user agent on Scrapy. So first open up a terminal and then write this command. Scrapy shell. Then inside quotes, write the link of the website and then press enter. So here I'm going to wait until this is finished. And now to get the user agent, we have to write request.headers. Then I press enter and we see here a dictionary. And one of the keys of this dictionary is the user agent. So here is the user agent and the value set to this user agent has the word Scrapy. So with this, the website will easily know that we're using Scrapy to scrape the website. So this is not a good practice. So what we have to do is change the user agent so it looks that we're sending requests using Chrome. Okay, first I'm going to show you how to get the user agent you're currently using in your browser. So let's go to the browser and here we right click and then click on inspect. So we click here and then we go to the network section. Then we reload the page to see all the elements and we wait until all the elements are loaded. Then we're gonna click on any HTML requests and we're gonna check the header section. Then we scroll down until we get to the request header section and we look for the element user agent. So I found it here is the last one listed and this is the user agent that is running in my Chrome browser. So I'm gonna copy this and then I go back to PyCharm and then we open the settings.py file. So this is the settings.py file of the project I'm using right now and I double click on it and now I could change the user agent here inside the settings.py file. So here there is a user agent variable and I can change this default value. But I'm not gonna use this option, so I'm gonna comment this out. So another way to change the user agent is going to the default request headers variable inside the settings.py file. So here I'm going to uncomment this and here we can change the user agent. So here I can write user agent inside quotes and then write colon and write the value of the user agent I want to set. In this case, the value I copied before. One of the advantages of this option is that you can change other headers besides user agent. This option is great, but now I'm going to show you a third way to change the user agent inside the code we've written. So back to the script, and here we're going to define a start request function. And inside, I'm going to write scrapy.request. This will take as an argument the URL, so we write URL equal to, and then we copy the URL we are using in start_URLs, and we paste it here inside quotes. Then the second argument, as usual, is going to be callback equal to self.parse. And the third and last argument is going to be the headers. So we write headers equal to and we open curly braces. This is a dictionary and one of the values of this dictionary is going to be user agent. So we write user agent inside quotes and the value of this user agent is going to be this user agent we copied before. So I paste it here. And in this headers dictionary, we can also change other headers besides user agent. Now I'm going to comment out the start_URLs variable because we're already using it in the scrapy.request. Now, since we're using pagination in this script, we also have to include this user agent inside the response.follow. So each request sent per page will have the user agent we want. So inside response.follow, we add a third argument, which is headers. This is equal to open curly braces and we create the user agent key and we set it to the same user agent we've been using. And with this, we finish the script. Now let's open up a terminal to test this code out. So I write the command scrapy crawl and then the name of the spider, which is audible, and then I press enter to run this command. Now I wait until this is finished. And here I got an error. So apparently something went wrong. Let's go back to PyCharm to see what happened. So it seems that in the start request function, I forgot to write the yield keyword. So I write yield, and with this, everything should work fine. So I open up a terminal again, I clear this app and now I run the command scrapy crawl audible again. So here I wait until this is finished, and as you can see, all the pages are being scraped. So I'm not going to wait until all the pages are scraped, but I'm going to stop it with Ctrl Z. And now to prove that we changed the user agent, I'm going to yield a new element. So I write user agent colon, and I'm going to set this to response.request.headers open square brackets and inside user agent. So this is how you get the user agent key inside the headers dictionary. Now I open up the terminal again and run the same command. Now I press enter and I stop this with Ctrl Z. And here, as you can see, apart from the title, the author, and the runtime, we also have the user agent. And the user agent is not set to Scrapy anymore, but to the user agent I have on my Chrome browser. We successfully changed the user agent. Now I'm going to show you a website where you can get user agent from multiple devices. I'm going to leave this website in the notes below. And here, as you can see, you can choose the operating system, the platform, or the software. Here, I'm going to choose the web browser. And here, you can find many user agents that you can copy and use in your code. You can choose any of these options to change your user agent. And that's it. In this video, you'll learn how to change the user agent on Scrapy. In this video, we're going to work with another type of spider called the crawl spider. So far, when we created a spider using the Scrapy genSpider command, we used the default template, which is the basic template. The basic template was made of a class with different properties such as the name, allow underscore domains, start underscore URLs, and also had one parse function. But you can also work with other type of templates. So open up a terminal and write this command, Scrapy genSpider-L. Then press enter and you will see all the available templates. So there is the basic template that we've been using so far in this course, the crawl template that we'll use in this video, and the CSV feed and XML feed that are not used so frequently. Now let's create a new spider using the crawl template. So we write Scrapy genSpider-T and then crawl. And then we write the name of the spider we want to create. In this case, I'm going to name it transcripts. Then let's go to the website to copy the link and then let's paste it. So now let's get rid of the HTTP protocol and then let's run this command. So we press enter to run the command. And then we get a message that says that we created that transcript spider using the crawl template. Remember that I did all of this in the spider underscore tutorial folder, which is the project we've been using so far. Now let's go to PyCharm to see the spider we created. So it's here, it's the transcript.py. So I'm gonna double click on it. And here we have the template of the crawl spider. As we can see, we still have the name property, allow domains, start URLs, but now we have a new property called the rules property, which is a tuple. A tuple works like a list, but they are immutable, which means that once you set it up, you cannot change what's inside it. The rule tuple must contain at least one rule object. The rule object is used to tell the crawl spider what are the links you want to follow in the website that we're scraping. By default, we already have a rule set up. This rule has 3 arguments. The first argument is allow. The second is the callback method, which is set as a string. Unlike we've seen in the basic template, the callback method in the crawl spider must be defined as a string. The last argument is the follow argument. It's a Boolean argument, and when it's set to true, it will send a request to the links extracted. Finally, we have the link structure object. It's used to specify the links that you want to extract or not extract. To define the links we want to extract, we use the allow argument. In this case, it's set to a regular expression, r quotes item. This means if the link contains the word items follow it, and then parse the response in the parse item function. The opposite of this allow argument is the deny argument. In this case, if the link contains the word item, then it won't be followed. There is also the restrict underscore XPath argument. This one restricts the region we want the crawl spider to extract the links. We should write an XPath inside quotes. With this, we will follow all the elements that match the XPath written. Remember that we can have many rule objects. Each rule object will be responsible for following links with different conditions. Now let's see an example with the website we're about to scrape. So we've scraped this website before, and we're going to use this to test this crawl spider. Now I'm going to the website to verify if this link has the S of security in the HTTP protocol. And as we can see, it has the S, so I'm going to write here in start underscore URLs HTTPS. And now let's go to the movies section. So this is the movies section, and I'm going to copy this link and paste it inside start underscore URLs because this is the website that we're actually going to scrape. So I paste it here, and now let's inspect this website. So I right click and then click on inspect, and then we can see the first element. Now I'm going to build an XPath that helps me match all the links in this page. So I write /ul square brackets at class equal to script-list. This is going to match the box that contains all the movies listed. Now I'm going to add /a to get the A tag, which contains the links that we want. Now on the right, we can see that 30 elements were matched, and we can navigate through them. Now we copy this XPath we built, and we paste it here inside the quotes where I wrote XPath expression. And this is going to be part of the rule I'm building. So this is the argument restrict underscore XPath. So we will follow only the links of the elements that have this XPath. Also, as you can see, I didn't add the /@href. This is because the link structure object will automatically search for the href attribute. So we have to omit it. Okay, now in the parse function, we're going to delete this that we have by default, and we're going to print a response.url to test this code out. Then let's open up a terminal and run the following command. Scrapy crawl, then the name of the spider transcript, and then press enter. Then we wait until this is finished. And now that it's finished, we scroll up a little bit and let's see what URLs we got. So here in the last line, we see a URL, the 63rd Annual Grammy Awards. So let's go back to the page to see if this movie is in this page. So we go here to the page, and now I'm gonna scroll up and it's here. So this is the movie, so perfect. Our code is working. So now let's go to one of these movies to scrape the website. So now I open one of these and then I inspect this element. So now we have the code behind this page. And we go back to PyCharm to create a new article variable that we're going to scrape. This is the element in the website. So let's build an XPath to match this element. So it has an article tag and the main article value. So we write /article square brackets at class equal to main article inside quotes. So with this, we successfully matched this element. Now back to PyCharm, and I'm gonna paste this XPath. So I write response.xpath, and inside parentheses, I paste this XPath. Now I'm going to delete this print response.url, and instead of this, I'm going to yield some data that I'm about to scrape. So it's going to be the title and the transcript. So in the XPath, I already have, if I add /h1, I get the title. And if I add /p, I get the plot. So now I'm going back to PyCharm to build this XPath. So I write yield, open curly braces, and here I'm going to set the first key as title. So I open quotes and then write title, then colon, and I'm going to use this value as a context. So the article is going to be my context. So I write article.xpath, and then to specify the current context, we add the dot sign and then slash. So the slash is for the immediate child nodes, and we want to get the immediate h1 element. Then I duplicate this line of code and edit this for the plot key. And then the XPath is going to be ./p. Now let's go back to the browser to get the element that contains the transcript of the movie. So as you can see, the transcript is inside this div element. So let's build its XPath. So to the previous XPath we add /div to get this div element. Now I'm going to open this so you can see that it has many lines of text. Because of this, we will have to use the get all later. Now let's continue building this XPath. So we write square brackets add class equal to, and then we paste the value. So full dash script. Now we copy this XPath we just built and we're gonna paste it in PyCharm. So here in PyCharm, I write the transcript key, and inside parentheses, we paste the XPath we copied before. Now I add /text with parentheses to each element, so we get to the text attribute. So now I add the last /text parentheses, and as you might remember, this last element has multiple text elements. So here in PyCharm, we're going to use get all, but only for the last element. So for the first, we write .get parentheses, and the same for the second. But for the last one, we use get all because this transcript has multiple lines of text. And also, we're going to yield the response.url. We're going to set this to a URL key. Finally, to avoid getting weird values like this one in orange, we're going to use a special encoding. Scrapy doesn't support UTF-8 encoding by default, so we have to add it in settings.py. So we open settings.py, and then in the last line of code, we add the following: feed_export_encoding, and we set it equal to UTF-8. Now everything is set up. I'm going to close these windows I have, and now I'm going to open up a terminal to run this script. So here I write the command scrapy crawl and then the name of the spider, so transcripts. Then I write -o and transcript.csv to store all this data into a CSV file. So now that this is ready, I press enter and wait until this is finished. Okay, now let's go back to PyCharm to see the CSV file we created. So let's open this transcripts.csv file, and here we have all the data scraped. And that's it. In the next video, I'm going to show you how to handle pagination using the crawl template. Okay, now it's time to show you how to handle pagination using the crawl template. So first, let me show you how we're going to scrape all the pages of the website. So let's go to the website, and here we are on the transcript page. So I'm going to the main page here, scroll all the way down, and here we can see the pagination bar. So to scrape all the pages of this website, we're going to click or follow this next page button. So let's inspect this button. So I click on the inspect button and then click on the next page button. So this is inside an A tag. And here we can see some attributes. For example, there's a rel attribute with next attribute value. So we're going to take this to build the XPath. Okay, to build the XPath, we're going to use the syntax of the previous XPath we built. So here, instead of UL, we're going to write the A tag. Then instead of class, we're going to use rel, and as a value, we're going to set it to next. Then we get rid of the /a because we don't need it. Now, as we can see on the right, two elements matched because there are two buttons, one at the beginning of the page and the other in the end of the page. Now let's go to PyCharm to create a new rule. Now I duplicate this first rule I had, and now I'm going to change the XPath. So I'm going to paste the XPath I built inside quotes, and here we have it. Then I will get rid of the callback and follow argument. The reason why I can delete the callback in this second rule is because we already set the callback equal to parse_item, in the first rule object. So when we visit each next page, the parse underscore item will be called. So there is no need to call it again in the second rule. On the other hand, we can omit the follow argument because we're not specifying the callback argument. So if there is no callback argument, there is no need for the follow argument. Another thing you need to know is that the order in the rules matter. So if the second rule was in the first position, we will not scrape the first page. Now let's go back to the browser to test an XPath. So here, as we've seen before, we have two next page buttons. So we can easily select the first or the second button with square brackets. In case we want to get the first element, we write the number 1 inside square brackets. But in case the XPath has some child elements, we have to use the parentheses before the square brackets. With this, we separate the XPath from the square brackets. Now I copy this and then go to PyCharm. So here, inside the XPath, I'm going to replace the XPath I had before for this new one. So with the square brackets. So I paste it here and that's it. With this, the second rule is ready. So with the first rule, we're gonna get the links of all the movies listed in one page. And with the second rule, we're going to the next page. So with these two rules, we're going to scrape the transcript of all the movies available. Now, before we run this spider, we're going to comment out the line of code that gets the transcripts, so we don't get such large text data. Also, to avoid making this video so long, we're not going to scrape hundreds of pages, but only a couple of them. So here in the website, I'm going to the page that contains only movies that start with the letter X. As you can see, there are only 2 pages, so it'll be faster to scrape this one. So I copy the link and then I paste it here in start_URLs. Now let's open up a terminal to run this spider. So we write Scrapy crawl transcripts -o and then the name of the JSON file we want to create. So in this case, I'm going to name it transcripts_letter_x.json. So now we wait until this is finished. And now, as you can see, it only took 6 seconds to scrape 2 pages. And it scraped 47 transcripts. So here, now let's go to PyCharm to open this file. And here we found it. So I'm going to open this JSON file. And here is the data we scraped. So here is the title, the plot, and also the URL. So this is the number of movies that start with the letter X in the website. Now, as you can see, some elements have a null value in orange. This happens because the element wasn't found. And this is fine because some movies don't have plot description, but only title and the transcript. And that's it. You learn how to handle pagination with the crawl template. As you can see, this way to handle pagination is way easier than BeautifulSoup or Selenium and also faster. Now it's time to learn how to change the user agent using the crawl template. As we mentioned before, you can change the user agent in the settings.py file. So here you can uncomment the default request headers and here you got the user agent. So you can change it here as I showed you before. Just set the user agent you want inside the value. So in this case, I'm gonna copy this user agent I extracted before. And also you can change this user_agent variable in case you want to change the user agent. But anyway, I'm gonna show you again how to change the user agent inside the spider. So in this case, in the crawl spider. So first, we're going to set a variable named user_agent. And here we're going to set it to the user agent we copied before. Next, to edit the user agent in the requests we sent, we have to create a start_request function. So we write def start_requests and then we yield a scrapy.request. Inside parentheses, we're going to set the URL and headers argument. So first the URL, we're going to set it to the URL we want to scrape. So I'm going to copy the URL inside start_URLs and copy, and then I paste it inside my URL argument. So I comment out the start_URLs And then the second argument is going to be the headers argument. So here's where we're going to change the user agent. So I set first the key user-agent, and then we write the column and write self.user_agent. So this is going to call the user agent variable that we created before. In addition to that, we also have to edit the rules we created before. So here in the first rule, I'm going to add an extra argument. So it's going to be process_request. And this is going to be equal to set_user_agent. Now I have to create this set_user_agent function. So I'm going to write def set_user_agent, and then in the arguments I'm going to write self, request, and spider. Then I'm going to use this request variable to get the user agent header. So I write request.headers, and to get the user agent I have to use square brackets. So I write square brackets, and inside I write user-agent. Then I set this equal to the user agent variable that we created before. So I write self.user_agent. After this, we return the request variable, and this is going to have the user agent we changed. I almost forgot to add the process_request argument in the second rule. So I write process_request and set it to set_user_agent as we did in the first rule. Finally, just to show you that we changed the user agent, I'm going to yield this user agent. So I write a new key, and it's going to be user-agent, and I'm going to set it this to response.request.headers. And to get the user agent, we use square brackets. So inside square brackets, I write user-agent. Now to run this spider, let's open up a terminal, and then I'm going to create this app, and I write the command Scrapy crawl and then the name of the spider. So in this case, transcripts. Then I press enter to run this command, and we wait until this is finished. So now this is done, and I'm going to scroll up to check the user agent that was printed. So here I have the user agent, and as we can see, it has the value that we specified in our code. So we no longer have the default Scrapy user agent. And that's it. In this video, you learn how to change the user agent using the crawl template. In this video, I'll show you how to export the data scrape into a database. In this example, I'll use the spider that extracts movie transcripts. But feel free to use any spider we built so far in this course. Okay, the first thing we have to do is to open the pipelines.py file. There you will find a class already created with the name of the project. In my case, the class has the name Spider Tutorial Pipeline, but yours will have the name of your project plus the word pipeline. Now, this class has only one function called process_item, which right now only returns an item scraped. Besides this function, a pipeline has two other functions. The first one is called open_spider. So I write def open_spider to define this new function. It has two arguments, self and spider, and this will be called when a spider starts running. I'm going to show you later how this is going to be displayed in the terminal when I run the script. The second function is called closeSpider. I'm going to duplicate this function and then edit it. So I define close_spider. Like the open_spider, it has the self and spider arguments. But in this case, the function will be called when a spider finishes the scraping process. Now to show you these two functions in action, I'm going to import the built-in login module. Now inside the open_spider function, I'm going to write login.warning. And inside parentheses, I'm going to write a warning message so we can know that this is working. when the spider starts running. So in this case, the message will be spider open. And I'm going to do the same in the second function. So I'm going to write login.warning, and in this case, the message will be spider closed. Now I'm going to write a dash and make sure that this message is the pipeline message and not any other message that we can see in the terminal. Now we go to settings.py. Now I'm going to search the word item. So I press Control F or Command F and I write item. So I found this configure item pipelines, which is what I wanted. So I'm going to uncomment these lines of code, and now here we should define the pipeline class we're using. So you have the structure spider underscore tutorial, which is the name of the project, followed by the pipeline's name, and then the name of the pipeline class. As you might remember, my class is named spider tutorial pipeline, but if you change this name, you should change it here too. So keep that in mind. Now let's say that we have not one but two item pipelines. So I'm gonna duplicate this to show you, and now I'm gonna edit this spider tutorial pipeline, and I'm gonna write new action that I'm gonna use as an example. So now let me change the number to 200 to show you what will happen in this scenario. So here we have one item with 300 and the other with 200. So what will happen is that the new action will be executed first and then the spider tutorial pipeline. This happens because a lower number has a high priority. Now I'm gonna delete this and leave this settings.py as it is. So I'm going back to the spiders file, and now let me remind you what we're about to scrape. So it's the title, the plot, the transcripts, and the URL as we did before. Now I'm gonna open up a terminal and I'm gonna clean this, and I'm going to run the command to scrape this website. So I write Scrapy, then crawl and transcripts. I just made a typo here. Now I'm gonna comment out the transcript element so we don't display the whole transcript in the terminal, so I can easily find the warning messages. So I run the code and it's finished now. So now I'm gonna find those two messages that we created before in the open spider and close spider. So what I'm gonna do is scroll up a little bit, and as you can see here, I found a warning message that says spider closed dash pipeline. This is what we wrote before in the close spider function. And now I'm gonna press Ctrl F, and then I'm going to find the first warning message, and as you can see here, I found it and it says warning spider open pipeline. So these two warning messages are the exact moment when the open spider and closed spider will start working. So as you can see, also the scraping process worked as usual. We scraped the title, the plot, and other elements too. And that's it. In the next videos, I'm going to show you how to store this data into MongoDB and SQLite. Okay, now it's time to show you how to store the data extracted inside MongoDB. MongoDB is a NoSQL database. Here, the data objects are stored as separate documents inside a collection, instead of storing the data into the columns and rows of a traditional relational database. To store data in MongoDB, first you have to create a free account. So go to mongodb.com/cloud and then click on the button Try MongoDB Cloud Now to create an account. So in this case, I'm going to sign up with Google. If you signed up with Google, you should see this page now. Now I'm going to accept the terms of service. And now you should see this welcome page that tells you that you just created your MongoDB account on the cloud. So After this, you should see this page. Here I'm going to choose just Python, and then I'm going to leave the other boxes as it is. So I'm going to click continue, and now the website is asking me to choose a path or a plan to create my account. So in this case, I'm going to choose the free option. Now we have 4 options. So let's choose the one that says MD Sandbox. So we get free storage. Now I click on MD Sandbox, and then I click on continue. After this, you should see this page, and on the lower left corner you should see a message that says cluster provisioning. This process will take 3 to 5 minutes, so you just have to wait until this is finished. Now, in the meantime, we're going to install 2 libraries that will need to store data in MongoDB. So to install them, we write conda install, and then we write pymongo and dns python. Then we write hyphen and y, and then we press enter. Now we wait till the installation process is finished, and once this is done, we go to PyCharm to create the class that will help us store data in MongoDB. So now here we delete the last name we had, that was Spider Tutorial Pipeline, and we replace it for MongoDB pipeline. And now we import pymongo. Now the first thing we're going to do is to connect to the cluster we just created. So I'm going to create a variable called self.client, which is equal to pymongo.mongoClient. The Mongo client takes as an argument a special string we'll take later from our MongoDB account. For now, I'm going to leave it as an empty string. Next, I'm going to set self.db equal to self.client with parentheses. Inside parentheses, we should write a database name. This database will be created when the spider is opened. As an example, I'm going to create a database named my_database. Then inside the closed spider method, we only have to close the connection to the database. So we write self.client.close parentheses. Finally, inside the process underscore item, we're going to insert each item script in the database. So we write self.db square brackets. Then we need to set a name to the collection in which we want to store the script items. So let's create a variable called collection underscore name, and I'm going to write equal to transcripts. Now inside the square brackets we call self.collection underscore name, and to insert the item being scraped we use the insert method. As an argument we pass the item we want to insert. This item variable is already considered as an argument of the function process underscore item, so we just reduce this item variable. So now we go back to the browser to see if the process was finished, and we see a message that says your cluster has finished provisioning. Apparently the process finished successfully. So now I'm going to database access, and now I click on add new database user. So here we go to password authentication, and we write a username and a password. So I'm going to write my name, Frank, and the password will be the same, Frank. And then we go to the section that says database user privilege. So here we have to make sure that in the dropdown we choose the option that says read and write in any database. Then we click on add user, and that's it. So the next section we're going to visit is the network access. So we click on it, and then we click on add IP address. Then we're going to write the following IP address to allow access to the database from anywhere. So we write 0.0.0.0/0, and then we click submit, and that's it. Finally, to get the string we need for our Mongo client, we go to clusters, and then we click on connect. Then we go to the option connect your application, and then we'll see this window. Then we choose on server Python and on version 3.6 or later, because that's the version of Python that is running on my machine. Then you see a string that you should copy and paste in the Mongo client. So I'm going to copy this and go back to PyCharm, and here I'm going to paste it inside the quotes. So I have this string, and now we have to replace the password for the actual password we set before. So I'm going to delete the password with the signs on left and on the right, and instead of this I'm going to write my name because that's the password I set before. So my username is Frank and the password is Frank. In your case you should put your password, and well, your username is already written, so it's okay. Finally, I'm going to the spider file to remember what we're going to scrape. So as you might remember, this is a transcript spider that scrapes the title, the plot, transcript, URL, and well, the user agent that we set before, but we're going to comment this out, and then I'm going to uncomment the transcript. So we store this also in the MongoDB database. Now, before we run this spider, we're going to edit the items pipeline that we set in the settings.py file. So I'm going to settings.py, and now I'm going to edit this item underscore pipelines. So I'm going to copy MongoDB pipelines, and I'm going to replace for spider tutorial pipeline, which is the default name of the project I had. So now everything is set to run the spider. I'm going back to the terminal. I clean this, and now I'm going to write the command Scrapy crawl transcripts. So now I press enter and I wait till this is finished. So now everything is done, and now I'm going back to the browser, and we're going to see if the data was stored in the database I created. So here in clusters, we click on the button that says collections. So now you should see the name of the database you created, and inside it you should see the data scraped. For example, I have here the title, the plot, and the transcript. And here I can navigate through the elements scraped. So as you can see, 47 elements were scraped, and the transcript element is an array. But you still can see the content inside it, because apparently MongoDB supports arrays. However, SQLite, which is the next database we're going to see in the next video, doesn't support this. So I'm going to show you in the next video how to turn arrays into strings, and also how to store data into SQLite. So I'll see you on the next video. Okay, now it's time to show you how to store data into SQLite. So SQLite is a relational database management system, and unlike MongoDB, it stores data inside columns and rows. To work with SQLite in Python, we don't need to install any third-party library, but only import SQLite 3. Now I'm going to duplicate this MongoDB pipeline, and I'm going to create my SQL pipeline. So I'm going to name it SQLite pipeline. And now I'm going to edit the functions. So first I get rid of this collection underscore name variable, and I'm going to edit the open spider. So I define self.connection equal to SQLite connect in parentheses. This first line of code will create a database file. We just have to set the name inside parentheses. So I'm going to name it transcripts.db. db is the extension used. So then I'm going to create a cursor object that will help execute SQL queries. So I write self.c. C represents the cursor object, and then this is equal to self.connection.cursor with parentheses. Then I'm going to write a query. So I write self.c.execute and I open parentheses. And inside it, I'm gonna open a multi-line string, and here I'm going to write the SQL query. So if you know a little bit about SQL, this is gonna be really simple for you. But if not, don't worry, because SQL code is easy to understand. So now we write create table to create a table in SQL. And then we write the name of the table we want to create. So I'm gonna name it transcripts, and then we open parentheses to define the columns that will have this transcript table. So the first column we'll set is title. So I write title. I'm gonna copy from the transcript just to make sure it's the same name. So I write title, and then we write the type of data this is. So I write text. Then I copy plot and paste it here. I'm going to duplicate this first, and now I add commas. Now I paste the value I copied before, and now I go back to the spider and copy the next value. So I paste transcript and then paste URL. I'm gonna comment out the user agent, and now I just remember we have to write the data type in capital letters. So I'm going to change this to text in capital letters, and I'm going to copy and paste this to the other values. Now the query is finished. Now to make sure everything is saved, we're going to write self.connection.commit. Now let's edit the process underscore item function. So I'm going to delete this and now write self.c.execute to be able to write SQL code. So now we open parentheses and we write the following query: insert into, and then the name of the table. So I'm going to copy and paste it, and then we open parentheses and we write the name of the columns we defined before. So title, plot, transcript, and URL. Then we write values and open parentheses, and inside the parentheses we write question marks for each column we have. So we have 4 columns, so we have to write 4 question marks separated with commas. With this, the query is finished. Now we have to return the items script. So we write return item. Then we're going to add a second parameter to the self.c.execute. So I add comma and I open parentheses. And now here I'm going to list each item scraped. So I write item.get parentheses. And inside the parentheses, we're going to write each column we defined before. So we copy title and we paste it. Then we duplicate this, add commas, and copy one by one. So plot, then transcript, and finally URL. After this, we make sure everything is saved, writing self.connection.commit. Now let's go to the settings.py to edit the class name. Remember that we changed the class name MongoDB pipeline for SQLite pipeline. So I'm going to copy and paste it here. Then before we run the spider, I'm going to edit the close underscore spider function. So instead of self.client.close parentheses, I'm going to write self.connection.close parentheses. Finally, we have to make sure we don't run into an error when we run this query for the second or third time, because here we create a table and we can't create a table with the same name. So if we run it for the second time, we're gonna get the error that that table already exists. So I'm going to deal with this with a try except block, and I'm going to write try, and I'm going to indent all of this expression, this self.execute with the connection commit. I'm going to indent this inside the try block. Then I'm going to write except, and I'm going to write the error. So I specified the error, which is SQLite 3 operational error. So if Python raises this error, we're going to pass this. With this, the script will not break, in case the table already exists. Now, one more little detail. The transcripts we're about to script are now arrays or lists. So SQLite doesn't support this format, so we have to turn it into strings. So as you can see here in the spider script, we're using the getAll method. So this is why Python gives us a list. So we only have to edit this to get a string instead of a list. So I'm going to write transcript underscore list, and I'm going to copy all of this expression. So I paste it, and now I'm going to define another variable which is gonna be named transcript underscore string. And now I'm going to use the transcript underscore list, and I'm going to use join to concatenate every element of the list with a blank space. With this, the list will become a string. So I'm going to copy this transcript script and I'm going to replace it for the code we had before. So now it's transcript colon transcript underscore string. So now we made sure this transcript element is a string. So back to the pipeline file, and now everything is set. So now I'm going to open up the terminal. I'm going to clean this up, and I'm going to write the command Scrapy crawl transcripts. Now I press enter, and now all this data is being scraped. And also, once this is finished, this is going to be stored in a SQLite database. So as you can see, everything was perfect. Now I'm going back to PyCharm, and I'm going to check if the file is here. So I check and it's here. It's named transcripts.db. So this is the same name we set before in the open spider function, transcripts.db. Now to see the content inside this file, we're gonna go to a website named SQLite Viewer. So we're going to drag this db file into the website, and now all the data will be loaded into the page. So now we can see that we have the 47 transcript scraped. We have the title column, the plot column, transcripts, and URL. So as you can see, all the data was scraped successfully. Now to prove this to you, let's check one movie in particular. So let's check the data of the movie named X-Men The Last Stand 2006, and then we see the page. I'm gonna copy and paste it here. Well, I already have the page, and here we see the plot, and as we can see, it's the same plot. So everything was successfully scraped and stored in a SQLite database. In this video, I'm going to show you how to scrape a website's API. When we scrape APIs, most of the time we won't work with the HTML markup as we did in previous videos. So we won't use XPath. Instead, we'll have to work with a JSON file and parse it in Python. So the website we're going to scrape, it's called Quotes to Scrape. So as you can see, it has some quotes and the name of the author, and if you scroll down, you see a pagination. So you have to click next to go to the next page. But we're going to go to the website quotestoscrape.com/scroll. So you get instead infinite pagination. So as you scroll down, more quotes will appear, which is known as infinite scrolling. Now let's start scraping the API of this website. First, we right click and then we click on Inspect. Now instead of working with the Elements tab, we'll work with the Networks tab. So I click on Networks and you should see this now. After this, we're gonna press on the XHR option, which stands for XML HTTP request. Now I'm going to refresh the website so we get the request of the first page. So I press Ctrl R to refresh the website, and now we can see that there is a new element listed that has the name quotes page equal to 1. So I'm going to click on it to see its content, and I opened this by mistake, but here's the content. So as you can see, this is the headers of this request. So as you can see here, we have the request URL, which looks like the link of the website, but it's not the same link because this one is quotes.toscrape.com/API, while the website's link is quotes.toscrape.com and /scroll. So here, apart from API, it's API/quotes and then the first page. So as you can see here, if you scroll down, you get the page 2 and then page 3 and so on. This is going to be that pattern we have to learn to scrape the API later. Now let's check the preview tab. Here we have what we call a JSON object. Let's check some important elements. Here we have the hasNext element, which is set to true because the next page exists. Then we have the quotes element, which contains all the quotes listed in the website. As you can see here, if I expand the first one, you see the author, the tags, and the text. For example, here you can see some of the tags like change or deep thought, and also here you can see the name of the authors like Albert Einstein. Now let's go back to the terminal to start a new project. So right now I'm located in the spider_tutorial folder. The folder is the one you see now on screen, but we're going to create another folder that contains a different project. So now I'm going to cd into the folder that contains all my projects. So this is the folder nvs, and now I'm going to create a new project by running the command Scrapy start project, and then I'm going to give it a name. So the name is going to be API_project. Now I'm going to press enter to run this command, and now we got the message that a new project was created. So now I can cd into the projects folder, which is the one you see now on the screen. So here is the nvs folder that contains all my projects. One is spy_tutorial and the other is the one I just created, API_project. So it has the same structure with the spiders and all the items and pipelines. It's the same structure as the other projects, but we're starting now from scratch with a new project. Now I'm going back to the terminal. I'm going to cd into the new projects folder. So I write cd API_project and then press enter. Now I'm into the folder and I'm going to create a new spider. So I write the command Scrapy gen spider and then the name of the new spider we want to create. In this case, I'm going to name it quotes. And then we write the name of the website. So I'm going back to the website and I'm going to copy the link. So I pasted the link and that's it. I'm going to press enter to run this command. But before, I'm going to get rid of the HTTPS because Scrapy is going to take care of that. And now I'm going to delete the scroll. So just the main website remains. And now I'm going to press enter. Now I got the message that a new spider quotes was created using a basic template. Now I'm going back to the browser and copy the link inside the request URL, which is the one you see now. So I'm going to copy this and I'm going to PyCharm and open the new spider that we just created, that we named quotes. So I'm open this one and I'm going to paste this link I copied inside stars_URLs. So I just paste it now. Then inside the parse function, we're going to test some code. We're going to delete pass and we're going to print response.body to see how it looks like. Then we go back to the terminal and we're going to run this spider. So we write the command Scrapy crawl quotes. Then we wait till this is finished, and once it's finished we scroll up a little bit and we check the response.body. So as you can see now, we got multiple keys, but the one we want to get is the quotes key because it contains most of the data we want to scrape. Okay, now what we're going to do in PyCharm is to convert the JSON file into a dict to extract anything we want. So first we import the JSON module. So we write import JSON. Then we delete the response.body we printed before and we write JSON_response, which is our new variable that will contain the response. And this is equal to JSON.loads. and inside parentheses we write response.body, which is the response we got before. So here we're just loading the response into a JSON object. Next, we're going to reuse this JSON underscore response and we're going to write that get. And inside parentheses, we write quotes. This will get only the quotes key that we saw before. This key has all the data we're going to scrape later. Now I'm going to put this into a variable I'm going to name quotes. So I write quotes equal to this. And now I'm going to print the quotes to see how it looks like. Now I'm going back to the terminal and I'm going to clean this up and I'm going to run the command Scrapy crawl quotes. So now that this is finished, I'm going to scroll up and I'm going to see what was printed. So here I get the author's key, the text key, and the text. So everything is perfect. So I go back to PyCharm to continue writing some code. Now let's loop through the elements inside quotes. So I write for quote in quotes colon and I press enter, and now we're going to yield and open curly braces to yield the data we're going to scrape. And now I'm going to write author colon and I'm going to duplicate this and add commas. So here what we're going to do is to use this quote element that is obtained from the quotes object and we're going to get some data inside it. Now let's go back to the browser to check one more time the keys. So I go to the preview tab and now we see the keys. So now we see the author key, the text key, and the text key. So the author key has the name and the link of the author's name. So let's get only the author's name and let's go back to PyCharm to implement this with code. So here in PyCharm, inside the author, we're going to write quote dot get and we're going to open parentheses. And inside parentheses, we're going to write author. Now, to get the name inside the author key, we're going to write get once again. And we're going to open parentheses and inside parentheses, we write name. Now, let's go back to the browser and now let's see the second key, which is text. So let's go back to PyCharm and let's copy this code. I'm going to replace the author for tag and now I'm going to delete get name. So we just have quotes that get parentheses tags. Now let's copy this code once again and let's paste it below. So instead of tags, now we write text. So we get quotes that get parentheses and text. Now let me verify if this is the right key. So I go back to the browser and yeah, it's the right key, which is named text. So we finished writing the code and now it's time to test it in the terminal. So I go to the terminal and now I'm gonna clean this up and now I write the command Scrapy crawl quotes and now I wait till this is finished. And once this is finished, I'm going to check the output. So as you can see, this is what we scraped, but let's check this in a JSON file or in a CSV file. So let's put the data into a more readable format. So I'm going to clean this, write Scrapy crawl quotes, but now I'm going to add -o and then quotes.csv, or you can use also JSON. So I'm going to use JSON to export this in a JSON file. So now I press enter to execute this command and now I'm going back to PyCharm to see the new JSON file I just created. So I open this file named quotes.json I created where I store all the data I scraped, and now you can see all the data that we scraped. So you see the author, the tags, and all the keys that we extracted. Remember that Scrapy doesn't support UTF-8 encoding. This is why we get these weird letters in orange. If you want Scrapy to support UTF-8 encoding, add the code shown in screen in the file settings.py as I showed you in previous videos. Okay, now it's time to scrape multiple pages of the API. I'm now in the network tab of the developer tool. In case you're not here, just right click on the page and then select inspect and then go to the network tab. Now let me show you how pagination works in this page. I'm going to scroll down, and as you can see, as I scroll down, more quotes load and also more requests load. For example, I have the request of the page 2 and also the request of the page 3. Now in the preview of page 2 as well as page number 3, we can see that the element has underscore next is set to true. This happens because both pages have a next page that loads automatically when scrolling down. Although this looks like infinite scrolling, there might be a limitation in the number of pages. So let's find out. I'm going to scroll down until I reach the bottom to see what's the limit. So I keep scrolling, and apparently the limit is in page number 10. As we can see, the has underscore next element is set to false now because there are no more pages. So we're going to use this element to deal with pagination. Now let's go back to Python to continue writing some code. First, I'm going to create a variable named has underscore next, and this is going to be equal to JSON underscore response dot get parentheses, and inside parentheses has underscore next, which refers to this has next element in the browser. Now I'm going to write a condition. So I write if has next. So this means that if has next is true, execute the following code. That is, if there is a next page, execute the following code. Now let's go back to the browser to see other elements. Here's the element page. This one represents the page we're in right now. So let's use it in our code. Now I press enter, and now I'm going to create a new variable named next underscore page underscore number, which is equal to JSON underscore response and parentheses page plus 1. This variable is going to help us scrape all the pages. For example, when we're in page 1, this variable will take the value of page 2. And when we're on page 9, the variable will take the value of 10. Now let's yield a Scrapy.request to go to the next page every time the has next variable is set to true. Inside parentheses, I'm going to define the URL we're going to scrape. But first, I'm going to open a f string to concatenate that URL with the next page number variable later. Now I'm going to copy the URL from starts underscore URLs, and now I'm going to paste it. So now I'm going to replace the number 1 with the next page number variable. So I open curly braces, and now I copy and paste the next page number variable. In case you're not familiar with f strings, we use curly braces to concatenate variables to strings. Now I'm going to add the callback argument, and I'm going to write equal to self.parse. Now let's go back to the terminal to run this spider. So now I'm going to clean this up, and I'm going to write the command scrapy crawl quotes -o quotes underscore pagination.json to store all the data scrape into a JSON file. Now I'm going to press enter to run this command, and I'm going to wait till this is finished. So now the process was finished, and now I'm going back to Python to open this file. So I'm going to check here, and this is the file, quotes underscore pagination. So I'm going to open it, and for some reason only one page was scraped. So let's go to the terminal to see what happened. I'm going to scroll up a little bit to see the messages I got. So I see here that I got a type error in line 21. So I'm going to line 21, and here I see that I forgot to put that get. So I'm gonna write now. Now let's go back to the terminal to run this command again. So I write scrapy crawl quotes and then -o, and now the name of the JSON file I'm gonna create. So I write quotes underscore pagination.json. Now I run the command and wait until this is finished. And now that it's finished, I see in the stats that it says item scraped 100. So this is a good sign. So I'm going to open the file in PyCharm, and as you can see now, I have the 100 rows, and this means that all the data was successfully scraped. And that's it. Now you know how to scrape multiple pages of an API. In this video, I'm going to show you how to log into websites using Scrapy. I want to remind you that I'm only doing this particular video for educational purposes. I wouldn't recommend you scrape websites that require login. This isn't a good practice because if the website doesn't want to be scraped, the owners will not only ban your IP, but also your account. So think twice about doing this, even if your intentions are good. That said, we'll continue using these quotes to scrape website because it has a login page that will give us a good idea of how to approach this with Scrapy. Okay, the first thing we're going to do is to open the developer tools. So right click and select Inspect. Next, let's select the Networks tab and then click on the All button and check the Preserve Block box. This will help us store the requests that will be sent when we log in. I'm going to refresh the website with Ctrl R so you can see the requests. Now in the username and password box, you can type anything you want because the website allows any value. I'm going to set the username as admin and the password as admin2. But before clicking on the login button, we're going to clean up the request recorded so far. To do so, click on this button. Now I'm going to click in the login button, and now let's open this first request listed. So in the headers tab, we can see that the request URL is quotes.toscrape.com/login. This request is set to post, and the status code is 302, which represents URL redirection. Before we submitted the form, we were at /login, and after we submitted it, we got redirected to the homepage. This is what the status code 302 represents. Now let's go down to the bottom. In the form data section, we can see a token key, the username, and the password that were sent along with the form. Now to log into this website using Scrapy, we have to provide this form data and then send a post request to quotes.scrape.com/login. One more thing you need to know is that the token is generated dynamically. To see this, I'm going to open a new tab and go to quotes.scrape.com/login. Now I'll open Developer Tools and then inspect the username input. As you can see, inside the input element, there is an attribute set to CSRF_token, and then there is a token value. This token value is generated dynamically, so as I refresh the website, the token keeps changing. Later, when building the spider, we'll copy the token value to send it with the form data. Now let's go to the terminal to create a new spider. So I open the terminal and I'm inside the API_project folder, and inside it I'm going to create a new spider. So far we have the spider we created in the previous video, which is quotes.py, and now we're going to create a new spider. So I'm going to write the command Scrapy gen spider. Now the name of the spider that I'm going to set to quotes_login, and now the name of the website or the link. So I'm going to copy this link and I'm going to paste it here. So I paste it, and now again I'm going to get rid of HTTP protocol, and I'm going to press enter to run this command. So I created a spider quotes_login with a basic template. Now I'm going to PyCharm, and here is the new spider we created. So I'm gonna open it up, and now I'm gonna check if the website has the S of security. And yeah, it has the S, so I'm gonna add it to the starts_URLs. And also I'm gonna delete this last slash. Then inside the parse function, I'm going to define a new variable called CSRF_token equal to response.xpath. And inside parentheses, I'm going to write an XPath expression that locates that token element. So I'm going back to the browser, and now I'm going to locate that token element. So I'm going to press Ctrl F to locate an element, and now I'm going to write /input. So I'm going to continue writing the expression. So I open square brackets and write @name equal to open quotes CSRF underscore token. So now this element highlighted in green is the one I want, but I still need to get only the value. So I'm going to add a slash and then add value to get only the token value. Now I'm going to copy this XPath expression and I'm going to paste it inside parentheses. So I go back to PyCharm and paste it inside parentheses. Now I add .get parentheses, and now I'm going to import from Scrapy import form request. Now I'm going to yield form request that from underscore response, and now I'm going to open parentheses and add the following parameters. The first argument is going to be response, and the second argument is going to be form XPath. Although we have other alternatives like for name or for number, we're going to use for XPath because the XPath in this case is easy to get. The XPath is /form, so we can check this out in the website. As you can see here, you only need / to get to the form element. Now I'm going to duplicate this to write the third argument. So I'm going to edit and write form data. And now I'm going to edit the value, which is going to be set to a dictionary. So I open curly braces to write the dictionary, and inside it I'm going to write 3 parameters. To check the parameters, let's go back to the browser. In here, in the first website we had, in the forms data, we can find the first, which is CSRF underscore token. I'm going to set this to the token variable we created before, and now I'm going back to the browser to check the second and third parameters. And here we see that the username and password are set to admin. So I write username : admin, and then password : admin. So as usual, we have to add the callback argument. So I'm going to write comma and then write callback equal to self.after underscore login. This after underscore login function will help us verify that we're logged in, and we need to define it below. So I'm going to define a function called after underscore login with argument self and response. Now to verify that we're logged in, we're going to locate a logout button. This happens because every time we're logged in, there is a logout button available. So it's going to be our reference. So I inspect logout, and now I'm going to build an XPath to locate this element. So I press Ctrl F and I write /a square brackets the @href equal to /logout. Now, as we can see, the element we wanted is highlighted in green. Next, to get the text, I'm going to add /text in parentheses. Now, I'm going to copy this XPath, and now I go back to PyCharm, and I'm going to write if response.xpath parentheses, and inside parentheses, I'm going to paste the XPath expression we built. Then I'm going to write .get parentheses. This line of code is going to help us verify if the logout text is on the page. Then we write print open parentheses, and we're going to write the following message: successfully logged in. Now let's open up a terminal, and now I'm going to clear this, and I'm going to write the command scrapy crawl _login, and now I'm going to press enter to run this command. And now to verify that we're logged in, let's search the message successfully logged in that we just wrote before. So I'm going to press Ctrl F to search the word successfully, but for some reason I can't find this word. So let's go back to PyCharm to see what happened. So here in allow domains, I forgot to remove the docker/login. Remember that here we should only include the home page, also known as the main page of the website. So now I'm going back to the terminal to run the command again, and I'm going to clean this app, and now I run the command, wait until the process finishes, and now I'm going to press Ctrl F to search the word successfully. And now I found it. So this indicates that we successfully logged in. And that's it. Now you know how to scrape websites that require login. To install Splash, first we need to download Docker. Docker provides the ability to package and run an application in a loosely isolated environment called a container. Containers are lightweight and contain everything needed to run an application, like Splash, so you don't need to rely on what's currently installed on a given host. Okay, to install Docker, go to Google and write Docker Desktop and go to the first option. Then you should see this page. Anyway, I'm going to leave the link in the notes below. Once you're on this page, click on the button that fits better your OS. In my case, I'll click on Mac with Intel chip, but this is also available for Windows and Linux. After you clicked on the blue button, Docker should download. After the file is downloaded, open it and start the installation process. Since I'm on Mac, I have to drag and drop the file into the application folder. In your case, if you're on Windows, just click next until the process is finished. So while this is installing, let's create a Docker account. Okay, I'm gonna open up a second tab and I'm gonna leave this link in the notes too. So once you're here, fill the information required, like an ID, email, and password to sign up. After this, you should see this page where you have to choose a plan. Just go ahead and choose the free plan. Then to finish the process, you have to verify your email address. So check your inbox and click on verify. After you click on it, you should see this verification success page. Once your account is set up, let's sign in. So double click on the Docker desktop app we just installed and click on sign in. Then you should see this window. Just introduce your Docker ID and password to sign in. After you sign in, you should see this window that says Docker engine is starting. Docker is ready to use when you see that green bar in the left bottom corner. Now let's install Splash. First, open up a terminal or a command prompt and write the following command: docker pull scraping hub/splash. Then press enter to run this command, and you should see now many files being downloaded. What we're downloading here are images. When you use Docker, you are creating and using images, containers, and other objects. An image is a read-only template with instructions for creating a Docker container. Okay, after the process is finished, we have to run a second command. This second command is going to help us run Splash on a browser. So I'm going to clean this app and now I'm going to write the command docker run-it-p 8050:8050 scraping hub/splash, as you can see on the screen. So now that the command is completed, I'm going to press enter to run this command and I'm going to wait until the process is finished. Now you should see a message that says server listening on HTTP and then a link. Copy this link and then paste it on the browser. So I'm going to paste it here and now you have Splash on your browser. So as you can see, we have here Splash 3.5 and you can write any code here on the right box. I'm going to teach you how to write code in Splash later, but now let me show you a faster way to run a Splash instead of running this long command. So the next time you want to open Splash on the browser, just open Docker and on the dashboard you should see a new container we just created. A container is a runnable instance of an image. You can create, start, stop, move, or delete a container using Docker. So the next time you want to run Splash on a browser, just click on the play button. And if you want to get the link, just click on logs to see the details of the command run, and then you can copy and paste the link on your browser. Okay, that's it for this video. In the next one, I'm going to show you how to write code on Splash. In this video, we'll learn how to write code on Splash. So as you can see now, Splash runs on a browser. This is the user interface. On the right, there is a white box. There you can introduce the website you want to scrape. And below you can find the code you have to write to interact with the JavaScript website. That is, this script is going to take care of things like clicking on a button, introducing text, and setting weights. So the parsing is still going to be executed on Scrapy. This is different from Selenium, where we can do both in the same place. Another big difference between Selenium and Splash is that you can write Python code on Splash. Splash uses another programming language called Lua. I know that learning another programming language is time-consuming, but believe me, Lua is an easy programming language. And in this video, I'm going to teach you the basics so you learn all the essential stuff for scraping a website. So let's start with this brief introduction. So I'm going to zoom in so you guys can see this code much better. And here you can see a demo code that appears every time you open Splash. I'm going to delete it so we start writing code from scratch. Okay, what we're going to do is to use Splash to go to Google and get the HTML code and a screenshot of the website. To do so, let's define a function. After writing function, we should write main. And inside parentheses, include the argument splash and args. Every time you write a function in Lua, you should write the word and below the last line of code. Now, to go to a website with Splash, we have to use a function called go. So write the following: splash :go and open parentheses. Now, you should define the URL of the website by writing URL equal to args.url. In the white box above the code, you can see that we set the URL to google.com. Feel free to modify this link with any link you want. To try this simple code, we'll test in this video. Now, inside parentheses, you could write args.url, but since I already defined that expression as URL, I'm gonna write just URL, which is the variable I created. Now, to get the HTML and PNG screenshot, we have to use the return keyword. So we write return, and then we write splash :png with parentheses. This will get a screenshot of the website. So let's test it out. So just click on the green button that says render me, and let's see what happens. So let's wait, and now we can see the screenshot that Splash took. So in this page, you still have access to the Lua code. Here we can modify the code if we want. So let's edit PNG and let's write HTML instead, and then render. Click on the green button and let's see what happens. So here we can see the HTML code behind google.com, and now we can also keep editing the code. So now to improve the readability of the code, let's add curly braces, and now let's define two variables. So I'm going to press enter, and now I'm going to introduce a variable called HTML. So I'm going to write HTML equal to splash :HTML. Now I'm going to duplicate this and add comma, and now I'm going to add the variable PNG, which is equal to a splash :PNG and parentheses. Now to test this code out, just click on the green button that says render. So I'm going to click on it, and now I'm going to wait. So here you can see that there is the screenshot of Google and also the HTML code. So everything was perfect. Now, what if I write an inexistent page? So I'm going to write google.com123 to try this code. So as you can see, the code doesn't break, but only gives a blank page with a message that says failed loading page. If you've been writing Python code for a while, you should be used to getting an error message that tells you which line of code breaks the whole script. So we can get this in Lua too. Just open the script and now include the assert function. So I'm going to write here assert, and wrap up this code with parentheses. So if the code breaks, we'll get an error message. Now let's click on render to test this code. So as you can see here, we got an error message. This error message might come in handy to fix the code. Now, just like on Selenium, we can add weights so we let the website render correctly if necessary. So let's write assert parentheses and inside parentheses write /weight with parentheses. And inside that parenthesis, just include the seconds you want the website to wait. So I'm going to write 2 seconds as an example and then click on render to test this code. Now, naturally, the process will take 2 seconds more because we set a wait. And now just got the result, and is the screenshot and the HTML code. So the code is still working. And that's it. You just learned the basics of Lua and Splash. In the next video, I'm gonna teach you some more cool stuff you can do. In this video, we'll learn how to find elements with Splash. Okay, what we're going to do is to go to Amazon and find this search box and then search for books and then click on the search button. To do so, first let's inspect the website. So right click and then click on inspect, and then as we can see here, the element that corresponds to this box is the input tag or the input element that you're seeing right now on screen. So this element has an ID which will help us easily locate this element. We're going to copy this ID and then go back to the splash page to continue writing some code. We're going to use the code we wrote in the video before. Although we use it for interacting with Google, this code is the base for interacting with any website. Okay, the first thing we're going to do is define a new variable that I'm gonna name input_box. This is gonna be equal to assert parentheses /select. Here, just like on Selenium, we have 2 options, select and select _all. The first will select only one element, while the second will select multiple elements. Now, inside parentheses, we should write the ID we copied. But on Splash, we can't just write the ID name, but we have to use the CSS selector. Unfortunately, we can't use XPath either, but don't worry, because CSS selectors are easy to write. Okay, to write the CSS selector of the ID, we have to write the # followed by the ID. So, # 2-tab search text box, which is the ID we copied before. And that's it for the input box variable. Now let's modify the link we're going to scrape. So we write amazon.com in the white box. Next, before we can send some text to the input box, we have to use a function named focus. Every time we want to use an element located, we have to use the focus function. So let's write input_box :focus with parentheses. Now to send text to this input box, just write input box :send_text with parentheses. This send text is similar to the send keys we've seen on Selenium. Inside parentheses, we have to write the text we want to introduce. So I'm gonna search for books, but feel free to search for any product you want on Amazon. Now to let the page render the results, I'm gonna add a 2 seconds wait. So I write assert and then I'm gonna copy the /wait. With this, the code is ready to be tested. So I'm gonna click on render me, and now I'm gonna wait for the screenshot and HTML code. Since we added 4 seconds of wait in total, this could take a bit more than usual. And now we got the results. So as you can see, the text was successfully introduced and the search suggestion was displayed. So far so good. So let's go back to the browser to locate the search button. So we click on inspect and then we click on the search button to locate the element. Then let's copy the ID and go back to Splash. Here we're going to create a new variable called button, which is equal to assert parentheses /select. And inside parentheses, we have to write again the CSS selector. To write the CSS selector of an ID, we write the hash sign followed by the ID we copied. Then we have to click on the element. So we write button colon mouse underscore click with parentheses. As you can see, some of the functions in Lua code are similar to those we use on Selenium. Now I'm gonna add a wait to let the page render the results after we click on the search button. So I'm gonna copy this wait we wrote before and I'm gonna paste it. And I'm gonna leave this to 2 seconds. Now let's click on render to test this code out. So I click on render and now let's wait until this is finished. Now the process is finished and now on the screenshot we can see that the images don't display correctly because the wait is too short. So let's add more seconds. So I'm going to open the script and now I'm gonna write 5 seconds instead of 2 seconds. And now render the script and wait until this is finished. And that's it. Now we can see that the page is loaded correctly. On the next video, I'm going to show you how to use Splash with Scrapy. Okay, now it's time to start scraping JavaScript-driven websites with Scrapy and Splash. In this video, we'll focus on Splash. So we'll write code in Lua that help us load this JavaScript-driven website and interact with some elements. Okay, we'll work with this website that we scraped before with Selenium. We'll click on the All Matches button and scrape all the tables as we did before. So you can compare the performance between Scrapy and Selenium. Now, before using Splash, you have to make sure that this website runs JavaScript. So right-click and click on Inspect. Then go to Settings and scroll all the way down and locate the debugger section. Then disable JavaScript and reload the page. So as you can see, this page doesn't load at all. So it means that it runs JavaScript. So I'm going to uncheck the disable JavaScript and I'm going to reload. And as you can see, all the data loads as usual. By the way, every time you load this page, a loading message will show up. So this means that most likely we'll need to use waits. Now let's open Splash. And now I'm gonna delete this code that shows up by default on Splash. Now I'm going to paste the link of the website we're going to scrape. I'm gonna leave this link in the notes so you can copy and paste it too. Now it's time to write some code. First, we're going to tell Splash that we want to go to this website. So we write splash colon go and inside parentheses we write args.url. Splash colon go is how you tell Splash the website you want to visit. Now we have to insert this inside the sort function. So if something goes wrong, Splash will throw us an error. And with this we can debug our code. Now, as you might remember, the website we want to scrape needs a couple of seconds to load all the content correctly. This is why we need to use waits. So we write splash colon wait and inside parentheses we're gonna set it to 3 seconds. Then we're gonna use the sort function again. So we copy and paste assert and put splash colon wait inside parentheses. Now let's go to the website to locate the all matches button. Here on the website, I'm gonna right click and then click on Inspect. Developer Tools is gonna open and now we have the code behind the buttons. So this div element contains these 2 buttons. Now remember that unlike Selenium, we can't use XPath with Splash, but only CSS selectors. So let's analyze how we can locate this All Matches button with CSS selectors. So we can see that both elements have a label tag, and also they have similar class names. Both have in common the btn, btn-sm, and btn-primary. However, they are not the same because one class name has the word active and the other not. This is enough to locate this element with a CSS selector. I know we haven't used so much CSS selectors in this course, so let me show you how we can locate elements with CSS selector. You can build an CSS selector with the tag name and the class name. You just have to put them together and instead of writing a space, you have to write the dot sign. If you inspect an element, you can also immediately get the CSS selector. So for example, the CSS selector of the All Matches button is this one. There you will always find the right CSS selector, which, as I told you before, is built with the tag name and the class name. Unfortunately, this long CSS selector might break with minimum changes. So if we want to write better code, let's use a smaller version. What I'm gonna do is use the first 3 words in the class name. As you can see, these 2 buttons have these 3 words in common in the class name. So we'll match both of them, but then we'll choose only the one we want. Now let's go back to Splash to continue writing some code. Here I write splash select underscore all to select all the elements that match with the CSS selector I'm about to write. Now inside parentheses, I'm going to paste the 3 words inside the class name I copied before. I add the label tag name, and instead of blank spaces, I'm going to write the dot sign. So this is how you build a CSS selector. Next, I'm going to copy and paste the assert function and put this code inside parentheses. Now this select all will return a list with multiple elements. So let's create a variable and then index to get the item we want. I'm going to set this equal to all underscore matches. Next, I'm going to write again all underscore matches and open square brackets, and inside I'm going to write the number 2. This number represents the position of the element we want to get. So in this case, we want to get the second element. Let's go to the website we're scraping so I can show you why this is the second element. Here there are 2 buttons. The home away split corresponds to the first label element, while all matches corresponds to the second label element. So this is why we wrote the number 2 inside square brackets before. Now we have to add mouse underscore click with parentheses to click on this button. So now let's add one more wait. So we'll let the page load after we click on this button. So I copy this splash wait, and I'm going to leave the time as it is. Now to display the whole page and not only a small window, we have to write splash set underscore viewport underscore full with parentheses. With this, we'll make all the content of the page visible. Now I'm going to return a screenshot and the HTML code. So I write return, open square brackets, and then write splash HTML with parentheses, then comma and splash PNG with parentheses. And with this, we finished writing the code. So I'm gonna click on render me. But first, I'm gonna change the order so I get the screenshot first. So now everything is set, and I'm gonna click on render me. And now the page is loading. This could take a couple of seconds, so let's wait until this is finished. Once this is finished, we should get the screenshot of the whole page. So now the process is finished and we got a screenshot. So I'm going to download to show you. So I'm going to open this screenshot, and as you can see, all the page was successfully loaded. And also, as you can see, the all matches button is selected. So there is one table per team, and the tables are not split by home or away team. Now I'm going to close this screenshot to show you something that you might need in case the website doesn't render correctly. We're going to open the script, and here we're gonna disable private mode. So we write splash.private underscore mode underscore enabled, and we set it to false. So with this, we disable private mode. Private mode is the equivalent of Google's incognito mode. If private mode is enabled, some websites might not render correctly. And that's it. We're gonna use this Lua code in Scrapy to scrape the JavaScript-driven website. But we're gonna do that in the next video. In this video, we'll learn how to work with Scrapy and Splash. So first, I'm gonna install a library. So I open up the terminal, and you can use the one that is inside of PyCharm, or you can open it with Anaconda. But before installing libraries, I'm gonna create a new project. So I write Scrapy start project, and then the name of the project. So I write splash underscore project, but you can name it as you want. Now I'm gonna press enter to run this command, and now it says that we can start a spider with cd splash underscore project. So I'm going to clear this up, and then I'm gonna write this. So I write cd splash underscore project. So once I'm in the splash project folder, I'm going to create a new spider. So I write Scrapy gen spider and then the name of the spider. So I'm going to name it Adam Choi, like the name of the website. And then I have to write the link of the website. So we go to the website and we copy the link. So this is the website, and now I copy the link, and now back to PyCharm. And here I paste the link. I'm gonna delete the HTTP protocol and leave only the main page. So this one. Now I press enter to run this command. And now we got the message that a new spider was created using a basic template. So far so good. Now as you can see, in my main folder I have a new folder named splash underscore project. This is the project we created, and inside spiders is the Adam Choi spider we created. Now we have to go to this page on GitHub to get the code to install the library we need to work with Scrapy and Splash. So I'm going to leave this website in the notes, and then you have to copy this code that you see. So I'm going to copy this code and I'm going to paste it here. So it's pip install scrapy-splash. Now I press enter to run this command, and the library was successfully installed. Now we also have to make some changes to work with Scrapy and Splash. First, we open settings.py, and then we go to the GitHub page, and here we're going to scroll down, and inside configuration we're going to copy this first line of code that says splash underscore URL. So we copy this, then inside settings.py we scroll down and paste this line of code. So this is the default value of splash underscore URL. But if you installed Splash the way I showed you in this course, you have to change the value inside quotes. So instead, you have to write the local address you're using in the Splash website. So let's go to the Splash page, and here we have to copy these numbers, and then I'm going to write http://localhost and :8050. This is the number that is in the splash page link. Next, let's go back to the GitHub page and copy the code that is in number 2. As you see in instructions, you should paste this inside settings.py. Now back to the GitHub page, and let's copy the code that is in the third step. So we copy and paste spiders middlewares inside settings.py. Next, we copy the code inside step 4, and we paste this one inside settings.py too. And with this, all the setup is done. So now let's start writing some code. First, let's go to Splash to copy the code we wrote in the previous video. So I'm gonna copy all this code, and then I'm gonna open the spider we created before that we named Adam Choi, and here we're gonna create a new variable named script. So I write script equal to, and then here I'm gonna set triple quotes, and inside I'm gonna paste the Lua code we wrote before. So this code is gonna be inside the script variable. Next, I'm gonna comment out the starts underscore URLs because we're not gonna use it, and instead we're going to define a new function. So I write def and then start underscore requests. Then we write from scrapy underscore splash import a splash request. Here we're using the library we installed at the beginning of this video. Then I'm going to write inside the start request function yield and then splash request, and inside parentheses I'm going to write URL equal to, and here I write the link of the website we want to scrape. So I copy the link of the website and I write it here inside quotes. So the reason why we don't use start underscore URLs is because we set the URL inside a splash request. Then, as usual, I'm gonna add the callback argument and set to self.parse. And as a third argument, I add endpoint equal to execute. And I add one more argument, args, equal to open square brackets, and inside we write lua_source and colon self.script. This self.script will call the script variable we defined above. And finally, inside the parse function, I'm going to print response.body. This is just to test if the code we've written is working. And it also means that we set up Scrapy and Splash successfully. So let's open up a terminal to test this code. So I write Scrapy, crawl, and Adam Choi, which is the name of the spider. Then I press enter to run this command. Now let's wait until this is finished. So remember that we set some waits in Splash, so this could take a couple of seconds more than expected. So finally, this is finished. So as you can see, we got the response.body, and it means that the code was successfully executed. So far, we successfully set up Scrapy and Splash. In the next video, we'll start scraping the website. Okay, now it's time to scrape the website. With the Lua code we've written so far, we obtained the HTML code of the website. Now it's time to use that code to locate elements and extract the data we want. Now let's go to the website to build the XPath we need to scrape the data. So we right click and then click on inspect. Then developer tools is gonna open, and since we inspected the data inside the table, we got this TR element. So the TR represents the rows and the TD represents the columns per row. So we have 4 TDs, so 4 columns, and 1 TR per row. So we're going to use these elements to build the XPath. So we delete this and then we write response.xpath, and inside parentheses we write /TR to locate every row inside the table. So we can test this XPath. We press Ctrl F and then write /TR, and this XPath will match each row inside the table. So back to PyCharm, and now we're gonna set this equal to a rows variable that I'm gonna create. Now, since the XPath matched multiple elements, we obtain a list, and we have to loop through a list. So we write for row in rows, colon, and then inside the for loop, we write row.xpath. And now let's go back to the browser to build this XPath. So as we can see, there is a TD inside the TR parent. So the first is for the date, the second for the home team, the third for the score, and the fourth for the away team. If I write square brackets 1, I get the date. As you can see, I can navigate through the dates. And if I write 3, I get the score, so I can navigate through the scores, as you can see here. So I'm going to use this XPath and go back to PyCharm to build the XPath. So first I write that to use the current row context, and now I paste the XPath we built before. So this is the XPath, and now we have to delete the /TR because it's already included in the dot sign. So we only leave dot, /TD, and square brackets. Now inside square brackets, we're going to use the numbers 1, 2, 3, and 4 to locate the first column, second column, and so on. After this, I write /text with parentheses, since there isn't any element between TD and the text. Then I write .get with parentheses to get the text element. Now I add this /text to the XPath we built before, and as you can see, it matches the text successfully. Now I'm gonna copy this and paste it in PyCharm to make a recap. So as you can see here, the /TR is considered in the rows element, and the rest of the XPath, so TD, square brackets 3, and /text is included after the dot. So the dot is for the current context, and then we write the rest of the XPath. That said, let's continue scraping the website. So I'm gonna set this to a date variable, and now I'm gonna create a variable for each data. So here we have 4 columns. So I'm gonna duplicate this 3 times. And now I'm going to change the number inside the brackets. So I write 1, 2, 3, and 4 because there are 4 columns. Now the first is for the date, the second for the home team, the third for the score, and the fourth for the away team. This is just how the columns are ordered in the website. Then I'm going to yield each variable. So I write yield and open curly braces, and now I write date colon date. So the first is the key and the second is the variable. And then I duplicate 3 times to get all the elements. So now I change the values. So home team, score, and away team. And now the script is finished. Now let's open up a terminal to run this spider. So I'm gonna clear this up and then I'm gonna write Scrapy crawl, the name of the spider, so Adam Choi, and then -o, and I'm gonna store this inside a JSON file. So I write football underscore data.json. Then I press enter to run this command and we have to wait until this is finished. All the data was scraped and now I'm gonna open the file we created. So we name it football underscore data.json. So I double click on it and here we have the file and apparently it has all the data displayed in the website. So now let's verify. So the first match should be Fulham Arsenal and it's correct. Now let's check the last match. So I scroll all the way down and the last match is Wolves with Man United. So I scroll down in the website too and now let's check. And yeah, it's correct. So all the data was successfully scraped. Did you just learn how to scrape websites with Scrapy and Splash? We've seen again how faster is Scrapy compared to Selenium. In this video, I'm going to show you different ways to change the user agent on Splash. If we don't change the user agent, we'll send requests using the default user agent. This is not a good practice because it will reveal that we're using Splash to scrape the website. So what we have to do is change the user agent so it looks that we're sending requests using Chrome. We'll continue using the script we wrote in the previous video. Okay, let's start with the easiest way to change the user agent on Splash. If we want to change the user agent, we write splash set underscore user underscore agent, and inside parentheses we write the user agent we want to set. So I already copied the user agent from the user agent page we've seen before. In case you don't have it, I'm going to leave the website in the notes so you can get the user agent of multiple devices. So in this case, I'm using this Mozilla 5.0 user agent that I copied before, but feel free to use any user agent as long as it's not the default user agent used on Splash. Now this is done and we can render the script. So I click on render and then let's see if the script still works. So I wait here and now I can see the screenshot and let me see if it's working fine. So apparently it's working fine because I can see all the tables. So now let me show you a second way to change the user agent. This second way to change user agent will also help us override other request headers. So we write headers equal to and open curly braces. Then we open square brackets to set the user agent key. So we write user-agent inside quotes. And then we set this equal to, and here inside quotes we write the user agent we want to set. So I'm going to set this again equal to Mozilla 5.0. Now I'm going to set the custom headers to the headers variable we just created. To do so, we write splash set underscore custom underscore headers, and inside parentheses we write headers. So with this, we're telling Splash that we want to use the headers inside the headers variable we just created. Now let's render this script to see if this still works. So I'm going to click on render and then I'm going to wait until this is finished. So now we got the screenshot and the HTML code. In here, I'm going to download the screenshot. And as we can see here in this screenshot I have here, all the data in this page still loads correctly. Now I'm going to open the script, and remember that this second way to change user agent will allow you also to change any other header and not only the user agent. So now I'm gonna comment this out so I can show you a third way to change the user agent. Okay, this last way to change the user agent will not only help you change the user agent or the header, but will also register a callback function that will be called on each request. To do so, we write /on_request, and inside parentheses, we write the callback function, which will take the request object as an argument. Now to change the headers, we write request:set_headers, and we open parentheses. Then I write end to close the callback function and write user-agent, then comma, and we set that user agent value that we copied before. Now I'm going to click on render to test this code. So now I wait until this is done. And as we can see, here we got the screenshot, and apparently everything is working fine. So I'm going to download the screenshot and I'm going to zoom in to see the page, and all the data was loaded correctly. And that's it. In this video, you'll learn 3 different ways to change the user agent. Alright, before showing you how to make visualizations with pandas, first we have to check the dataset, and also we have to make a pivot table so we can easily make the plots with pandas later. So first we have to import pandas to read this CSV file, and well, I have this import pandas as PD, so we just run this code, and now let's read this new dataset. So as you might remember, to read a CSV file, we have to use the read_CSV method. So we write pd.read_CSV, and then we write the name of the CSV file. So in this case, the name is population, and I'm gonna use this population_total.csv. So I pressed tab to get this the name. So we have now the name, and now I'm gonna assign this to a new variable. So the variable is gonna be df_population_row. So this row data, and now we're gonna have a first look at this data set. So I paste this, and now I'm gonna run this too. And now we have this data frame. So here, as you can see, we have the population of many countries throughout the years. So for example, we have China here, United States, and India. So we have the population, and here I wrote the name row because this dataset was extracted using some web scraping techniques, and then it wasn't modified. So now we have to make some changes to reshape this data frame so we make it easy for us to make visualizations with pandas later. So what we have to do here is to make a pivot table to reshape this data frame, and that's what we're gonna do here below. So we're gonna make a pivot table, and we're gonna use the pivot method. So as you might remember, the pivot method returns a reshaped data frame organized by given index column values, but it's a pivot without aggregation. So this is what we want. So we only want to reshape this data frame. So we're gonna start by dropping null values. So we do that by writing the name of the data frame, and now I'm gonna just copy the name and I paste it here. And now to drop null values, we have to use the drop NA method. So I write drop NA, and then we have to run this. And as you can see here, we have the result, and it's a copy from this data frame. But if we want to save the changes that we make to the data frame, we have two options. The first option is to use the in place argument. So I write in place and then set this to true. So if we do this and we run, all the changes that we make to the data frame are going to be saved. And the second option is to do something like this, to overwrite the content inside this data frame. So we do something like this. We write df underscore population underscore row is equal to the same data frame, but that drop NA. So we're overwriting the content inside this data frame. So I'm gonna choose the first option just to reduce some code. So I write in place equal to true, and now I run, and this new data frame shouldn't have any null values. Okay, now it's time to make this pivot table. So first I'm going to show you what I'm going to do so we have a better idea before writing the code. So here we have the original data frame, and what we're going to do is to reshape this data frame. So I want the year to be in the index. So the year column, I want it to be here in the index instead of 0, 1, and so on. And then I want the country column, or the values inside the country column, I want it to be here in the columns. So for example, I want China here in one column, then United States in another column, and then India in another column. And I want the population data inside the data. I wanted this to be the only data here. So to do that, we have to use the pivot method, and that's what we're going to do here below. So let's do it here. So first we have to write the name of the data frame, which is this one, and then write dot pivot. Then we open parentheses, and here let's see the arguments that this pivot method accepts. So I press Shift and Tab to get this helpful, let's call it cheat sheet. And now we have the arguments that this pivot method accepts. So first is the index, then the column, and then the values. So as I told you before, the index, I want it to be the year column. So we have to write index equal to, open quotes, and I write year. Then comma, and let's check another argument. So the next argument is the columns. So I want the columns to be the country, so the data inside the country columns. So here I write columns, then I open quotes, and here I write country. So country. And now the last one I think is values, and yeah, it's values. So I want the values to be the population data. So let me see if that's correct. And yeah, it's here. So population, and I'm going to press enter here so it looks much better. And now population is here. So I have the three arguments, the index, the columns, and the values. And now I'm going to reshape my original data frame. So here I press Control Enter. Now, as you can see here, we have the countries in the columns. So here we have many countries. It's from the first country, Afghanistan, to Andorra, Argentina, Uruguay, and many other countries. So we have also the year. So it's here, the year from 1955 to 2020. So we can see here the evolution of the population throughout the years for all the countries in this data set. But as you can see, there are many countries. So what we can do here is to select just some countries so we can simplify our visualizations later in pandas. So here I'm going to select some columns, but first I'm gonna name this new data frame. I'm gonna give it a name. So I'm gonna name it df underscore pivot. So this is my new data frame. Now I'm going to rearrange this, and now it looks much better. So now I'm going to run this, and now let's select some countries. So I copy this pivot data frame, and now we open square brackets, double square brackets to select 2 or more columns. And here, let's write some countries. So first, United States. Then let's say India. Then China. 2 more countries, Indonesia. And last but not least, Brazil. So here we have the 5 countries. So I run here and we have these 5 countries and the population from 1955 to 2020. So great. Now we simplify this data frame. And now I'm going to overwrite the content inside the data frame, df_pivot. And I'm going to write here, df pivot equal to df pivot and with this selection. So I'm overwriting the content. So I press Control Enter and our new df_pivot is here. So we have it here and now I'm going to show it to you. And this is our new df_pivot data frame. And that's it. Now our data is ready. So we can use it to make great visualizations with pandas. And that's what we're gonna do in the next video. Okay, now it's time to make some visualizations with pandas. And here I have the data frame that we created. This is the pivot table we created in the previous video. And as you can see here, we have 5 countries in the columns. And here we have the year in the index from 1955 to 2020. So what we're going to do now is to make our first visualization. So I scroll down here and the first one is going to be line plots. So here first, to make this visualization, I'm going to copy the name of the data frame and I paste it here. So now to make plots with pandas, we have to use the plot method. So we write .plot and now I open parentheses. And one necessary argument we need to introduce is the kind argument. So I write kind now equal to, and here I have to write a kind of plot we want to make. So in this case it's a line plot. So we write line, and this is actually the mandatory argument we have to introduce here. And now we can run this code. So I press Control Enter. And as you can see, here I have the line plot. So in this line plot, we can quickly see the evolution of the population throughout the years. For example, China and India, which are green and orange lines, they had some fast growing population, while United States, Indonesia, and Brazil, they have a lower population, and also the population didn't change so much in the past 50 years. Here we can add more arguments to this plot method to customize this line plot. So here we can introduce another argument, which is the X label. And this X label is what you can see here. Here, when we created this line plot, by default, it was assigned this year label, but we can change it. So for example, let's say we want to write year, but now with capital letter. So we write year here. And now let's say we want to add a new label here in the y-axis. So here we have only to write y label and then equal to open quotes. And here we have to write the name we want. So in this case, I'm going to write only population. And finally, we can also add a title. So we can add any title we want. In this case, I'm going to write, the name of the argument first, title, then equal to, and then the name of the title is going to be, let's say, population from 1955 and to 2020. So this is the title. So let's run this. And now, as you can see here, we got the title, population, 1955 to 2020, and the X label and Y label were modified too. Finally, we can add one more argument. In this case, the argument is the size of the figure. So to change the size of this figure, we can add the argument named fig size, and this is a tuple, so we have to open parentheses. And now to edit the size, we have to add two arguments. The first is the size of the x-axis, and the second the size of the y-axis. So in this case, I'm going to set it to a and then 4, which means that the x-axis is going to be large, while the y-axis is going to be short. So here I'm going to run this code and let's check it out. So here the figure has a different size, and that's how you can customize this line plot. Okay, now let's make a bar plot with pandas. So the first thing we have to do is to select only 1 year. So the bar plot only accepts just 1 year, and we can plot there the population of different countries. So let's select 1 year of this data frame we have before. So I'm gonna copy the name of the data frame so you can check it out again. So this is the data frame, and we're going to select 1 year. So to do that, we have to use the index attribute and then the isIn method. So first I'm going to show you the index method in case you don't remember. So here the index attribute allows us to see all the index in this data frame. So we have here from 1955 to 2020. So that's what the index attribute does. And now if we use the isIn method, we can filter out some index. So here, let's say we want to select only the 2020. So I copy 2020. And now here I write equal to, and first I'm gonna make the selection. So it's here. And now I'm going to show you what's the result. So here I press Ctrl Enter, and the result is this little data frame that only contains the population in the year 2020. So this is important because the bar plot is supposed to show only the population in this year. So here we have it, and now what we're going to do is to name this data frame. So here we write equal to, and then let's give it a name. So I'm going to name it df_pivot_2020. So here I press Ctrl Enter, and now I'm going to show this new data frame. Well, again here. And here one little detail I have to tell you is that when we make bar plots, we have to put text data in the index. So here the name of the countries should be in the index. So to do that, we have to use the transpose method. So this transpose allows us to switch rows and columns and vice versa. So here we can easily do that by writing the data frame, the name of the data frame, and now .t. So if now we run this code, we can see here that we have this. So now the year 2020 is in the column and not in the index anymore, and the country names are in the index here. So this is the format we need to have before making the bar plot. So now I'm going to overwrite the content in this data frame. So I write df_pivot_2020 equal to this same data frame but .t. So here I run this, and now it's time to make the bar plot. So here I copy the name of the bar plot, and now I use the plot method. So I write plot again, open parentheses, and the first argument is the kind. So I open quotes and we write bar. So now it's ready and we can run it. So as you can see, we have a basic bar plot, and it has some default values like the name of this X label, and also the default color is blue. And we can customize this bar plot a bit more. For example, I want a different color, so I write the color argument and then open these quotes, and let's say I want it to be orange. So I write orange, And also we can change the X and Y label. Actually, I can copy this here so I can save some time here. So X label and Y label are here, and let's paste it here. So X and Y label. And finally, I can add also the title, which was here. So I copy and paste it. But in this case, the title is a bit different because in this case, it's not from 1955 to 2020, but it's only 2020. So here I have only 2020. And now let's run this to see the results. So you can see here, we have a title, the X and Y label, and the bar plot is in orange. So that's how you customize the bar plot. All right, so far so good. Now let's go one step further by making bar plots grouped by n variables. So here we have to select a group of years to make these bar plots grouped by n variables. So I'm going to copy this code we used before to select only the year 2020. I'm going to copy this. And in this case, I'm not going to select only one year, but a group of years. So let me show you here. Instead of choosing only 2020, I'm going to show you the pivot table again so you can easily understand. So instead of choosing only 2020, I'm going to choose some other years here. So I'm going to delete this and I'm going to write it here. So let's say 1980, 1990, then 2000 and 2010, and well, finally 2020. So we have a group of years here, and we're selecting this using the index and is_in method. So here I'm going to give it a different name. In this case, since it's a sample, I'm going to write df_pivot_sample. Now I'm going to show you this one so you can see what this looks like. So now we have 5 countries and now 5 years. So now I'm going to assign this to my data frame. So df_pivot_sample. I run this and now we have this new data frame. So it's time to make this grouped bar plot. So here we write the name of the data frame and then the plot method. So we write that plot. And now let's add the first argument, which is kind and equal to bar. Now we run this, and as you can see here, we have the plots or the bar plots grouped by year. So here's 1980 and 1990 and so on. And you can also add the same arguments we added here. So for example, I can add the X and Y label. So I can do it here. I'm gonna do it fast. So here I run, and as you can see here, we modify the X and Y label. And that's it. That's how you make bar plots with pandas. Okay, in this video, we're gonna learn one of the most common charts that we can make in pandas and actually in any other visualization tool. And these are pie charts. So before we make this pie chart, first let's give a look to the data frame we're going to use. And in this case, to make a pie chart, we're going to use the same data frame we used for making the bar plot because it follows the same logic. So here I'm going to copy the data frame we created for the bar plot, which is this one, df_pivot_2020. So this is what we created before by using the index attribute and the is_in method. So here I'm going to copy this, and now I'm going to show you here so you can remember what's inside this data frame, and it's here. So here, as you can see, we have the column 2020 and the countries are in the index. So everything is fine. That's what we need. That's the format we need for making the pie chart. But there is one little thing we have to modify, and this is the column name, because now it's 2020 and this is a number. It's actually, I think it's an integer. So it's not a good practice to have numbers in columns. So what we have to do is to make this a string. And to do that, we use the rename method. So we write that rename, open parentheses, and now we use the columns argument. So we write columns, then open these curly braces, and now we write the name of the column we want to change, which is 2020, and we're going to make this integer value into a string. So we open quotes and write 2020. So apparently they are the same, but the green one is an integer and the red one is a string. So now to save these changes, I'm going to write in place equal to true. And I'm going to run this. So now we can make the plot. Here I'm going to write the name of the data frame. And now I'm going to use the plot method. So here I write that plot. So the first argument is kind. And here I write pi. So the kind is pi. And now I run this. And here I forgot to include the y argument. And I'm going to write it here. So the y argument is supposed to have the data. So in this case, I'm going to show you here again the data frame. So the data is here in 2020. So we should write here 2020. So I'm going to delete this. And here in the y argument, you write the column that has the data. So that's what we did. So now I run this. And now we finally have our pie chart. So here is the pie chart. So that's how you make a pie chart. If you want, you can even add another argument like the title. For example, here, I can say that this is the population in 2020, but in this case in percentages. So write this, and now we have this title. So that's how you make a pie chart in Pandas. Okay, in this video, we're gonna learn how to make box plots with Pandas. A box plot is a graph that shows us how the data is spread out. And the box plot shows 5 important numbers. First, it shows the minimum score of the data, then the first quartile, also known as Q1, then the median, then the third quartile, also known as the Q3, and finally the maximum value of the data. Okay, now let's make this plot in Pandas, and we're gonna use the data frame that we created before that is named df_pivot. So here I have it, and I run it so you can remember what this data frame looks like. Okay, let's start by making a single box plot, and then we're gonna make multiple box plots. So here, since we only wanna make a single box plot, I'm gonna pick one counter here. So here I write df_pivot, open square brackets, then quotes, and then write the name of the country. So in this case, United States. So now to plot this box plot, we only have to use the plot method. So here we write .plot, open parentheses, and as usual, we have to write the kind argument. So here, kind equal to, and in this case, it's gonna be equal to box. And that's all we need. So now I run this, and as you can see here, I have the box plot. And here we can add more arguments to customize the box plot. For example, the color argument, I'm gonna set it to green. And also I'm gonna add a Y label, and this one is gonna be equal to population. So I run this, and now we have this label in the y-axis, and the box plot is green. And as I mentioned before, this box plot contains 5 important values. So the one we have here is the minimum value, and this one is approximately 1.7. Okay, then the one I'm showing right now is the Q1, also known as first quartile. It should be here 2.2. Then this one here in the middle is the median, and this one should be 2.7. And the one here is the third quartile, so Q3. And this one is the maximum value in the data. All right, now let's make multiple box plots. So here I'm going to write df_pivot. And in this case, I'm not going to select a specific country because we're gonna make multiple box plots. So we're gonna get one box plot per country. So here I just write df_pivot and then dot plot, then parentheses, and now the first argument is kind, and here I'm gonna set it to box. So now I can run this one, and as you can see here, I got 5 box plots, and each of them represent one country. Here, if we want, we can add also the color argument equal to green, and also the Y label argument. In this case, I'm gonna set it to population. So as you can see here, the box plots are in green, and now we have the population label. And that's it. In this video, we learned how to make box plots with pandas. Alright, in this video, we're gonna make a histogram with pandas. But first, let's see what's a histogram. A histogram is a graph that organizes a group of data points into ranges. In the graph, these ranges are represented by vertical bars, and they show the frequency distribution of the data. Alright, now let's make this histogram, and here I'm gonna use the df_pivot data frame. So here it's this data frame, and here we can choose any country to make its histogram. So I'm gonna choose here Indonesia, and I open square brackets and write the name here. So now I write dot plot to make the histogram, and here I add the kind argument. So I set this equal to hist, and then I can run this to make the histogram. So I run, and here I got the histogram of the country Indonesia. But that's not all. Here we can make multiple histograms in this plot. So here I add square brackets, and now we add one more country. So here I'm gonna write United States, and now I'm gonna run this. Here I wrote incorrectly, so I modify, and now I run again. And here we got a histogram of Indonesia and United States. And that's it. That's how you make a histogram using pandas. In this video, I'm gonna show you how to make scatter plots in pandas. Scatter plots are used to plot data points on a horizontal and a vertical axis in the attempt to show how much one variable is affected by another variable. In this example, we will plot years versus population, and we will see how much the population is affected by the year. So to do that, I'm going to use the data frame that we had at the beginning. So this data frame that we got after reading this CSV file, and it has this format with country, year, and population in separate columns. And this format is going to help us make scatter plots easily because each row will represent a dot in the scatter plot. So here, now I'm going to paste the value of this data frame, and now I'm going to make some little changes. So the first thing I'm going to do is to select some countries from this data frame. So to do that, I select the countries column. So I write country inside square brackets, and now I use the is_in method. So here is in parentheses, and now I select some countries. So I open the square brackets. And now I'm going to choose some countries. So United States, and also India, then China, Indonesia, and finally Brazil. Okay, I have these 5 countries, and now I'm going to set this to a new data frame that I'm going to name df_sample. So now I run this, and here I forgot to make the selection. So I'm going to select this data frame. So I open square brackets and write the same name of that df_population_row. And now we created this df_sample data frame. So let's see how it looks. So here I print it. And now we have this data frame, but now we only have 5 countries. And we reduce the number of countries because we don't want that the scatter plot is overpopulated. As I told you before, the rows represent one dot in the scatter plot. And if we have many dots, we won't be able to see the dots clearly. But with 5 countries is fine. Now that I have this data frame, I'm gonna plot this with dot plot. And now add the kind parameter. So kind equal to, and here scatter. Now the 2 other parameters we have to add are the x and y parameter. So here I write x, and then I write y. So here x and y. and this represents the values that are going to be in the X and the Y axis. So first, in the X axis, I want to show the year. So I write year. Now we have this one here, and now in the Y axis, I want to show the population. So I write population, and that's it. Now we can plot this scatter plot. So I run this, and here we get this scatter plot, and each dot represents a row in the data frame df_sample that we have here. Here we see that the dots follow a pattern, and this is not so good because scatter plots are much better when the dots don't follow a pattern. But I'm just making this scatter plot so you know how to make the scatter plot with the plot method. So now we can control the size of the dots. So here I could write S, the S parameter, and here let's write 80. So we make it bigger, and now we see that the dots are bigger. Also, we can control the color of this data frame. So I write here color, and now let's set it to green. And now let's see the result. So now we see that all the dots are in green, and this isn't so good because it's hard to recognize what category each dot belongs to. So for example, we don't know if this dot belongs to the country India or United States or Brazil. We only know that the year is between 1980 and 1990, but we don't know exactly the year. And also the population is between 1 million and 1.2 million, but we don't know exactly how much the population is for this dot. I could show you how to set different colors for each dot based on the category, but that will involve importing Matplotlib and also writing a for loop and more lines of code. Fortunately, there is an easy approach that helps us set different colors for the dots based on the category and also see the values behind each dot. And that's by making interactive visualizations. And I'm going to show you how to do that in the next video. Alright, so far we made a pivot table and many plots using pandas. And in this video, we're going to learn how to export the pivot table and also the plots we made with pandas. So let's start by exporting the plots we made with pandas. And to do that, first we have to import matplotlib. So we write import matplotlib.pyplot. And then we write as plt. So this plt represents this matplotlib.pyplot. So now we run and we imported matplotlib. And now we can use this plt to save the plot. So we write plt.savefig. And now we open parentheses, and here we have to write the name of the file we want to export. And here I'm going to write my_test.png. So this is the extension and this is the name of the file. And now before exporting this file, I'm going to show you something here. So probably you noticed that when we make the plots with pandas, we get these words here that says access subplot and all of this. So we can get rid of these words by using the show method. So we write plt.show with parentheses. And if we run this, we're going to export this figure and also we're going to get rid of these words. So let's try. So I run this, and as you can see here, all those words disappeared. And also we exported the figure to a PNG file. And now this file should be located in the same folder where you have this Jupyter notebook file. Okay, I'm going to open that file, but first I'm going to export the pivot table. So here I copy this df_pivot and I paste it here. And now to export it, we have to use that to_excel method. So we write to_excel, and now I open parentheses. And here we write the name of the file where we're going to export this pivot table. So in this case, I'm going to name it pivot_table.xlsx. So this is the extension of Excel and this is the name of this file. So now I run this and now the pivot table should be exported. All right, now I'm going to open the Excel file and the PNG file we created. So it's here, and here we have the plot we exported and also the pivot table. So as you can see here, the plot looks exactly the same as the one we created here with pandas, and the pivot table is the same. So I'm going to show you how the pivot table looks. And here is the pivot table, and here is the pivot table we exported. I open it in Google Sheets and looks exactly the same. And that's it. In this video, you learn how to export data frames as well as plots. Okay, in the previous videos, we learned how to make visualizations such as line plots, bar plots, pie charts, box plots, and more with pandas. But all of them were static visualizations. This is good, but sometimes you want to interact with your visualizations to know the data behind a line plot, for example, or to know the values behind this bar plot. This is not possible with the traditional visualizations that we have in pandas, but there is a library named Plotly that helps us make interactive visualizations in Python. Fortunately, this library works good with pandas. And in this video, I'm going to show you how to make interactive visualizations with pandas using Plotly under the hood. Okay, to easily create interactive visualizations, we need to install cufflinks. This is a library that connects pandas and Plotly, so we can create visualizations directly from pandas. In the past, you had to learn workarounds to make them work together, but now it's simpler. And you don't even need to learn the syntax to make visualizations with Plotly, but you can use the same syntax we learned so far to make visualizations with pandas, with some little changes. Okay, first we have to install the Plotly library. So to do that, here we write pip install and then Plotly. Remember that you need to add this exclamation mark to run commands from Jupyter Notebook. So this is a command and we're running this to install Plotly. So I press Ctrl Enter to run this. And now let's wait until Plotly is installed. So just a couple of seconds. Okay, I got the message that Plotly was successfully installed. And now that I have Plotly installed, I'm gonna install another library, which is cufflinks. And as I told you before, this library connects pandas and Plotly. So let's install this library. So I write this exclamation mark and then pip install, and then we write cufflinks. So CUFF and links. Now I run this, and here we have to wait a couple of seconds. Okay, I got the message that it was successfully installed, and now we can start making interactive visualizations with pandas. So here I'm gonna delete this cell and let's import the libraries that we need to make interactive visualizations. So first we import pandas. So import pandas as PD. Then we import cufflinks. So import cufflinks as CF. Then we have to import display and HTML from ipython.display, and this will help us display the interactive visualizations in Jupyter Notebook. So here I write from ipython.display and then import display, HTML. And finally, I'm gonna edit the default configurations of these cufflinks by writing cf.set_config_file, and inside parentheses I'm going to change some parameters. First, the sharing parameter, I'm going to set it to public. Then the theme, I'm going to set it to ggplot. And finally, the last parameter is offline, and I'm going to set it to true. By the way, here I'm using the ggplot theme, but you can choose any theme you want. You only have to write here the command cf.getThemes with parentheses. And here you will see all the themes. Here I didn't get it because I didn't import cufflinks as CF, but I'm gonna import it here. So I import, this might take some seconds because it's the first time. And now I imported these libraries, and now I run this, and here we get all the themes. So here is ggplot. This is the theme I'm gonna use for this video, but you can choose any theme you want. You only have to set it and then test it out and see if you like it. Okay, now before we make interactive visualizations, I'm gonna show you the syntax, which is similar to the static visualizations, but with some little changes. So let's say we have a data frame named df. So if we want to make an interactive visualization, we have to write the iPlot method, which is that iPlot and then parentheses. So this one looks similar to the plots we make before for static visualizations, but here is not plot but iPlot. So the I is for interactive and well, plot for the plotting that we're making. And inside you have to add the parameters, the kind parameter, which is similar to the static visualization. And overall, the behavior of this iPlot is similar to the plot method, but it will have some changes in the parameters or in the way it behaves. So let's review each visualization and let's see how the iPlot method works. Okay, to make these visualizations, we're gonna use the same dataset we use for static visualizations, and I have here the code, so I don't have to write it again. And this is the name of the dataset or the CSV file, population_total. And here we have the same data frame. So I'm gonna run and I'm gonna show you the data frame, so you remember how this one looks. So here we have the country, year, and population, and we're gonna make visualizations, but this time we're gonna make interactive visualizations so we can see the data behind the plots. Okay, now I'm gonna copy and paste all the code we used in the previous videos to make the pivot table, so we focus only on making interactive visualizations. Okay, here I pasted the code, and these are all the operations we made to get this df_pivot data frame. So we read the CSV file, then we drop some null values, make a pivot table with the pivot method, and then select some countries. So here I'm gonna show this df_pivot. So I run this one, and here we have this data frame that will help us easily make the interactive visualizations. Okay, now before we start, I'm gonna delete these 2 lines of code or 2 cells, and here I'm gonna start with the line plot. So I delete this one too, and here we start with a line plot, but this time it's gonna be an interactive line plot, so we will be able to see the data behind the lines. So here let's start by writing the name of the data frame, which is this one, so df_pivot, and then we write the name of the method, so that iPlot. So after this we write kind, and then we write the type of plot we want to make. So here is line, and now this is everything we need to make this basic line plot. So let's have a look. I'm gonna run this one, and here we got this plot, which is a bit big, but anyway, you can see clearly. And the cool thing about this interactive visualization is that if we point and drag this plot, we can see the data year by year. So here you see the population in China in 1970. Here in this blue line, you can see much better the numbers. And here we see the population in India in 1975. So here we can see how it grew over the years. And here we see the population in 2019. So this is cool because you not only see the plot, but you can see the data behind, and you get more detail about this line plot. Okay, now let's say we want to add some labels here, the X label and the Y label. So we can do this also in interactive visualization. So we can add some parameters to the iPlot method. So first, let's add the X label, but in this case, the X label that we had here in the line plot, here, this is the static visualization we made previously. Here, the parameter was called X label, but now in the interactive visualization, this one is called X title. So keep that in mind. So I write X title, and here I'm gonna name it years, and the other is gonna be population. So here I write years, and then Y title, and in this case is gonna be population. So now I'm gonna add a title, and here the title is just named title, and this one is gonna be named population, and I wanna add the years, so 1955 to 2020. So here it is, and I run this, and now we see the title, and also we see the years in the X axis, and the population in the y-axis. And that's how you make a interactive line plot with pandas and also with Plotly. Alright, before we move on to the next visualization, I want to show you this bar that comes with Plotly, and here we have different options. For example, we can download this plot as PNG with this camera icon, or we can make zoom. So I click here and let's see what happens. So now if I make this, so I made a selection and you see that we have more details in these years for these two countries. So here let's make another selection and we zoom in again. So here to zoom out, let me see how to do it. And I think I can do this with this zoom out button. So here I zoom out and we get this line plot, but now it's a bit smaller. And here again zoom out and we can see all the line plot, but now we have more years. So here we have 1940 and let's zoom in now and you can see now that it fits much better, but now it's too close. But you can control this much better with this zoom in and zoom out options. But also you can auto scale with this option here, so you get the line plot as it was before. And finally we got this reset axis, and let's see what this does. And I think this one fixes the axis position or the ticks position. But anyway, let's check another one. So the pan option helps us move in this plot so we can see other parts of the plot, as you can see here. And finally we have this produce with Plotly. If you click on it, this is going to send you to the Plotly website. So let's try it out. Here we see, yeah, the Plotly website. And anyway, those are all the options in this Plotly bar. And now let's make our next plot. So here I'm gonna make a bar plot. So I write bar plot, and now let's make this bar plot. And as you might remember, we have to make some changes to the original data frame to make this bar plot. And to avoid repetition, I'm gonna copy and paste those lines of code so we can focus only on making this interactive bar plot. Okay, now I have the code that helps us make this data frame df_pivot_2020 that we use to make the bar plot. And now I'm gonna run this code. And here, the first line of code helps us select only the year 2020. And the second one transposes the data frame, which means that we switch the rows and the columns. So here, I'm going to show you the data frame. So I print it, and here, this is the data frame. So with this data, we're going to make the bar plot. And in this case, it's going to be an interactive bar plot. So first, we write the iPlot method. So iPlot. And inside, we write first the kind parameter. This one is equal to bar. And then we're going to give it a color. So I'm going to set it to light green. Then I change the name of the labels, the X and the Y label. So I write X title equal to years. And then also the Y title. Remember that in static visualizations with pandas, this is called X label, but in interactive, this is called X title. So here I write Y title. And in this case, it's going to be the population. So with this, I'm going to run the code. And now let's see the visualization that we got. So this is the bar plot. But now if we select one bar, we get the value that it has. So for example, here in the traditional or static visualization, we only get this. So we don't know how much population India has in 2020. We can say that the population in India in 2020 is approximately close to 1.4 billion, but we don't know exactly how much is the population. But if now we select the India bar in this interactive visualization, we get that the population is 1.38 billion. And we can see also the other countries. So for example, United States, 331, and China 1.43 billion, and so on. In this case, it doesn't make so much sense to use the zoom in or zoom out. So now let's move on to the next visualization, which is making bar plots grouped by two or more variables. Okay, here I pasted this code that selects some years. So the years between 1980 to 2020, and we're going to use these years to make multiple bar plots. So here I run. And now I'm going to show you the df underscore pivot underscore sample. So is this one. So now we have multiple years, and this is going to help us make multiple bar plots. So now I write the iplot method. So here I write .iplot, then the first parameter is kind, and I set it to bar, and let's see how this one looks. So here I have these multiple bar plots, or bar plots grouped by 5 variables. Here we can see in detail the population of each country in the year we want. So let's pick this one. So it's India in 2020 and it's 1.38. Let's pick one more, and for example this little one, and it's United States in 1990. The population was 252 million. Okay, so far we made interactive bar plots and also interactive line plots. And you can argue that maybe it's not so useful to make interactive visualizations in bar plots because the detail is not so much. I mean, you only get one value, but maybe in line plots it's more useful because you get more values behind one line. And the next visualization we're gonna see is more relevant when it's interactive. Okay, the next visualization we're gonna see is the pie chart. And here I have this first line of code that helps us change the name of the column 2020. So here I run this one. Now let's make this interactive pie chart, and then I'm going to explain you why I think this pie chart is more relevant when it's interactive than when it's static. So first I copy this data frame, and now I'm going to use the iplot method again. Here I added the kind parameter, and now I set this equal to pi. Then I'm going to set the values equal to this column that is 2020. So now I write 2020, and now this pie chart is ready. So I'm gonna run this one, and here I got an error because I forgot to add the labels. So I'm gonna add the labels parameter. So labels, and here equal to, and now I'm gonna show the df underscore pivot underscore 2020 data frame, and here the labels is the country because here we have the names of the elements in this pie chart. So here I write country, and this is also our index. So here country, and now I run this, and I forgot to mention that we have to set this country as a column. So here, unlike the plot method for making pie charts, we need to set this country index to column. So in the plot method, we could make this pie chart with this country as index, but in the iplot method, we need to set this country index as column. And to do that, we have to use the reset underscore index method. So here I'm gonna do this. So I write dot reset underscore index parentheses, and here you see that the country index is not anymore an index, but now is a column. So now to save the changes, I'm gonna overwrite the values in this data frame. So now I run, and let's see the results. I'm gonna run this iplot method, so to make the pie chart. So I run this, and now we verify that this labels parameter only accepts columns and not indexes. So keep that in mind. This is a difference between the iplot method and the plot method. Okay, now we have the pie chart, and we can see in detail the percentage that each element takes. So for example, India takes 37.9% and the US takes 9.1%. So this is helpful, so we can see in detail the percentages. And here in the plot method, it wasn't possible. We could add a parameter that shows the percentages in each portion, but that might require more lines of code. But in this interactive visualization, we got this with the same lines of code. And to make this even much better, we can play with the visualization, so we can hide some elements. For example, I want to hide India. So if I hide India, we only see the United States, China, Indonesia, and Brazil. And also the percentages were calculated again. So all of them sum 100% because we're not considering India as an element. So let's show India again, and now let's hide China, and let's say also India. And now we see in detail the proportion between these three countries without considering the countries with the largest population. And you can play as you want with this interactive pie chart. And this is something you cannot do with the static pie chart. So this is one of the advantages that the interactive pie chart has over the static pie chart. Okay, if you like this interactive pie chart, I think you're gonna like even more the next visualization. Okay, the next interactive visualization is box plot, and this interactive box plot is way better than the static box plot because we can see in detail the parameters that the box plot has. For example, the Q1, Q3, the minimum value, the maximum value, and the median. All of that we cannot see on the static visualization, but on an interactive box plot we can easily see by just pointing at those values. Okay, now let me show you how to make a box plot. So first we write the name of the data frame, which is df_pivot. Let me check it here so I don't make a mistake. So yeah, it's df_pivot, but unlike the previous plots, we're gonna select only one country. So we make only a single box plot. So here I write df_pivot, and now I'm gonna choose the United States country. So here, United States, and now the D, and here I'm gonna use the iPlot method. So the kind parameter is gonna be equal to box, and here I'm gonna plot it, and let's see the result. So here we have this box plot, and also if we point at this box plot, we automatically get all the values of this box plot. So we can see that Q1 is 219 million, the Q3 is 323 million, and we also see the maximum and minimum value. In this box plot, we don't have outliers, so we don't see the outliers, but if we had outliers, we will be able to see the values of those outliers too. Okay, now to move on to making multiple box plots, I'm going to customize this box plot much better. So here I write color, and now let's change the color to green. And also let's add one more parameter. So also I'm gonna add a title for this one. So y title equal to, and this is gonna be population. So now we run, and now we get this box plot, and we see that it's green, and also that the y label is population. Great, now let's make multiple box plots, and let's do it below. So here I write df_pivot, now I plot, and here the kind parameter, so again box. Now we write the y title to add a name for the y-axis. So this one is going to be population, and now let's run this and let's see the results. So here we see the 5 box plots, and each of them represent one country. So here we have United States, India, and all the countries, and we can see in detail all the values that correspond to these box plots. And this is cool because in the static box plot you will have to calculate those values on your own, following some equations as I'm going to show you in some videos. But with interactive visualization you don't have to do that. You only have to point at the box plot and you immediately get the values you want. Okay, now let's make interactive histograms. And to do that, first I'm going to write the name of the data frame, which is df_pivot. Now I select one country, so in this case United States again. So here I have United States. Now I use the iPlot method, then I add parentheses, and the kind is going to be equal to hist for histograms. Now I add a label for the x-axis, and this is x title, then equal to population. Now I run this and we get this histogram, and we can see the values inside each bin. So the first one has 3 values, as you can see there. The second one has 4, the third one has 4, and the last one has 7 values. So here we can control also the number of bins. We only have to add the bins parameter and now set it equal to a number we want. So now let's say we want 3 bins. So I write 3, now run. And instead of having 4 bins as we had before, now we have
3 bins. So the first one has 3, the second one has 8, and now the third one has 7. So we rearrange these bins. Okay, now we can add even one more histogram. So we make multiple histograms in this one plot. So here, the only thing we have to do is to add one more element to this selection. So I add one square bracket, and here I add one more country. So in this case, let's add Indonesia. So Indonesia here. And with this, we should get 2 histograms in this plot. So let's run this. And now you see here that we have 2 histograms. And the cool thing about interactive visualizations is that we can play also with this plot. So here I can hide Indonesia, and also I can hide United States. So we can see the histogram we want. And this is something you could do also with the box plots here. With the multiple box plots, you could hide any value you want it. So you only focus on the country you want. And this is very cool because this is not possible with a static visualization. Finally, we're going to see a plot that is more relevant when it's interactive. And I'm talking about the scatter plot. This one is more relevant because in the static scatter plot, you don't see the values behind all the dots that are in the scatter plot. But in an interactive visualization, you can see the values of all the dots that are in a scatter plot. And now I'm going to show you so you understand much better this. So first, df underscore pivot, so this data frame. And now I write the iplot method, so that iplot, and here the kind parameter as usual equal to scatter, so double T. And now I add the mode. In this case, it's going to be markers mode. So I run. Now I scroll down, and now we have the scatter plot. This one looks like a static scatter plot, but now if we select any dot, we will see in detail the value behind a dot. So for example, China in 1985 had 1.07 billion population, and we can see all the values behind all the dots in this scatter plot. Again, you can hide any country you want. For example, I only want to show Brazil. So here I have the scatter plot of Brazil, and this scatter plot of population doesn't make so much sense because this follows a pattern, and usually scatter plot is useful when the data doesn't have a pattern. But still, I think you get the idea of the usefulness of interactive scatter plots. And that's it. In this video, we learned how to make interactive visualizations with pandas. We learned the advantages that interactive visualizations have over static visualizations. And also we learned the differences and similarities between the iplot and the plot method.